Good morning. Thanks, everyone, for having me at the Azure Community Conference 2021. Definitely excited to be here. I am coming to you all from my home in just outside of Richmond, Virginia, in the United States. It is a little early in the morning or late at night, depending on how you look at it. And I'm still proud to be here to chat with you all today. I want to take a quick moment and thank the sponsors. Without sponsors, events like this are certainly not possible. So thanks a bunch to all the organizations and companies who have helped put this together. This is me. I am Scott Ford. I'm the co-founder and chief code whisperer of Corgi Bytes. We're a small consulting firm that focuses exclusively on helping teams make improvements to existing software systems. That's what we like doing. We like paying down technical debt and things like that. And that is a little bit about what I will be talking about today, is taking a monolith legacy application and moving it into the direction of Kubernetes, specifically talking about a time that my team did this for an application. And we actually ended up taking it to Kubernetes in Azure. So we'll be talking a little bit about that. So, one thing that we've discovered over the years with legacy applications is that many teams are, often hesitant to take an existing application that is kind of seen as relatively stable and, introduce newer technologies into it. Kind of the idea is that, if it's not broken, then don't fix it, kind of thing. And then also, there's often a sense of it being safer to try new projects, to try new technologies on newer projects. There are a few other excuses that we run into a lot. One being that the app just isn't in the cloud yet. So, what's the point? There's no value in trying to adopt Kubernetes if the application isn't in the cloud already. There's definitely a lot of criticism about Kubernetes being really complicated, and I think this is somewhat valid. Kubernetes is a rather complicated set of technologies, and it can be very difficult to kind of get your brain wrapped around those and figure out the best way to make use of them. Container orchestration is just too new or too buggy or insecure. There are a lot of people who, feel that, containerization is something that's just not quite ready for production applications yet. Similar to the too complicated issue is the idea that it's too much. It's way beyond what the application needs at the moment, and all of the extra work that goes into orchestration, isn't really needed and won't provide a whole lot of value. There are a lot of organizations that feel like they can only adopt Kubernetes when they have microservices already, and kind of the benefit being that that the benefits of containerization and orchestration specifically on Kubernetes really only comes to bear when you have an existing set of microservices. The idea that the organization that you're working with, or the application that you're currently working on, is just unable to adapt to the approach of using Kubernetes. That's an objection that I think comes up quite a bit. And then finally, the one that we're going to kind of dive into in more detail and kind of look at actually how to tackle the problem is the complaint that the application is just simply a monolith, and so why bother? So first, let's talk a little bit about monolithic applications and kind of the definition of that, if you're not familiar with the term already. The idea is that a monolithic application is one very large application that is fulfilling many different needs all at once. And this has kind of been a very traditional way to build web applications for quite some time. And it's definitely a very easy way to get started. Is to build one application, and as you add new features, you add those features into the application as you go. So let's look at some of the reasons that you might want to containerize even though you are working with a monolith. A big one is consistency. So even if you're working with a monolith, by moving your application so that it runs inside of a container, you start to get some consistency and predictability about the environment that your application is running within. The dev team has a lot more control over what dependencies are installed inside the container, the exact versions of different libraries that might be provided by the operating system layer, different packages from various package managers, different versions of language runtimes, things of that sort. You gain all those benefits when you run inside of a container, and you don't have to worry as much about the classic "it works on my machine" problem, where the production environment doesn't look very similar to the other environments that you might be working with, whether it's the local developer desktop environment or a staging environment or a testing environment, things, other non-production environments, or even, some organizations might have other production environments, such as like a demo environment that doesn't have actual customer data in it, but can demonstrate the purposes of the application. By running inside of a container, you gain some confidence that the exact binaries that are running in production are also running in all of these other places. Redundancy becomes quite a bit easier because you can just spin up another container. That's definitely possible. There are some challenges that you need to work around, and we will talk a little bit about those later. But kind of the idea is that you can, if you've got your application running in one container and you want another one, just start another container next to it. And then put some load balancer in front of them and route traffic that way. Portability becomes a lot easier, whether you are running on bare metal hardware or you are utilizing a cloud vendor such as Azure here, AZConf, or you want to make sure that you've got the flexibility to explore other cloud vendors, or you want to make sure that, kind of going back to the redundancy, if you want to have a strategy of your application, maybe having a primary cloud vendor, but also having a backup cloud vendor in case the primary cloud vendor has an outage, you get a lot more predictability around that portability with being able to run your app in lots of these different environments. And then it also gives you the flexibility of choosing which of those environments makes the most sense for your different, your different tiers, your deployment tiers. So whether it be production or staging or test, you have a lot of flexibility for those. Deployment becomes much more predictable. You no longer have to, have a complicated set of deployment scripts that run inside of each environment. Instead, that complicated set of deployment scripts is what's used to produce the container itself. And then the deployment of that container becomes much simpler into all the different environments. It also gives you a chance to kind of codify the deployment environment as code itself. So the deployment environment becomes something that gets described as code, same way that you might describe any other kind of code or assets on your application. And then another benefit of containerization is it makes it easier to start to decompose your application into other containers. So you can start to, you can start with a monolith and start chopping up various bits and pieces. And having the flexibility that you gain with containerization, it makes it a lot easier to perform experiments, to do A/B tests, things of that sort. Largely by taking advantage of the features that cloud platforms like Azure provide you. So that all sounds great. Why isn't everybody doing it? So we're gonna go through an example, and this is kind of using. I won't be talking about the specific client that we worked on, but I will be talking about kind of the state of the application that we took from a bare metal environment up to the cloud, specifically on Azure. So in the pre-migration state, the application was being built and unit tests were being run via Jenkins. Source control was inside of Git, and then the servers were running Apache PHP with a load balancer in front of them to balance traffic between the two. Data was being stored in a combination of a SQL Server database and a network file share. The network file share was being used for static assets such as PDFs that were generated, images, things like that. Whereas the SQL Server database was used for storing the transactional relational data that the application was working with. So the first step that we took was to set up Docker just for the local development environment. And a lot of the benefits that we get from this are gonna look really similar to the benefits that I talked about for containerization in general. Probably the biggest win comes in a much more consistent development setup. You can take a completely blank machine, and once you get Docker installed on it, if you put enough care and attention into the way your Docker file is constructed, a simple command, especially if you're using Docker Compose, you can get like one consistent command to bring up the entire environment on your local workstation. That is an incredible improvement over the local development environment instructions that I've experienced in the past, which has been a series of steps in a wiki, often out of date. It's usually the newest member of the team is the one who discovers all of the things that are missing or inaccurate in those in that wiki and in those instructions. As a result of that, onboarding becomes much easier. So if you do need to scale the team, if you need to add a new member to the team, the list of things that they have to go through, the list of things they have to work through, is much less. And this ends up acting as a form of executable documentation that consistently stays up to date because the team is using it frequently. So not only is it an executable document that documents the state of the system in terms of like how it's produced, here specifically for the development environment, but because it's something that the team is working with regularly, you know that it's accurate and it's a living document. It's something that's getting updated frequently and is getting worked with. So it's less likely to fall out of sync with what the developers are actually doing. So step 2 on this journey was to dive into the 12-factor application principles and really take advantage of them and kind of embrace them and start to adapt the application so that it worked in a way that was consistent with as many of these principles as possible. Really kind of tackling them one at a time. So I'm not going to go into these in too much detail. But there's the code base, which is the idea that you have one central code base that is tracked via revision control, and from that you can have many deploys. There are many teams that are already here. This is pretty much if you're using a source control system, you've got that kind of factor already checked off. Dependencies. You have a way to explicitly specify all of the dependencies for your application. So if you're using C# or in .NET world, this is as simple as having the NuGet packages that you're referencing listed in your CS proj file. If you're working with npm, this is the list of dependencies that are specified in your in your package.json file. It also extends beyond just the application runtime, such as say .NET or Node, but also down to the operating system as well. So if there's a library that you're using, whether it's something that's installed via an MSI, if you're working with a Windows container, or something that might be installed through a Linux package manager, such as Yum or apt-get, things of that sort, being able to specify those dependencies and get those declared down to the version numbers. So what version numbers of these packages does your application expect to be there? Configuration. So details about how the application changes. So what the URLs for external services it connects to, passwords, connection strings, ports, anything that might be variable or could benefit from being variable. You store that information in the environment, and by environment I mean it's meant as specifying them as environment variables. So with a containerized application, it's very easy to set those environment variables when the container is brought up. So if you have your code looking for those values from environment variables instead of looking for them from a just a config file, many application developers, especially in the .NET ecosystem, have been used to storing configuration values inside of a web config, and then having different web configs for different environments. So you might have a web config for test, and you might have a web config for production, you might have a web config for dev. So the idea here would be to move to one web config and move some of that variability across those three into environment variables, and then let the environment variable settings control that variability. Your backing services. So these are things like file storage. Start to treat those as things that are ephemeral. They are things that can be attached and they will go away. You aren't directly utilizing the file storage within the container. You're using some third-party service to store that information. So this could be a database. Many applications are already using them, but you don't have that database living inside the container itself. There's another service that the container is relying on that provides that database functionality. You clearly have separation between your build, release, and run kind of phases of deployment. So you build your application in building produces a kind of deployable candidate. So like a candidate binary for deployment. In the case of containerization, that's a Docker image file. You then release that. So releasing in the context of a Docker image, you push it into a package registry, and then when you run it, you then would configure your container runtime, such as Kubernetes, to retrieve that version of the container from the container registry and then run it. So you've got that nice clear separation of those three steps. The benefits there are again consistency and the ability to kind of go back a step and kind of repeat the process. So if you've released version 12 into the container environment and you realize that there's an issue with it, you can then choose to run release 11 instead. If you have detected an issue with a release, you can create a new build that potentially fixes it, create a new release from that build, and evaluate in a test environment whether or not the bug is fixed. And then you can choose to also run that release in production. You start to think about and decompose your application in terms of processes. So with the idea being that you kind of have move in the direction of having one process per container. So the for a web application, this would be that single process would be the process that's actually serving the HTTP requests. So the process that's listening to port 80 in the case of a public website on the default port. If you have some kind of worker application that is kind of processing tasks out of a queue, that would be a separate process. And so you start to decompose your application that way and kind of notice, what activities do you have that would require you to, in your dev environment to actually like start multiple executables. Each of those executables would be a separate deployable thing in production. And then also the goal there is to kind of move in the direction of those being stateless. So you would be able to restart any of those applications and they would be able to pick up right where they left off. Port binding, this kind of goes back to, this is a little, there's a little overlap here between port binding and configuration, because you can kind of think of port bindings as configuration. But your application has ports that it runs on, and then the production environment, or like the deployment environment, I should say, allows you to create a mapping between the port that's publicly available and the port that your application is running on. Concurrency, so having the ability to take the processes that are mentioned in step 6 and run multiple processes and not have that be a problem. So in the case of I mentioned having a worker process, if you need to process items from the queue faster, you should be able to add additional worker processes. Each one is then able to process items from that queue and get through the queue much faster. If the worker is designed such that it's the only one worker at a time is allowed to read and write from the queue, then that's something that you're going to need to address in order to really adopt the 12-factor application principles. Another challenge that shows up a lot with web applications is the way session information is stored. So often session information will be stored in the memory of the web server. So concurrency becomes an issue, because if somebody comes to your website and their session is created on process A, and then their next request gets processed by process B, then the session from A is not shared with the process, but the session is not shared between processes A and B. Each one gets their own session. So it can be, rather confusing, and information can get lost. So that kind of forces you in the direction of, using a backing service for storing session information. Disposability, there's a little bit of overlap here with kind of the process idea and also with concurrency. But the idea is that you want to be able to have any of your processes to be able to stop at any time, and also be able to start at any time. So if they've got any work that's in progress, there should be a way for them to very quickly save that off, so that it can be picked up when the process is restarted. This allows you to set up monitors for, memory usage or CPU usage, and then you can, restart a process to help kind of mitigate that problem. If, say, there's like a memory leak in the application, that is one way to mitigate those. Get really good parity between your development and production environments. Docker files and kind of Docker setup definitely really helps with this. But you want to make sure that you have as much similarity as is possible between all of your different environments: development, production, staging. All of those environments need to be as absolutely similar as possible, and that helps you avoid the it works on my machine challenges that I mentioned before. Logging, when you're working with a kind of a 12-factor app environment, logging is definitely your friend. As you start to add multiple processes and sometimes multiple copies of different processes, in the case of kind of adding scale and concurrency, knowing which process had a failure and kind of what series of events led to that failure, you can get more complicated. So having a single centralized location for all of your logs from all of your processes to go to becomes really important. And have that kind of be, that stream of time series log information be treated as a data item that your application is producing and is responsible for, for maintaining and treating appropriately. And then any admin processes that you need to run, such as, say, like migrate the database to add a new column, or if you need to, perform some kind of corrections. Say it's a financial system, and there was an error in the code that was doing a particular calculation, and now you need to go through every user account and basically add a correcting journal entry, sort of thing. It's a one-time activity that happens once. Or maybe there's like an ETL process that is exporting information from the system or ingesting information from an external system. Have those things run as separate processes that can be run by an administrator on demand, and then when the process is done, it stops. And that's especially helpful for both things that you're only going to do once, and for things that you might do on a schedule, such as like manage through, some task scheduling service, such as, say, cron, or, like over in Azure Functions, you can set up, processes to repeat over there as well. So I've kind of, already delved into these quite a bit. But again, once you kind of get an understanding of the 12-factor principles, really kind of lean in and focus on them. So again, double check your dependencies, make sure that you've got those set up. This is definitely like one of the first places to start. Like if you're like, wow, like all those 12 factors sound great, but how do I get started? Where's the most important place to start? This is definitely the most important place to start. Even before, and it's probably something that you had to start doing as you started exploring containerization. So being able to specify those dependencies that your application is depending on. Next up, if you have to, kind of prioritize, would be to start moving your configuration into environment variables. Next would be to move your processes in the direction of stateless. So avoid reading and writing directly to the file system, and instead use a service such as Azure Blob Storage for that information instead. So kind of the idea is that the file system may go away, or the file system will go away, and any information that you write to it, should be treated as purely temporary in nature. So if it's not something you'd be comfortable just storing in RAM, then it shouldn't be something you're comfortable putting on the file system. Some of the 12-factor principles that we went over are kind of built into Kubernetes already. So if you do decide to adopt Kubernetes, these are some principles that you kind of get for free. So disposability is really kind of baked into Kubernetes as a platform. The way orchestration happens, you're kind of getting disposability for free in that containers are created and destroyed as needed. Processes are started and stopped regularly by the orchestration engine. And you also kind of get development and production parity for free as well. The development and production can use the exact same container definitions, and there are projects that can help you run Kubernetes locally on your dev environment. So you can either within Docker Desktop, there's like a little checkbox to enable Kubernetes within Docker Desktop. Or if you don't want to use Docker Desktop, you can look at there's a project called Minikube, Minikube, and that can help you have a Kubernetes environment set up on your development environment on your local development computer as well. And so then the same Kubernetes setup scripts that you're using for that environment can be adapted to production as well. So next up on your journey of like moving in the direction of getting your monolith into Kubernetes is to actually kind of build out a proof of concept. So you've gotten a development environment set up and you've been able to experiment with some of these things. You've started to adopt some of the 12-factor principles, and definitely you've started with the most important ones. So next is to really dive in and start learning Kubernetes and learning how Kubernetes kind of works as an orchestration engine. There is a lot of terminology that you need to pick up when learning Kubernetes. I found it incredibly overwhelming when I first started diving in. You'll read documentation and you'll see words, clusters, pods, containers, controllers, services, replica sets, nodes, secrets, all sorts of terms, and it seems like as Kubernetes continues to evolve as a system and even an ecosystem, there are even more to learn. So diving in and starting to learn those, there is very thorough documentation that's provided by the Kubernetes project. It can be a little overwhelming. I think there are certain sections of it that seem to assume that you have a pretty big understanding of Kubernetes overall, and that can certainly be overwhelming and make it difficult to dive in and get started with Kubernetes. So if you learn better by watching tutorials or working through tutorials, seek those out. Find a video series to watch. Take an interactive course, and really kind of start to experiment and get used to these terms. Probably the next thing is to start really small. So your first attempt is probably not going to be. Sorry, your first attempt shouldn't be the monolith. So that big monolith that you've been working on. The first thing that you try to deploy into a Kubernetes environment is probably best being like the Hello World container, the official Hello World Docker container, or you can just build a very simple web page, like static HTML, CSS, and JavaScript application that you can deploy into a container. Something that's not going to have many or any really runtime dependencies or any any need for external services or file systems. Really try to limit the number of things that you have to get right in order to see it be successful. And then finally, experiment. Set up a local cluster, like I mentioned, using Docker Desktop or Minikube. Take advantage of Azure Kubernetes Service. It is very easy to set up a cluster on Azure Kubernetes Service and experiment with it. If you have Azure credits that, I know that with subscriptions that I get through employers for Azure or for Visual Studio Professional, I have credits that I hardly ever use. So you can start to take advantage of some of those credits and spin up some environments to just experiment with. And if you don't want to keep them around, then just delete them. And that's kind of what's really great about that environment. After you have done your experiment and you kind of want to move forward, the next thing that's important to start thinking about is cobbling together a CI/CD pipeline that is going to have Kubernetes for production as the destination. There is an almost overwhelming amount of choice for you to choose from. There GitHub Actions, Azure DevOps, Circle CI, CloudBees, Jenkins, CodeShip, Travis. There are so many CI/CD environments that you can utilize. So picking the solution that is going to work best for your team is always my recommendation. And that's often kind of starting with something you're familiar with or something that you already have, something that your team is already paying for. Start building and publishing container images. So taking the development environment that you created that was Docker-based, start to build those Docker images every time code is checked into the repository, and actually push that image into a container registry, whether it's Azure Container Registry or another container registry. There's container registry built into GitHub. Again, choose what works best for your team. Work amongst yourselves to figure out a strategy that you're going to use for versioning and tagging containers, so you can tell which container image belongs to a particular version of the source code. There are lots of different strategies, and there are pros and cons to each one. So read up on those and pick the one that's going to work best for your team's needs. And then, next would be to stand up a staging environment that is running Kubernetes and is running the containers that are coming out of the container registry, and compare that experimental staging environment to your existing production environment, or your existing staging environment, and test them out, see if they're equivalent. If you have an automated test suite that you can run against both, that's amazing. If not, use the same set of tests that you would do to validate a release, and check to make sure that everything's working in the Kubernetes environment that you would expect. And then finally, the big scary part, set the pipeline up to actually deploy to a production Kubernetes instance. It's usually a good idea to have this be something that's triggered manually. So the deployment to staging, teams are often pretty comfortable with that being automated, so that new code is checked in, a container image is created from that code. The container image is put into the container registry. Kubernetes notices that the container registry has been updated, so it then pulls down that container and then updates any pods that are running that container and restarts them with the new container image. That is something that a lot of teams are more comfortable doing in staging than they would be in production. And so it's usually a good idea to have that final step be one that is only done after you've taken a look at staging and you're like, okay, yes, this is good, and then you can kind of click a button to then instruct the production Kubernetes to also pull down the newer images for the the containers have been updated. And then from here, you really start to iterate and add layers. So one of the best first starts is to make sure that the ingress controller and load balancer is set up the way you like it, and start to take advantage of that. So this is shifting traffic off of your container as being the final destination for web traffic, in terms of say termination of HTTP certificate or something like that, HTTPS certificate or something like that. And instead you shift that responsibility to an ingress controller and a load balancer. The Azure Application Gate, there's an Azure Application Gateway ingress controller. So this partners the Application Gateway product that's provided by Azure with an ingress controller that runs inside of your Kubernetes environment and provides that load balancing support via the Azure Application Gateway. And then the ingress controller is routing traffic to the appropriate controller based on the request that's coming in. You can also set that up manually by just installing an ingress controller. And the benefits of that separation are that you can terminate your SSL certificates at the ingress controller instead of at your app, and then it's a lot easier for your application to go away and come back up without having to worry about certificates getting reissued and things like that. It also allows you to start experimenting with auto scaling. So once you've got that load balancer in place, and the load balancer is going to a single node, you can then start to experiment with the load balancer, working with multiple nodes. You can experiment with setting up auto scaling in the cluster. So based on different metrics that can be monitored. If the metric goes above a threshold, then you create a new node to start handling traffic. If then the metrics kind of dip down below a lower threshold, you can then stop and terminate one of those pods to kind of reduce the resources that you're consuming and the amount of money it's costing to run your application in the cloud environment. Next, look at how secrets are being stored, such as passwords, connection strings, things of that. Start taking advantage of Azure Key Vault as a Kubernetes secret store. It works really well at this. And then this will give you also the ability to start to take advantage of some of the features that are available in the Azure Key Vault, such as key rotation, being able to run reports on how old different secrets are, and can help with different levels of compliance depending on the environment that your application runs in terms of how well monitored security has to be for that level of a compliance. And then at this step, now you can start actually doing some of the fun and start to identify some some initial microservices that you can kind of carve out of your app. So if you're if it's a web application that has static assets, when you're running a monolith, it kind of made sense to have those static assets be inside the same container as the monolith. But as you start to move in the direction of microservices, when you create a copy of that container, you're also creating a copy of those static assets. So as you kind of scale out horizontally and add additional nodes, you're taking up additional space with these static assets that you know aren't going to change. So you can shift those static assets into their own container, and then the dynamic portions of your application, those are the ones that are more likely going to need to scale. The container that is just serving up static assets, every HTTP service, whether it be IIS or Apache or Nginx, those are all highly optimized for serving up static assets. That is something they do incredibly well, and they can handle a ton of load doing that before you have to scale them out. So then you can likely get by for probably the life of your application with only one pod running a static assets container, and then you can have multiple pods, running the more dynamic parts of your application. Authentication is another good one to move in the direction of, being run inside of its own container. So take the authentication endpoints inside of your application and start to move those into their own container. Excuse me. This then starts to give you the benefit of being able to add additional functionality that relies on being authenticated, but can be completely separate from the technology stack that lives inside of your monolith. So you could build a new portion of your application, say like a new admin panel or a new reporting system, and that could that feature could live at like /reports or /admin or say /reports. And those endpoints would be relying on the same authentication that's provided in the authentication container. And you're able to build those portions of your application, of your overall application, using technologies that are separate from the ones that you're utilizing inside of the monolith. This can be pretty helpful if you want to move in the direction of newer technologies, but the cost of upgrading the monolith is really high. So you kind of have that tension between wanting to use the newer versions of, say, .NET or a particular reporting engine, or maybe you want to experiment with another language entirely, such as using Go or Rust for handling some high performance applications, or maybe it's a data science need that you have, and so being able to leverage some libraries from the Python ecosystem would be really beneficial. It starts to give you that flexibility where you can kind of pick the right tool for the job, and still have that tool be restricted by the same set of users that the rest of your application is. And then next up is to look at how developers are getting access to the environment, and getting access to the cluster. So create a virtual private network around the cluster, and try to limit the amount of traffic that can go in and change the cluster. Utilize vulnerability scanning. There's a service called Cube Hunter by Aqua Security that looks for weaknesses in a Kubernetes cluster setup. It looks at for like misconfigured defaults, things of that sort. It's a really good thing to lean on. Sneak offers scanning of Docker containers themselves, and will let you know whether or not any of the packages that are inside that Docker container are vulnerable to any known vulnerabilities. And And then that can help you figure out whether or not you need to upgrade to a newer version of OpenSSL or things of that sort. Threat detection. This is a service that Azure provides that you can start taking advantage of via the Azure Advanced Threat Protection. And then also start standing up some end-to-end browser testing. My favorite approach is to, if you do have manual testers on your team, to have them do what humans do best, and that's go through and use their testing brains to try to find ways that the application is broken. If you have humans going through a set of instructions to test, instead of asking a human to do those instructions, automate those instructions, and then retask that human with trying to be creative about finding ways that the application might be working incorrectly. And then that will give you a lot more coverage in terms of testing. Humans are really good at finding those boundary conditions that might get overlooked as part of the automation testing. And then if something is found via exploratory testing, capture that failure as an automated test to help you monitor regressions in an automated way. So next is kind of really refining your deployment and monitoring as you go. Set up some kind of telemetry and alerting service. There are aspects of the Azure service ecosystem that can help a lot with this, both in terms of logging and alerting. And there's also lots of packages out there that can really help with detecting whether or not your system is under attack by denial of service, whether or not people are repeatedly attempting to log in, using a set of password, username and passwords that might have been published as part of a data breach, things of that sort. And have a fallback plan. Things are going to break. There are going to be aspects of this journey towards getting your monolith onto Kubernetes and start breaking it up into microservices. There are going to be things that go wrong. So plan for failure. Figure out what you're going to do if it doesn't work. Kind of at every step of the way. So anytime you make an incremental step forward, before you actually kind of click the button to execute that part of your plan, ask yourself, what are we going to do if this doesn't work? There are lots of valid answers to that. They tend to kind of fall into two categories. One being to revert and kind of go back to what was working before, and the other being to do your best to correct the problem as fast as possible. And so then you have you leave the application in a failing state, and you continue trying to iterate very quickly to get it to a non-failing state. And then you clean up, any problems or technical debt that you might have introduced during that rapid portion. On the revert side, you simply revert to the previous version of the application, and then kind of go back to development and test, try to replicate the problem that you saw in production, and then try to defend against it. There are pros and cons to both approaches. There are going to be times when, even if your team is used to primarily doing reverts, or primarily kind of failing forward, there are going to be times when it's going to make the most sense to adopt the other strategy. So try to be flexible. Look at your needs and take those into account as you're going along. So potential pitfalls that you're going to need to look out for. Kubernetes has a huge learning curve. I tried to touch on that a little bit earlier. And even just understanding the different offerings in the Azure ecosystem, there's so many different and amazing services that you can utilize inside of Azure, and many of them can be connected into the Azure Kubernetes service. But even just understanding those, when you would use them, why you might choose to use the Azure offering over another offering, making those choices can feel very overwhelming, and it's a lot to learn. There is a fair amount of complexity. Kubernetes does a lot for you, which is awesome. A downside of that is Kubernetes is doing a lot for you. So there's a lot to learn. There's a lot to know. So it's a very vast ecosystem that you have to get up to speed on. And there are many things that can be installed into your cluster from the community, and that can make it a little bit confusing as to whether or not the behavior you're seeing is something that was written by your team or something that was installed into your cluster via a Helm package or something like that. Other potential pitfalls: reliability and performance, finding the right balance of cluster size, number of nodes per pod. All of that takes a while to get used to. There's a lot of trial and error there, and then what you're seeing in staging might not match how things are going in production. Tooling, tons of new tools to learn. I never know how to pronounce. Is it kubectl, kubecontrol? I don't know. Helm, Customizer. There are tons of ways to set this up. There are some Kubernetes specific IDEs that can help a lot. So these are ways to kind of connect a graphical environment that you might be used to, kind of similar to Visual Studio or Visual Studio Code, but kind of connect it up to Kubernetes and then use that to kind of get an idea of what's going on inside of the cluster. But ultimately, where you want to land is something that looks a little bit like this, where things are much more decomposed than they were, and you end up utilizing a lot more cloud services on the Azure platform, and as a result, your application can usually handle a lot more load. You can have different development teams working on different parts of the system at the same time with less risk that they're going to be interfering with each other. And you can usually gain and benefit from a lot of the reliability that the different offerings from the cloud provider, Azure in this case, gives you. So that's it. I know I'm coming up on time. So if you'd like to get in touch, these are the other ways to do so. I'll put this slide up again a little bit later. Before I run out of time, I'd like to take a moment to thank the conference partners. Again, they are incredibly helpful for getting an event like this off the ground. And then also to the communities who have helped participate and promote the event. And I think I've run out of time for Q&A. So we're going to skip over that. But please do fill out the feedback. I definitely like hearing how you found this information, and so I can make improvements to it if I give it again later. Again, this is how to get in touch with me, and that's all I've got. So I see that there's 3 more minutes. So if people do have questions, you can put them in the chat, and I will do my best to answer.
Hello.
There we go. I hear you now.
All right, perfect. Thank you so much. Looks like the Bluetooth was the issue, but thank you so much, Scott. I guess there are not many questions today, but
It's
people
early.
would know that. Yeah, yeah. So they would contact you in case if there's any question on this topic. But
Yeah.
thanks once again, and a great hosting you at DaisyCon 2021.
Thank you. Thanks for having me, and enjoy the rest of your day. And good luck on the rest of the conference.
Perfect. Thanks everybody, and please stay tuned for the next talk from Mayur. Hey Mayur, good morning. Are you right there?
Hello, Elias. Can you hear me?
I can hear you. Thank you so much, Mayur, for joining AZConf Day 2. And the stage is yours.
Oh, I'm already live.
You are. You just need to share your camera so people can see you.
Okay, let me see if I can. So this is
You
my
can, of
setup.
course.
Sorry about this weird look.
No problem at all. You look
These are the
fantastic.
periods from these are the periods from working from home, by the way. So
That's, yeah. Virtue
you
of
may hear, yeah,
COVID-19 pandemic.
you may hear a baby crying, maybe pressure cooker going off. So yeah, please bear
That's our
with me.
pleasure. That's our pleasure.
Yeah, yeah.
Go ahead. Go
So,
ahead.
yeah, thanks a lot, Elias, for hosting me. Hello, everyone. Welcome to this Azure Community Conference, India's largest Azure conference. I was here last year as well, and I have seen a phenomenal, outreach over here. I have seen a lot of developers coming to this event, uh, and a lot of experts sharing their, expertise with developers. This has been a fantastic event. I simply love being over here. So let me just quickly, jump into my slides. Yeah. So a quick introduction. My name is Mayur Tendulkar. I work as a customer engineer with Microsoft India, and I focus on, the startup segment. So I help startups come on board on Azure. I help them with solution architecture. I help them on publishing their solution on Azure Marketplace. And yeah, the idea in a nutshell is to spread love about Azure, and that's why I'm also here today. So when we talk about this conference, today's topic for me is building SaaS products on Microsoft Azure. So I have provided my blog URL and my Twitter handle. Mostly I tweet about my frustrations, and mostly I write a blog post about the frequently asked questions. So you can find me over there. Definitely, if you have any questions, feel free to ask these questions, and I will try to answer these questions at the end of this presentation. This is a level 100 presentation. I don't have a demo, but I'm going to show you, or I'm going to talk to you about what different services that we have in Azure which you can incorporate, and when we are building a SaaS product, how we can utilize these services. So let's get started. So when we talk about the SaaS, which is software as a service, how the journey started, right? So when I started in 2000, two, I was writing a blog at that time. And the blog was, typically a ASP.NET website. At that time, ASP website I was hosting on my own Windows server. Later on, when the .NET came in, I used different vendors, cloud providers to host my application. But then I had to, handle the entire server patching, making sure, the software is up to date, my blog is up to date, and all that stuff. So the journey started from the hosted applications, and then it went through, the infrastructure as a service. Then cloud came in, and we had infrastructure as a service, then platform as a service, and now we are at the helm of, now we are using software as a service. Most of these tools, utilities that we see today are software as a service based. So when we talk about software as a service, okay, we have you can see the market at the Gartner research. So I have just got a screenshot over here. You can see the market is growing. The SaaS market is growing. But let me quickly give you an analogy when we talk about SaaS, what exactly it means. So when we talk about the SaaS model, right? So we have, I want to give you an example, right? So in India, everybody loves to drive a car. So when we think about going and buying a car, you have to think of it like an on-premises car. That means you have to buy a car, you have to think about the finance, you have to think about the insurance, monthly or semester servicing, the road tax. You probably also need to have a parking or a garage in your building so that you can safely park your car over there. And definitely you will need to drive a car by yourself and uh, face the frustration of Indian drivers probably. So this is the on-premises model. So that's fantastic. But then we also have uh, infrastructure as a service. So when we talk about infrastructure as a service, what is it? So it's basically leasing the car. So you go to Zoom car like services. You say that, hey, I just want to get the car and move from one place to other place. So you are not going to buy the entire car at this moment. So you are going to pay only for 2-3 days. You don't have to worry about the insurance, the road tax, anything. So it's like most of the things are taken care by the service provider. You have to just drive the car and pay for the fuel, pay for the if there is any maintenance, you have to pay for that. So think of it like infrastructure as a service, where you are just renting a car, leasing a car for a time being. Then we have something called as a platform as a service. Think of it like Uber, where Uber or a taxi or Ola, where you can just rent a car. It comes with a driver and it just takes you from point A to point B. So you are just paying for the travel and the convenience. You are not worried about the car. You are not worried about the finance of the car, the depreciation, the insurance, the road tax, the garage, nothing. So that's platform as a service. And then comes software as a service. What is software as a service? Think of it like public transport. So you go to railway station, you buy a ticket, you sit in the uh, train bogie, and then you go from one place to other place. That's it, right? You don't have to worry about anything, even so everything is taken care by that public transport. So that's the beauty of software as a service. And you can see most of the softwares that today we are looking at, be it from Microsoft or Amazon or Google, are moving towards the SaaS approach, the software as a service approach. For example, today, not today, couple of years ago, if I have to open a Word document or a PowerPoint, I have to buy an Office license, which might be costing me around like 5,000, 10,000, depending on license fee at that time. But now with software as a service, I can just use Office 365 just for a month, or I can go ahead and buy a family plan and I can pay only for that month or a per user per basis. I don't have to have the full capital investment over there. So that's the beauty of software as a service and where the industry is moving. So when we talk about building a software as a service solution, there are a couple of things which comes into the mind. So the first thing that comes into the mind is, how am I going to secure my software as a service solution? The best example, Office 365, you can see. So we have, Microsoft has this solution called as Active Directory, which used to provide, authentication for, laptops, machines, and applications, right? So when you start your machine, you just, log in with your domain slash your alias and then enter a password and enter, right? Similarly, now you can use the same thing for your applications as well. Maybe it's a payroll application, HR application, something that sort of. So behind the scene, that Active Directory you can think of is available on Azure, called as Azure Active Directory. There are some featured differences, but then think of it, the same Active Directory is available on Azure. It's in the cloud. So you can use Azure Active Directory to register applications with Active Directory so that people can use their Active Directory authentication to single sign on into different applications. You can already see there are thousands of applications. Office 365 is one of them. Azure Portal is one of them. Workday is one of them. ServiceNow is one of them. Even you can go ahead and create an app and say that, hey, I want to use the same Azure Active Directory to log in. With that, you also get conditional access. For example, if I am Mayur, part of Microsoft, working from Pune, I can have a conditional access that I can access Microsoft resources only from Pune. If I move to, let's say, US all of a sudden, and if suppose somebody is trying to hack into Microsoft systems using my credentials, they won't be, because there is a conditional access that, hey, Mayur can access these resources only from Pune. Something that sort of specific IP or specific region. You can also enable multi-factor authentication so that you can use your mobile, your email, or your biometric to log in. You also get federation for enterprise single sign-on. So when you build an application, let's say you want to share that application with your colleagues, which are in other organizations. For example, let's say Microsoft and let's say company XYZ are working together to build something. Now, there might be some resources on Microsoft SharePoint portal. These resources needs to be shared across the XYZ, the employees of XYZ. What we can do is we can federate the Active Directory, build a trust relationship, and also give a single sign-on so that people from XYZ can access only specific resources that are shared with them from the SharePoint portal. You can also bring in social and third-party logins with Azure Active Directory B2C or external identities. So when you build an application, if it's an enterprise application, you can use Active Directory directly and you can do the federations. But if suppose it's a consumer-facing application, think of it like you are building an application for people to upload their blood reports, or pathology reports, so that you can do analysis and you can have a historical data. So in that case, people may log in from their mobile using mobile number and OTP, from using username, password, using Facebook or Google or LinkedIn logins. So you can use that as well, and you can customize your flow of the using the identity experience framework. For example, when users are trying to log in, you can say that, hey, you need to validate your mobile number, you need to validate your email ID as well, and probably you may want to add some terms and conditions and other stuff in between, so you can customize that. So when building a SaaS application, the first thing that comes into the picture, the first thing that you want to cover is definitely the identity, and we have identity covered over here using Azure Active Directory. So the next bit is when you are deploying the solution. Okay, so you have identity. Now you want to host it somewhere, the front end, the application itself. So what options do you have? So there are different options. For example, I create a React application. Okay, I can put it or host it on a virtual machine, or I can host it in a virtual machine scale set. So let's say virtual machine is just like a machine that is available on the cloud. But then if suppose all of a sudden there are, let's say, thousands of users visiting your website. All of a sudden you become very famous, your solution becomes very famous, and people are subscribing to it. So in that case, or during Diwali, let's say Diwali festival, people coming to visit your website. So in that case, you can quickly increase the number of virtual machines, and once Diwali period is over, you can quickly remove or deprovision these virtual machines. So you have the option of virtual machine scale set. Virtual machine and virtual machine scale set is nothing but infrastructure as a service. That means you are responsible for provisioning these virtual machines. You are responsible for installing all the tools, all the dependencies, and your application on top of it. You are responsible for managing it. So it is infrastructure as a service. A step ahead, we have something called as app service, where you can host your application and you can define certain parameters. So your application can auto scale in, scale out. Then it can automatically, install the patches as and when required. So you have to just take care of your application. You don't have to worry about the underlying infrastructure. You don't have to worry about the underlying operating system. So that's app service. If suppose your solution is simple, which is like you give me a photograph of the car and I'm going to give you a number from the number plate, right? So it could be useful for RTOs. It could be useful for uh, uh, toll gates kind of scenario. So in that case, you can use Azure Functions, which is a serverless offering, which is platform as a service, where you can just create a function. It will execute when it's required, and it will shut down. So it will start a machine, execute the function, and shut down the machine. So you will pay only for that execution time. And then yes, we also have Azure Kubernetes service. So if suppose you have let's say you have the uh, containers, right? So you have containerized your solution and you want to achieve the scalability. You have to achieve the you have to build a microservices based solution. So in that case, Azure Kubernetes is a perfect solution. So if you go to Microsoft documentation, this is as I said, we have a lot of options for you. So depending on what you are doing, what kind of application you are building, you have the infrastructures as a service and a platform as a service available. Now, when we talk about the application, the software as a service application, we covered the identity part, we covered the front end part. Now let's talk about the back end. So when we talk about the back end, when we're designing a software as a service, there are different approaches. For example, you can have a standalone app. So let's say you build an HR application so that people can, the HR people can do the talent acquisition. And once people join that organization, they can see their payroll is, they can see their payroll, their pay slips. They can apply for leave. They can, go for extended leave, something that sort of. So it's an entire application. Let's say HR application. So you can build that as a software as a service and still deploy it as a standalone app. So you will create the same infrastructure for each customer. So tenant as a customer. So let's say Microsoft wants to buy it, you will deploy the app and the tenant for that Microsoft subscription. Let's say tomorrow Facebook wants to use your application, you will deploy the same thing for Facebook. Tomorrow Google wants to use your solution, you will deploy the same app and you will create the same infrastructure separate. The problem is you have to fix the app and database schema if there are any changes across all the standalone applications. So that is one approach. The other approach is the database per tenant, where you can have one application, but then you will have a different databases for each customer. So the HR application is only one. You create only one front end, you host it somewhere, and then you have separate databases for Microsoft, let's say for Facebook, for Google, and something that sort of. The reason is why we need a different database, because some companies don't want to share their database, so that you can have a database separate for each tenant, and then you can have elastic pool like configuration, where depending on the requirement, database can be database size can be increased, decreased, something that sort of. Then we also have something called as a sharded multi-tenant, where you have one database, but then you segregate customers, you differentiate between customers using the row. So each row will have a tenant ID and a customer ID. So if suppose I am a customer of Microsoft and Facebook, in that case, there will be two rows, about me. One is, let's say, with the tenant ID Microsoft and customer ID, let's say one, and the other is tenant ID, let's say Amazon, and the customer ID is one again, something that sort of. So when somebody is looking for me, let's say if I log into Microsoft, it will see I will see my records, if my leaves available, and if suppose I log in with Amazon, I will see my details from the Amazon site, something that sort of. So basically you can have a row level separation, you can have a database level separation, and you can have a separate database and app as well. So this is the consideration that you can do while deploying a database. Now it's all up to the data residency laws, the policies, and the requirement of a customer. Now, just like the infrastructure as a service, for data storage, also in Microsoft, we have multiple options. So you need to ask a couple of questions. For example, do you want to have a unmanaged or a managed database? For example, you want to go ahead with infrastructure or a platform service. Whether you want to go ahead with a relational or raw relational or a graph. So for example, if it's going to be, let's say, HR application, it could be a relational database. For example, let's say employee will have leaves, so there is an employee table and there is a leaves table. There could be employee and a payroll table, right? Something that sort of. Or it could be a non-relational where employees are there, but then there could be other tables which doesn't have any records over there for employees, right? So you can have a non-relational database as well. Or you can have a graph database. Think of it like Facebook, right? Facebook has friends of a friends can have posts, friends can have photographs, friends can share videos and all that. So that kind of data you can store in the graph. The data could be structured or unstructured. For example, it could be a file, it could be a text file, it could be a data file or a video file. The data could be batch or a series. So think of it like if I am building an application for, let's say, capturing the photographs and then processing. So what I can do is I can take 10 photographs and then send to Microsoft Azure to process it. So in a batch. Or I can have an application which is continuously taking photographs and sending it to the cloud. So it is a time series. So we can have a batch or a series kind of data as well. And we also need to think about the size. What is the size of the data that we are transferring to the cloud? So is it in KB, is it in MB, or is it in GB, something that sort of. So for example, if it's a 500 GB or more, probably sending a hard drive itself might be cheaper than uploading the data to the cloud, something that sort of. Again, we have this chart which can tell you what is the requirement, and from that requirement you can come to a conclusion. Okay, what is the right service that is available for me? For example, if I'm going to store files, I can store these files in the blob storage. But if suppose I want to access this file just like we access from the SMB store, right? So I can go ahead with Azure Files, something that sort of. So we have that option as well. This is a typical SaaS architecture. So when you are building a SaaS solution, so here you can see all the different services that are available in Azure, which you can use to build a SaaS, software as a service solution. For example, a user comes to the front door. Front door allows you to have have a failover traffic manager. You can think of it like that. So for example, we have resource group 1, which is in region, let's say, India, and we have resource group 2, which is in region, let's say, Singapore. So if suppose Singapore region 1 goes down, automatically front door will divert the topic to the traffic to the region 2. So something that sort of you can do. Then we also have application gateway, which can depending on the sessions, depending on the cloud, can divert the traffic to the different app services. These app services have backend of Azure Kubernetes service, where we can have different services running, or even front ends running, something that sort of. And then we have Azure Search and Redis Cache talking to something called Azure SQL Elastic Pools. So for each customer, we can create different databases, and as and when required, this database size can be increased or decreased. Definitely, we have Azure Active Directory for the authentication purpose, and Azure DNS for for the DNS purpose, name resolutions and all that. You can find this architecture on this URL, which is bit.ly/Azure-SaaS-architecture. I will share. You will definitely have access to these slides and the video after this presentation. Now, when you build a SaaS application, one of the thing that you want to do is sell your solution, and there are different approaches. You can just create a website and just wait for customers to come in, or you can go to marketplace and say that something like a bazaar and say that, hey, I have this solution available, and you can go ahead and buy it. So Azure has something called as Azure Marketplace, which allows you to uh, to submit your applications, solutions, software as a service solutions on the Azure Marketplace. So you can reach to billions of Microsoft Cloud customers. So let's say, as I said, you have built an HR application. There could be small firms, there could be enterprises who need Azure, let's say the HR solution. They can see your solution on Azure Marketplace, and they can buy it right from the Azure Marketplace, and they can start using the solution right away. You can add different channels. For example, you can use different Microsoft partners. You can add Microsoft Cloud solution providers who can sell your solution. And then you also get the GTM benefits and rewards and sell your solution across different 140 geographies. So let me quickly show you when I talked about the, let me just open it up. So I have this over here. Let me just go to the portal, Azure portal. I'm going to show you how you can create a multi-tenant application in Azure Active Directory. So here, this is my Azure portal. I can go to the Azure Active Directory. I can go to app registrations. I can say, let's say, a new registration, register an app. Let's say the name of my app is HR app. And you can see that I can create accounts in any organizational directory. Okay, so anybody in can just go ahead and subscribe to my application, which is Azure Active Directory user. So this is a kind of an enterprise application. I am not allowing the external identities yet, but let's say if I create an application, so people with at Microsoft, at Amazon, at Google kind of email IDs can go ahead and buy this application and start using it. So here, this is the first step of creating the identity for your application. The second is you can go ahead and create a web app. So creating a app service is a simple task. You can create a new app service. This app service will be, allow you to create the front end for your solution. So let's say as dev conf demo, something that sort of, you can use code to publish your front end. So it could be .NET stack, Java stack, Node, PHP, Python, Ruby, or even you can have a Docker container, which could be Linux based or Windows based, and you can have it in different regions, right? Something that sort of, so you can have the app service created as well. Similarly, you can create a SQL database. So you can see I have options of SQL servers. I can create a SQL database, and then within that database, I can have different databases. So I can have a server, and within that server, I can have different databases. So I can have that. And then I also wanted to show the marketplace. So let me just open up Azure Marketplace, where you can publish your software as a service solution. So you can see here we have apps, consulting services, and you can also hire an expert. Here we have the Get It Now offers. So something, if suppose you have a software as a service, you can publish it over here and people can start using your service right from here. So I just wanted to give you an overview of what options you have for putting your solutions on Azure and building your solutions on Azure using the Azure services. Now let's go back to the presentation. Presentation is here. Sorry about that. There are multiple screens. Just a minute. Yeah. So these are the URLs that I wanted to share with you. So I talked about only a couple of things. For example, I talked about the technical bits of building a SaaS solution, which is basically what services you have in Azure which can help you to build a software as a service solution. So it could be identity, it could be front end, it could be back end. But then there are many things which are required for building a SaaS solution. For example, understanding the market, understanding the pricing model, and all that. So Microsoft has the Microsoft SaaS Academy. I have created this URL for you, bit.ly/msft hyphen SaaS hyphen Academy. Please visit it so you can have more details about how to uh, build a SaaS solution. And then I have created a couple of videos on Azure Marketplace, which is Azure hyphen Marketplace hyphen 101. So you can find about how to publish a SaaS solution on Azure Marketplace. So that's pretty much I wanted to cover. If you have any questions, let me know. Uh, we have title sponsors as Microsoft and EI and community partner Elastic. We have learning partners as Pact, developers Roll Ahead, and security partner as Vikian. Uh, and then we have different communities, helping us spread the word about Azure Community Conference. So you can, if you are in Chennai, you can join the Chennai user group. If you are in Bangalore, you can be part of X Hackers. If you are in Pune, you can join the Pune user group. And definitely, these different communities have online presence, so you can join them for online activities as well. So that's pretty much. I'm happy to answer if you have any questions. The I just wanted to share my credentials again, so you can read. My name is Mayur Tendulkar. This is building SaaS products on Microsoft Azure, and this is my Twitter handle. Let's wait for Q&A. We will have next session by Karthikeyan VK, and he will be talking about architect using Kida Helm virtual kubelets to save cost. Stay tuned. If you have any questions, I'm here.
Hey, Karthik. Hello, can you hear me?
Yeah, 1 second, yes. 1 second. Mhm.
Hello,
Yeah, yes, Elias. 1 second, 1 second.
Karthik, can you hear
Yes.
me? You're ready. You can
Yeah,
start. You can start.
1 second. Let me share my screen. Mhm.
Karthik, can you hear me?
Yeah, I can hear you. 1 second. I'm just trying to share my screen.
Hello.
Yes, Elias. Mhm. Some problem with my screen. 1 second.
Hey, Karthik, can you hear me?
Yeah, I can hear you.
Hello.
Okay.
Hey, Karthik, can you hear me?
I can hear you.
Hello. Hello. Hey, Karthik, can you hear me?
Yes, yes, Elias, I can hear you. Can you hear me?
Yes. Now, can you share your screen? I will
Yeah,
guide
sure.
you what you need to do.
Okay. Is that okay now? Can you see my screen now?
Not yet. You have to click on the share option on the bottom of the screen in StreamYard.
The screen. One
On the
second.
ScreenYard,
Yeah,
the
I can see it.
StreamYard,
1 second. Yeah.
click on share.
Okay.
And now click on F5 first. Do F5.
Mm-hmm.
F5 is good enough. Just press F5.
1 second. Stop screen.
You stopped it again.
Mhm. Okay. Now it's clean. Can you see it now?
Now, yes, go ahead, Karthik. Please talk.
Okay. Okay. So, okay, I'm live now, is it?
You are live. You are live.
Okay, fine. Okay. Hi, everyone. Sorry for all the trouble due to the screen share and other activities. Okay, so welcome to the Azure Community Conference. Myself, I'm Karthikeyan. I'm a cloud native architect and I'm also a Microsoft MVP. And yeah, let's start. So today we're going to talk about Azure with respect to cloud native architect and other perspective on how you can save cost in your with your infrastructure. So what I have taken right now is I've taken a simple application where you can implement KDA using Elm and virtual kubelets, where you can save lots of cost. Okay, so I've actually implemented this in my projects where we were calculating for around 27 to 25 lakhs, and then when we started implementing KDA and virtual kubelets, the cost came down to some 4.5 to 5 lakhs. So that is how we save costs. So I thought, okay, let's do something with what we have learned through the process of implementing this KDA and virtual kubelets. So let's start. So the agenda of today's agenda is basically AKS. We're going to talk about AKS, and we're also going to talk about what is an autoscaler, why you should use SCADA, and what is SCADA, and also touch upon virtual kubelets and also Elm charts, and we'll have a demo at the end. The AKS is, as everybody know, AKS is a managed Kubernetes cluster in Azure, and AKS basically reduces the complexity and operational overhead. Meaning, if I want a Kubernetes in my system or in my on-prem or in my VM, it will take minimum of at least say a week with experts around to implement. Just to kickstart the Kubernetes installation and network configurations. So it takes so much time with respect to setting up clusters, networks, all the nodes, pod setup, security settings, everything. It takes minimum a week. If you have a very good team, it might take a month. If you have a proper, normal team. So that's the very pain point of setting up Kubernetes. And all the cloud vendors right now gives you a flexibility to create a Kubernetes service, managed service in few clicks and maybe within say 5 or 10 minutes maximum. And Amazon provides you a service, Google provides you a service, and also Azure by itself provides you a service. So these managed instances are very good to use, and AK is one of those services provided by Azure for Kubernetes. So it almost gives you everything on the out of the box, meaning monitoring, maintenance, and also making sure their master nodes are up, and you have a latest version. You can upgrade your versions. Those are all like very easier. You can just click on those nodes and then upgrade those nodes without even having a downtime. And alpha beta testing is all easier with Kubernetes. So that is the main thing with AKS. So it comes with all the bells and whistles also. You might after setting up AKS. Setting up AKS is easy, but you start using AKS, it's kind of too many bells and whistles. You need some expertise to use the Kubernetes. As long as you feel that you don't need Kubernetes, if you feel you don't need Kubernetes, you don't need Kubernetes, because it is not just a simple application. It might be easy for a smaller application to just see for it, but once you start putting it in production, it is actually a huge giant to handle and manage. AKS takes care of setting it up, but managing and making sure things needs to be in a proper place, CACD and all those things. It's actually tougher. That's why we use Helm charts. We'll also discuss about Helm charts in the upcoming slides. Okay, so that's the main introduction to Kubernetes. So let's talk about the HPA. So the point is, Kubernetes makes sure that it scales easily, right? So you would have seen autoscaler in web apps. You would have seen autoscalers in many applications. For autoscaling purposes, in AKS there's something called HPA. HPA takes care of horizontal pod scaler to monitor the resources demand and automatically scale the number of replicas. So whenever there is an increase of CPU, increase of memory usage, it will automatically spin one more node or spins one more pod based on the needs that comes in. But there is a catch with the HPA. The catch is basically nothing but it cannot scale based on any other external devices or external sources, right? So if the increase in CPU is high, it will scale up the pod. but if there is an increase in the, say, number of queue count in the queues, it might not increase the pods. It will still be the same. Or there is an increase in traffic of your own application. Only when the CPU hits a certain metrics, it will scale. Otherwise, it will not scale. So it will not know how many metrics is coming up or pointing to a Sen grid, pointing to a event grid, pointing to an IoT hub, or pointing to some kind of any Cosmos DB or any other database where you can actually send the traffic and make the AK scale. It will not work. HPA will not help. So there came up a community that helps you to do this limitation, have this limitation handled. Okay, so KKS cluster is only for mastering all nodes are deployed. Right. So okay, so we spoke about HPA, right? So we said HPA is something which scales based on the metrics of the CPU or metrics of the memory or any other metrics that is respect to the AKS, not respect to any external source. So why KEDA? So KEDA takes care of your scaling Kubernetes in case of any events that needs to be processed. Okay, the Kubernetes only scales based on CPU and memory metrics, but the KEDA will help uses the HPA to scale your applications in for if there is an increase in queues or blobs or any other. There are like hundreds of extensions that are available for multiple, not only for AKS, it is also being used in AWS, it is also used in GCP. So people use it for RabbitMQ, people use it for other kinesis based event-driven designs. It is not only used in the actual cloud. I mean, Azure cloud. It is also used in AWS. It's also used in GCP, I guess, but I'm not sure. But AWS, I'm 100% sure they use it for RabbitMQ and other event-based scaling platforms. So HPA is only supported from 1.8 plus, and probably we are above that. Okay, so okay, what is KEDA? So we spoke about why KEDA, right? So we saw that HPA had a problem of scaling, not scaling based on external events, but KEDA came in and then solved that problem. The main problem with the system is, the main problem with what we want to decide here is we have to make sure that what is KEDA, right? So KEDA is nothing but something which we need to take care of event-driven auto-scaling. So that's a main thing that needs to be taken care by KEDA. So it's basically a single-purpose, lightweight component that can be used into any Kubernetes cluster. It can be a GCP, it can be a AWS, it can be any other cloud vendor. It can be even on-premise. But yeah, it becomes a nightmare when you want to. I mean, I would suggest not to go for on-premise until or otherwise you really need them to be there. Okay, yeah. So and then yeah, next thing is KEDA works uses your HPA to auto scale as we discussed before. So without any duplication or overwriting, state management is automatically taken care by KEDA. And if you can see the diagram here, so this is how it works. So KEDA acts as a mid layer between the HPA and Kubernetes API server and the pods. If you see in the diagram here, what we do normally is there is a metrics adapter, there is a controller, there is a scaler. So metrics adapter is nothing but your metrics that comes in whenever there is an event. The controller will take care of actually orchestrating between your metrics and the scaler. The scaler is someone who actually increase your pods, the actual function pods, using the Kubernetes API server. So so the KEDA talks to the HPA and tells the HPA that, you know what, there might be a need in increasing the actual server capacity or server nodes or server pods. That is how it has to. That is how the KEDA works. Yeah, fine. The next slide. Okay. So next, we saw that there is an HPA. We saw what is HPA. We saw what is Cube, and we also saw. Okay. So this is fine. The problem with there is one more problem that needs to be solved. The main problem is with respect to the Kubernetes. The number of nodes you add will always stay there. Say if I add one node, you can still set auto scaling and reduce it. So if I add one node, what happens is that node you have to pay for it even if you are using it or not. What if I can have some nodes where I will pay, but I will not be using it for some time, like say I need it as a burst of traffic that comes in, and I need to pay it only for maybe 1 hour per day, or like say 6 hours per day. Say if it is 6 hours per day, even if you're using it for 30 days, it's almost like 1/3 of a day, right? 1/4 of a day. What happens is, so you'll be paying say $100. If you use virtual kubelets, what will happen is you just need to pay what, $25, because it will reduce the cost to 1/4 of what you're actually paying. So that is the huge advantage, and you don't have to make sure that you see the node is down or anybody sits there. So whenever there is a burst of traffic, it will pulls it up and then push the kubelets, the number of pods to a certain limit, and then you can actually again bring it down. The main good thing with virtual kubelet is you can configure that based on your number of events that comes into the queue. So virtual kubelet will help you to make to scale the pods. Okay, so meaning that those pods which is given by the horizontal autoscaler can be linked to a virtual kubelet. Meaning, say there is a node to there is a AKS and there is multiple nodes. Say I have configured 10 nodes. Okay, so I can actually pin those nodes to pin my traffic pods to nodes. Say what, for example, I have a Kubernetes, and in that Kubernetes I have say 5 nodes. One node is say D version, one is B, and one is GPU version, or one is some F version. Okay, and I know certain times some nodes might need a GPU for say machine learning workloads for some extremely Tesseract or TensorFlows. Then I need a GPU version. In that, what I will do is I'll pin this pod to one node. Okay, I can do that. Meaning, okay, for this machine learning workload, use my GPU based nodes. For smaller workloads, use my B2S instance or B2MS instance. So I can actually pin those nodes to the pods or to the actual process or the task. Okay, so that pinning is all possible in Kubernetes. When you write Helm chart, we'll discuss Helm chart one by one. So I'm just giving you. So what virtual kubelet does is it actually pins the node, or so pins your traffic or your event driven task to some system which will be ephemeral, meaning it will come live when it's needed and it will die when it's not needed. That way you'll be saving lots of cost. That is a virtual kubelet, if you ask me in a very layman term. It's nothing but pinning your task to a node which will die sooner, where you will be paying only for what you are using. Okay, so this is how it works, virtual kubelet. So if you have any questions, please let me know. You feel free to put that in the window. I'll be able to answer it in midway. I'm fine with that. Okay, so as you said, so if you see the diagram here, so there are multiple rows, right? So say let this node be B series, other node be M series, and the other node can be a GPU series. Okay, so what I have done is I can write an Helm chart where it says pin it to any one of those nodes. Okay, so if I pin it to say node 1 and node 2, I'll be actually paying the cost whether I'm using it or not. But when I pin it to a virtual kubelet, once a virtual kubelet is up, you will be paying only for what I have used that compute for. I will not be paying anything extra. That's the extreme advantage of using the virtual kubelet, and we'll be doing this with Helm. I'll show you where you can configure that in the Helm chart. Okay, so I think this is clear with the virtual kubelets, right? You have to make sure that you actually pin it to the virtual kubelet, which is already existing in AKS. You need to just tick a checkbox, or if you're creating in a CLI, you need to enable add-ons to it. It's actually very pretty simple and straightforward. Enabling virtual kubelet is easier. But I'm not sure whether if you have a Kubernetes already, whether you can enable it. I don't think so. It is possible. You have to create it and then enable it. Because I've tried a couple of times, it is not possible. Okay. Okay. So we saw the concept about HPA, right? And then we saw what is the problem with HPA, and we made sure that HPA is all done. So HPA is a problem. Then we figured out, okay, you know what, how to solve the problems of HTA. We started using KEDA, but the KEDA has its own problem because I might have to pay a lot even if I'm not using it. So that is why we used virtual kubelet. And then next comes the Helm chart. So it's all fine, right? So it's all fine to write lots of script and then run it every time. But what if I want to I have my system as a configuration as code or infrastructure as code, then it's a problem, right? So I cannot be running the script every time I want to run certain things. If I made changes to any of those systems or any of those kubelets, virtual kubelets, or increase the memory of the kubelets, or increase the CPU of my pods. I want to do all that. I don't want to write a script and then run it every time, right? So what if I want to actually have my infrastructure as code? So I don't have to even worry about it. I can actually kill the whole Kubernetes for a month and say, if I feel from January to March, I will not even have one single traffic. I can delete full Kubernetes, and then I can still have my all my application intact. And then when I create my Kubernetes, I still should be able to create it and then run my application again. So that is the femoral nativity of um, infrastructure as code or configuration as code or code or whatever it is. So usually people think they call it as pet and cattle uh, paradigm. It is not. It is no more infrastructure. Is no more your pet. You cannot name it with your things you like. It is like you always kill it and then move on and then get a new one. So it's like a cattle. So pet and cattle. So you'll be very affectionate or close to the servers and all those things. All those emotional bonding you had has to go off, because that is how they have designed in such a way that it's always femoral. Anything with is pet and cattle. So you think in terms of cattle mentality, where you'll be able to kill your whole infrastructure and build whenever you want it. So for that, you need certain technologies and tools. One of them is Elm-Chat. Okay, Elm-Chat is basically nothing but a package manager. You can think it as something like an Homebrew or npm packages for Kubernetes. Okay, so it gives you a very great flexibility to create your infrastructure or configure infrastructure at your own will, and it's pretty damn fast. It is not something which is, it takes like seconds to change, make your changes available in the Kubernetes. It is super fast. It also helps you to put A/B testing also in progress. They have lots of features that have comes in Kubernetes that enables you to enter into A/B testing without any even almost like a single line of code change. You can ask those pods to be in A/B testing if there is some kind of a parameter that comes in. So that's all pretty cool. Elm is something I am very excited about, and it's been here for a long time, and it's gonna uh, pick up a lot with respect to Kubernetes. And we have used Elm a lot, and you just need to know or understand Elm a little bit, YAML a little bit. Once you get understand a bit and the syntax and also the alignment, it's pretty easy. Means until you get that alignments and other process as a little, there is an hindrance in getting into it. Once you get into that, and you will be okay with that. It's more like a mm, uh, how to say it, a JSON with proper intention. That is the one you can actually talk about. So I would say that, but it takes a little bit of time as Kubernetes takes, and Helm is something which helps you to reduce your problem a little bit with respect to infrastructure and making your Kubernetes extremely femoral. So there is something called charts. I'll explain it to you when I'm showing a demo. The chart is nothing but a collection of files that describes a related set of Kubernetes resources. Okay, and Elm is the best way to find, share, and use software built for Kubernetes. So when you create an Elm, if you feel okay, you know what, I have something which can be reused. It's like an npm package, right? So you can actually put into a repo and then publish it. People can actually use that using the URL. So that is the beautiful way to find and share and use your software that is built for Kubernetes, because even the KDAS run on Elm, they have actually configured or used the Azure pods to understand to create something on Kubernetes. They are using basically HPA and writing some logic and publishing it as Elm. That way we are using the KDA. So Elm is the beautiful way of sharing your software or your ideas. Okay, let's dive into demo. Let me share the I'll share my one more screen. I'm sharing my screen right now. Yeah. I'll go ahead and create a Kubernetes. For some reason, my system is getting stuck. 1 second. Yeah. So I'll just conf 2021 kubelet demo. Okay, so I spoke about it, the Kubernetes version. We are right now in 1.2. Okay, you can choose any other version you want. 1.2, 1.2.1. The default versions are there. So this is where you actually select the nodes. So B2MSA or B2S. Things like that. I'm just selecting B2S because it's cheaper, and also I'm just running a smaller one. And you can also create an autoscaler. So this is autoscaling part I was talking about, where your HPA will take care. So the authentication, you can enable the role-based authentication, and also AKS managed Active Directory. And I would say you can leave all others as by default. And this you can enable so that application routing happens. Others, the log analytics, everything can be left as it is. You can even say, get your content registry configured, so you don't have to share your credentials in Helm chart. So when I'm explaining Helm chart, you'll be able to understand what I'm talking about. Yeah. So let's go ahead and create. I'll click on create right now. Once the validation is over. I'm sharing my screen 1 second. Yeah. So let it start. So meanwhile, what we'll do is we'll talk about the Helm chart I was talking about, right? So we'll talk about all the parts of the Helm chart on how it works and how it does. So let me share that part. Share. Okay, hopefully you can see my screen. Yeah, perfect. Right. Okay, so if you can see here, this is the chart I was talking about, right? So this is basically the chart you have to do, you have to create. So chart is, as I spoke to you, chart is nothing but a small package manager or big package manager that is for Kubernetes. So let's knock it down one by one. before getting into the production, until we get this Kubernetes up and running, let it create spun for a while. Okay, perfect. Right. So this is the chart I was talking about. Hopefully you can see my screen. Yeah, perfect. Yes. So this is the chart I was talking about. So let's start one by one. What we'll do is, this is something called value start YAML. Okay, this is a value YAML where people can see set those configurations here. You know what? This is where you put all your configuration files, your secrets, or your anything you want to use it in the charts file. Okay. 1 second. So this YAML file is, you need to get used to the syntax. Once you understand the syntax, you'll be able to understand how it works. Sorry, I was actually drinking some water. Yeah. And this is where everything starts. You actually talk about the actual what is the description, what is the version of the YAML file, and then who is the maintainer and who creates this. You can put your name, say here, and say this belongs to you, or you maintain that. Okay, and then you can change it to okay. So let's get into the deployment at YAML, which is one of the interesting things to learn about. So deployment at YAML does nothing but what needs to be deployed, and what is the pods that needs to be there, and what is the actual policy, restart policy, where should I pull the images from, what is the environment I should run. You may remember I told you about pinning your task to one node, right? The node type, maybe a GPU node type or virtual kubelet node type. So this is what is this. So this is called node selector. You can say, you know what, you do this and call it as a type as a kubelet. It can be B2S, M2S. So there are each and every one, there is a name to it. So this is where you pin it. The next is to termination grace period. Termination grace period is nothing but once the pod has finished its work, it will send the signal to HPA, okay, saying that, okay, you know what, I have finished my work. There is a grace period for HPA to start killing it. Okay, so you can actually set that. Sometimes what happens is you might release the resource, but still you might be needing the resource for maybe some few seconds. What if there is a queue that is running, and then the queue might have actually fetched up some data, and the HPA will set run for only 15 minutes or 20 minutes, or there is again you need to clean up some resources, and the HPA has asked for termination of the pods. For example, say I have a queue. In that queue, there was like 10,000 queue items was there, and due to the increase in spinning of all the pods, what will happen is it keeps on saying for 10,000 I will increase the pods to 1,000, and every damn pod 1,000 pods has got their share of 100, and it will become 10,000, and the queue would have actually all fetched everything, and it will start processing. If there is a timeout, timeout that is from the HPA, or the actual pod is releasing those resources, what will happen is HPA will get the termination, will send the termination signal, or the pod will send I'm going to terminate myself. Then the HPA say, okay, you know what, terminate, because I don't have any traffic anymore. At that point, you can set up some termination grace period where it wait for 30 seconds or wait for 300 seconds before actually killing it. What is the advantage of that is, you might have to clean up some resources. You might have to even actually push those resources back to queues. So that is like the proper thing, because at real time in production, when you're running crores and crores and crores or millions of records, these things will all come up and bite you. So you have to see all those small configurations to get your pods very reliable, and there is a lot of resiliency added to your system. Okay, and then the next is the secret. So you can create some secrets and then have a 64 based hash keys which can be which is saved in this YAML file. Okay, so basically you can actually take it from the values and then run it off. So this values, yeah, YAML, you can have it like a prod value.yaml or stage value.yaml, and each and every prod and stage can have, and this can be sent as a configuration to the actual Kubernetes when it's running. We'll just show you an example of how it does. So deployment is nothing but telling what my system is, what is my node, where should my task run, what is the node that needs to be done. So what is the rollback strategy, what is the timestamp, what is the container that my things should have, what is the image I should pull from, what is the image pull policy, whether it's an always or take a backup, or where should I pull the images from, and how should my restart policy be applicable whenever there is a failure of nodes. So these are the configuration with respect to the nodes. You can actually set it in the deployment YAML. So this is whenever you put a deployment YAML, or when you put whenever you call this YAML file kind is deployment, you'll be able to add these details about your node into the system. So this is like the kind which you have to set. There will be a deployment kind. So there will be a scaled object kind. So this will be a secret kind. This is actually this is chart. This chart YAML, you should actually keep it as name as it is. Others is all okay. You can rename to anyone. But these chart.yaml, you should make sure that this syntax is exactly right. Otherwise, it will be like a problem there. So I usually go with this cap chart because I tried a couple of different variations that was not working. So I just left it as it is. So this is my learnings for that. Okay, fine. So the next thing is we saw a deployment YAML, and another is scaled object. So scaled object is actually a simple one which actually tells you how much I can scale up to. Okay, how much maximum replica I can scale up to, what is actually triggering my scaling, and what is the one which actually, what is release, and what is the namespace I should actually set up, and also talks about the how many what triggers the actual scale up, right? So you can also say what is the minimum count. So the initial topic itself, let me start with 3 nodes, and let me start with 50 nodes, or let me start with 50 pods. So those are the configurations that can be scaled, put up in the scaled object. And the secret is, which we already discussed, which has the actual value, that secret that will be copied from the values.yaml. So what if you are copying data from, say, for example, calling the data from Key Vault. So these secret.yaml will help you to actually pull those records also. You have the Helm chart to that for creating it from a Key Vault or any other vault we have, which might be from AWS, or which might be some other system. Okay, so that's it with the Helm chart. So you have to put all your YAML Helm files into the templates folder, and then your chart.yaml should have the actual default details about the chart, and then your values.yaml will have actual values of your informations about your system that needs. Say, think of it something like a web.config. Okay, values.yaml. Okay, it can be web.prod.config and web.stage.config. So that's how it works. And then secret YAML is one which actually tells whom to pick it up, right? And deployment is just for your all the nodes or the pods size, pods toleration, pods node selector, what should they select, what is the termination grace period, anything with respect to the node. And then scale object is nothing but something which helps the HPA, talks to the HPA, or tells what HPA should do, or tells HPA to configuring the HPA. So that is the scaled object. So this is almost the case with KEDA chart and more charts, any charts. If you understand these 3 or well and good, you should be able to actually run it across. You should be okay with it. Okay, you just need to try a couple of things from Helm. You can start usually working on it. The major problem will be actually I don't know whether I should copy this code I got it from Stack Overflow to this part or this part. Okay, that will be the problem. Other than that, it will all be fine because you have to know little bit about how things works, how pods, what is node, what is pod, and how can pod sit together. So you have to have a common basic understanding of the logical separation, logical way things are. Then you can write those YAML inside if it gets to extremely complicated YAMLs. Okay, so if you ask me, this is little bit not very simple YAML. You might actually get confused. Let's say this environment from. So the containers might need this environment from secret ref, and also there might you can actually configure this from the same node selector from environment from. Okay, you can use the same secret ref. So based on your stage workload or production workload, you can pin your nodes to different tasks. Sorry, pin your tasks to different nodes. So you have to be like little bit cognizant enough to understand, but it takes time to get used to and uh, and not get carried away, because sometimes I've even sit to like 2 days to under 2 days where I've actually copied some certain code into different part of the file and was trying why it wasn't working. And it gives you a weird errors of okay, something is not wrong, and then I would have realized it is because basically I didn't understand the basics. Then I came back and then put the same content into the uh, other region and it will work. Yeah, so those are all the small nuances which is with respect to YAML. So if you take TypeScript and all, it's actually pretty easy, right? It will tell you, okay, so wherever you are, it is wrong. Okay, this is the Helm chart area, which is okay. So what I have done is I have actually created a small queue example where I'll be queuing that to a system. Okay, so I'll be queuing this to my some queue called AC power function, PowerShell some number. Okay, and I'll be queuing that, and now it picks up to that. So this is so I'll be using this Azure function to KDA. So KDA basically supports Azure function directly, and then whenever you write an Azure function, it dockerizes that and then push that to KDA, and it will run your workloads. So that is how right now the KDA works. They are also trying to pull that out and then make sure that any workload you can put. But still, I would say even if I'm going to AWS, go for Azure function, because the boiler it tries everything for you around the boilerplate, which is actually pretty easy. For Azure function, you don't, if you want to point to a queue, you don't have to think about anything. You just need to create. If you put func int, it will automatically create Azure function and it will configure everything for you. You don't even have to worry about what should I do for all the plumbing works. So it will remove all the plumbing code for you. It will create a very small JSONs, and all you need to write is start writing code somewhere here. Okay, so just start writing code. Put func int, give some yes or no, and what type of configuration it, and you are ready to write code, which is very pretty nice for developers like us, because we want things to go faster. We don't want to write the same code over and over and again. So func in it will write all your plumbing code. You can start using it. Okay. So this is the code. This is the help with respect to the code. And then let's move from that to actual AKS. I'll also see whether my AKS spun up. Yes, I think it's spun up. I'm just trying to share the screen. Give me a couple of seconds. Yeah. So AKS spun up. I'll connect to the AKS. Let me open my PowerShell. Okay. Let me share my screen now. Okay. I'm just connecting my Kubernetes. So before that, I have to put AZ login. I've already done that, so it's not asking me for AZ login. Otherwise, it will not work. I have to get the subscription from your AZ login, that if you start logging in. Okay. I'll go ahead and install some of the Elm files that needs to be installed. So I have already installed my Elm in local, so this command will work. Otherwise, it will not work for you. Uh, I have created a namespace for KDA. So you make sure that you install Elm in your system. Okay, so if you go into some sites, you will be able to see that. Just search for Elm, and you should be able to see. Okay, now it is being installed. So I'm going to okay. So this is the easier way to get your KDA up and running. Okay, I'll put KDA test. So it's actually throwing some error, but it still works. We'll see. There is a version mismanagement yesterday night it happened. Okay, I'm going to install my KDA one. So you have to make sure that you are inside that folder. That is what it is. So it takes like 3 seconds. Everything is installed. So that's quick it is. Say what if I want to change my say. Let me share my other screen. I'm gonna Visual Studio. Yeah.
Karthik, we are missing your screen. Okay.
Yeah. Okay. So what if I want to change this replica count to 100 and cooldown period to say 200? Okay. And then I'm saving it. I'm just coming back to my. I'm gonna share my screen again. Screen. I'm just trying to figure out where is my PowerShell. Yeah. So let me run this SCADA. Okay, it stays okay installed, right? I just need to upgrade it. Okay, that's it. So it takes like say a couple of not even seconds, like maybe a second or two for installing your upgrade. So that's the beautiful thing with Helm, and it's all configurable. You can do it like within seconds to upgrade your infrastructure. Anything you do, it is easily upgradable, and you can put that in the CI/CD pipeline. You are always good to go with that. Let's queue something. So I'll go ahead and I'm sharing my screen to queue. I'm just sharing my screen once again, trying to figure out the AC. Yeah. Okay. So I'll queue it up. So this is the Python queue. So let me just queue something. this will pick up in a while once the Kubernetes is up and running. Let's go and check the actual configuration of Kubernetes, so how things are inside Kubernetes. Which one I created? Yeah. Okay, so we spoke about node pools, right? So if we go and see the virtual kubelet, so I created a namespace. Yeah, KDA test. In KDA test, you can see, one second, am I sharing right screen? Okay, yes. Okay, so if you see here, the KDA test has the YAML files actually configured to it. This was a YAML file. So let's go and see what is actually inside the workloads. Okay, so if you see here, there are certain things which is being added as a namespace inside the Kubernetes whenever I select a tick, right? When I've selected HTTP application, this is also added as one more deployment. In Kubernetes, everything is a deployment, and then the same way, my queue trigger is also deployment. So this is what I deployed. Okay, so this is the queue pod that is actually running right now, which should actually pick my queue. So this is a KDA operator which we installed. Everything we installed through Elm, and then I should see my virtual kubelets. Let me and that. No, 1 second. Yeah. Okay. I think I missed the virtual kubelet thing. Okay, so if you see here, this is the virtual kubelet I was talking about. So there are two nodes, the actual master node and the virtual kubelet. This will not be costing you anything until some other pod is running. It's just a logical one which actually sits on your Kubernetes, and will not be costing you any other efforts, any other cost. But this will help you to run your pods. Okay, so if you see here in YAML file. See, you can actually set those set configurations. So it will give you a 10K of CPU size and 4 terabytes of memory. So if you want to increase this virtual kubelet's power, you have to send us. I mean, you have to create a ticket to Microsoft saying that, you know what, I need to run 1,000 pods with a memory of say 20 terabytes or TI of memory, and my GPU should be something else, or I need a GPU which more than 1,000, because once we started using this virtual kubelet, what happened was we figured out our the default setting for Microsoft pods and virtual kubelet is around 1,000, and there are some as you said, it's like a 10K CPU and 4 TI memory, which was not sufficient for us. So we have to actually talk to Microsoft, and then if you are trying to run a huge workload, we make sure don't hit your limit once you are in stage. You send an email or create a ticket to Microsoft itself saying that I need more containers or more memory powers, memory and CPU that needs to be allocated to my pods. Then they will ask you to change your billing to invoice, because you cannot. So if there is some more than a lakh or something, you need to pay only 3 invoices. The credit card won't be enough. So those are the problems you need to work out for, like say maybe at 15. I don't know. It took me 10 days to make them understand. I need this to be increased, the number of pods to be increased, and the billing, the account system is different, and the billing system is account system is different, and the scuba different. The container increasing department is different, and there will be lots of mails that cross run across to get your because I faced at least 5 days of before production just to hold it, because I don't have enough pods to run. Okay, so you get that thing running, so you make sure that what is your actual workload, calculate that, and then do it as it is. So this is with respect to the ACI. And if you want to check around others, so you can also increase your storages, your persistence volumes. I would say keep your if you ask me, well, keep all your task-based or workload, use Azure functions whenever needed. If there is no timeout to it, if there is a timeout, what you can do is you can use Azure functions, still use Azure functions, deploy it to KDA, use Kubernetes, and then run your workloads. And if there is a web app or web app solution, if it's a static web app, then use your so-called static storage, which actually, and put a CDN on top of it, and it scales heavily. Go to Kubernetes for Web API only if you need that huge scale where you do lots of A/B testing, where you are okay with running your workloads, the millions of requests that comes in. You want to scale that much faster, or you want to handle your gRPCs and multiple microservices that sit together with Istio and all, then you go for Kubernetes. If it is not the case, I would say you still stick to all your machine learning workloads or any other workloads that runs as a batch process that needs more than 5 minutes. Then you go to Azure Functions. And even that Azure Functions, if it's like only 10 or 15 minutes and there is no burst of dirt, you can still use a app service plan and then do Azure Function. So the first step is to maybe do it for Azure Functions and then see if it's timing out. Go to web app service plan, and then you see it cannot scale faster. Then you move to Kubernetes. Okay, so don't jump into Kubernetes if you feel you want to do certain things up. Okay, so that is my takeaway from that. Okay, Ilyas, I'm almost done. So if there is any question, I can take it.
Nothing much, Karthik. I'm looking at the screen for the question. Am I audible, first of all?
Yeah, I can hear you.
Perfect. So there are not many questions at this moment. So for the audience, please submit the feedback form to stand a chance to get an amazing giveaways from AZConf community. And we have the next speaker lined up. And Karthik, thank you so much for the session on Kubelet, virtual Kubelet. I guess, whatever suggestions and recommendations that you had from your working experience is really useful for the attendees, and we hope they would apply that on their day-to-day activities at their office.
Yeah, thanks, Ilyas, for the opportunity. Thank you very much.
Thanks, Karthik, and have a nice day.
Same to you. Bye.
Bye. So attendees, please, stay tuned, and we have Prince and Naveen joining in a couple of moments for the next session. So I'm switching my head this side because I have the screen on this side, but now hope you can see me. So we have 3 more minutes for the next session. So until then, I will play the music. Hello, everyone. Thank you so much for joining AZCon 2021. And this session is all about Synapse Analytics, doing data warehouse with Azure Synapse Analytics. And we have Naveen and Prince joining us on this session. Prince and Naveen, you guys are live, and the stage is yours.
All right. Thanks, Elias. Just want to check we are audible.
You are.
Yes.
All right. All right. Hello, everyone. This is Naveen, and I hope you all are doing good physically and mentally in this pandemic. Let's start Azure Community Conference 2021, and the next topic is Azure Synapse Analytics. All right. We'll be touching upon how to build modern data warehouses using Azure Synapse Analytics. And within Azure Synapse Analytics, there's a lot of buzz. What is the difference between a dedicated SQL data warehouse and what is this Azure Synapse Analytics workspace, which is a studio UI provided by Azure. So let's look at the agenda that we'll be going through. We'll be going through the entire data warehouse journey, that how Microsoft reaches from parallel data warehouse world to what we know today is a dedicated pool and Azure Synapse Workspace. We'll go through its overview, its architecture, and we will have a couple of demos on Polybase, on the different distribution tables, how those provide the data warehousing capability within Synapse. And we'll see how the workload is managed, and a couple of demos on all these the different table structures and how the ETL is performed within Synapse Analytics. And then later up, we will be having demo from Prince on Power BI, that how we connect to the dedicated SQL pool and create the visualization directly from the warehouse. So a little bit about me. It's been 15 years that I'm working on Microsoft technologies, and mostly in database, data warehouse, and mostly on the BI projects, end-to-end implementation of BI projects. Worked as a senior consultant, as a BI architect, and currently working as a technical lead on data warehouse and BI projects, and contributed to Microsoft community, and of course a lifelong learner. Thanks to Mr. Satya Nadella, and thanks to Microsoft for giving us the opportunity to learn Azure and providing us the capability to create apps using Azure and Azure Cloud. So let's start on Azure Synapse SQL Data Warehouse. So before we move on what it is today, let's quickly look at how it was earlier and how that journey has been so far. So very initially, it was known as Parallel Data Warehouse, and that was the analytical platform system that we used to use. But this was not on Azure Cloud. It was a dedicated hardware where all these appliances has to be set up using all those virtual machines, or a physical hardware has to be set up within the organization's data center or some other data center, which will be then further connected with the dedicated network. But the scaling options and all those capabilities which a cloud offer, those were not possible. We had to purchase all those hardware upfront, and there was upfront cost as well. So this was the very first instance of the warehouses that we all know. When we moved to cloud, it was first released as Azure SQL Data Warehouse and called as SQL Data Warehouse on Cloud. And that was the very first offering on Azure. Later on, it was rebranded as Azure Synapse Analytics, which was for long-term Azure goals. And that also tells us that, okay, there is a big workspace or analytics capability is coming. And that's how the Synapse rebranding came in. What it is today, it can be divided into two things, but behind the scene, they're just a different component, but all integrate with each other. So the one which we know, which is Azure Synapse Analytics, that's a workspace. And another one, which is a warehouse, it's a dedicated SQL pool. So this dedicated pool is also just one of the many way how we can connect to the data within the workspace. So workspace provide us capability to connect to the dedicated pool, to a serverless pool, or we can also use our Apache servers, and we can, you know, spin up our clusters to connect to the data which is lying inside the data lakes. So that's the workspace offering. And what we will be discussing today is mostly on the dedicated SQL pool, where we'll be seeing that how a data warehouse should be set up and what are the offerings that dedicated SQL pool provides us. We will also see the differences between a dedicated pool and serverless pool, which is one of the capabilities within the Azure Synapse Analytics workspace. So this is entire Azure Synapse Analytics workspace. It is accessible by creating Azure Synapse workspace, and then there's a thing called Synapse Studio. That's Studio UI itself offers the capability to connect to the dedicated pools, to serverless pool, or to Apache Spark pools. We can run our own cluster here. The dedicated pool, we have the compute predefined, which is also scalable. Serverless SQL pool allows you to connect to your data in data lake, and the scalability will be handled automatically. Here we can scale it manually, we can scale it automatically, but here the cost will be taken care as in how many SQL Server pool units we are using. But the moment the user is submitting the query, uh, all the underneath node which will act and bring the data, this entire automatic scaling will be handled by the system itself. Here we have more control, and in both these units, the data is handled separately from the compute node, which we'll see in a moment. So this is pretty much the workspace offering, and there is more within this, that how the management needs to be taken care, how the integration needs to be taken care with many other services. What we will be mostly focusing on today is dedicated SQL pool, which is formerly known as SQL Data Warehouse. So if we go through some theory initially before we go with the demo, what dedicated pool is, and what is DWU? It's a data warehouse unit. So how different compute options are used and what compute features that we are using, that is basically termed as a data warehouse unit. And it has an offering from starting from DW100, and it can go up to 30,000. And basically based on what options we are, what services we are choosing, accordingly the data warehouse unit will increase, and it will also increase the compute power of our warehouse. And once this is set up, yes, it provides us the offering using Polybase, where we can simply use the T-SQL queries using Polybase, which can connect to the data lying in the data lake. It can not only query it, but it can also bring the data to do import and export and ingest within the dedicated pool. So how this entire system works, let's look at its architecture on a very high level. So if you look at where the data is present, it is purely in your Azure storage, and the entire storage layer is kept separately from the compute node. All these different compute node, they are connected through a control node as well. So any user who will connect and or fire a query that is through this front end, it will go to the control node. Control node will be talking to all these different compute node using this massive parallel processing engine called as MPP engine. And this control node will provide this information to all the compute node, how that query has to be broken down into smaller pieces, and how each compute node will work independently on that query, acting on the same data, but will be bringing the results, will be joining internally, and then giving it back to the control node to present it to the user. There's another component which is called data management service. The purpose of this is to combine the data which different compute node are giving and then giving it back to the control node. The good thing about this architecture, which is a distributed system, is that all these compute node can be scaled independently, and the data is kept in a separate Azure storage, and the scaling need not to be interfering with the data. Just entire a set of compute node can be brought as per the performance required. So yeah, this is the scale out architecture, which will help in distributedly providing the computational power process using the distribute computational processing. The unit is called data warehouse unit, which we have already discussed. Let's look at the Polybase demo. We will set up Azure dedicated pool, and we will be connecting that dedicated pool to a data lake, which will be creating as part of this demo. We'll create a test file in the data lake. We'll put it into a container, and then we will connect it from the newly created SQL data warehouse. So as you can see, as part of this demo, I've already created a dedicated SQL pool, but I'll be going through and I'll be showing you that how we can create the data warehouse. So we'll say create a new resource, and we'll say dedicated SQL pool. The moment we will say create, it will provide us the different options, what we can choose, what SKU required. So we'll choose a subscription, we'll choose the resource group. If it's not existing, you can create a new one. Then we will write up our SQL pool name. We can create a new server, or if there is an existing server that we want to leverage, we can use that one. We can define all this performance level upfront. There is an option to go it up to 30,000 DW unit, or we can keep it to 100 or 200 as part of this demo. We can choose whatever the networking options are there. If we want our private endpoint, that is also possible. So once we provide all this information, we can also say that it has to be a blank data warehouse, or we want to restore it from a backup, or we want to create a sample AdventureWorks database. So that's also possible. So once this is created, this is how the dedicated pool will look like. And we will be connecting to this dedicated pool using Azure Data Studio or using Management Studio. So here in my Management Studio, I am connecting to one of the data warehouse that I've created. This is the database that it's basically a data warehouse. So in order to set this up, there are two things that we have to create first so that we can start creating our Polybase. First thing is we will be creating a master key. As part of this demo, I've already created a master key. So no one can use the same subscription to create another one. The next thing is we will be creating a database scoped credential. In order to create this database scope credential, we will be going to the data lake that we have set up, and we'll go to our container and we'll get the storage key from there. So the one that we will be connecting is this data lake. I've already created a container inside this, which is the demo container. Inside the demo container, I've created a file which is called test employee. And I've kept 10 records in this file, and we will be connecting to this file using Polybase, and we'll bring this data to our data warehouse. So before that, how we will be connecting to this container is it's through this storage access keys. There are a couple of options to connect to this. It can be through managed identity as well. The one that we are choosing as part of this demo is through the access keys. So this is the access key which we have used. Currently it's hidden. And when I was setting it up for the data warehouse, it's the same access key that I'll be using here. So what I'm doing here is I'm just creating a database called credential, which will be named as the demo identity. And this is a secret where I'm giving that entire data lake key so that the connection can be set up. The next thing is I'll be creating a data source, and let me first drop it if it already exists. All right, it doesn't exist. So I'll be creating external data source. What it does, it connects to the container within the data lake so that whatever the files are there under that container, we can set up a connection with. So this is the endpoint that how we'll be connecting it. And this is for the blob. If it is a file system, only the endpoint configuration will change. The location will change. It can connect to your blob. It can connect to your file system. It can connect to your table as well. What is the credential we are using? This is the credential which we set up, DLake credential that we will be using in order to set up our external data source. What is the type underneath entire Azure data lake? It's a Hadoop offering. So this is the type which we are defining Hadoop. And now we are going to create a data source, and it's an external data source to a data lake. All right, that's because after changing the connection, it has changed it to master. I have to connect back to data warehouse. Okay, let me drop if it already exists. Okay. I have to drop the external file format, and I have to drop an external table first. All right, we are good to go. So I'm creating an external data source, which is connecting to the container location, and it's using the credential that we set up here. So first we are creating a data source that is done. After that, we will be creating a file format. So using Polybase, we can connect to a text file. Using Polybase, we can connect to a CSV file, Parquet file, ORC file. JSON is currently not supported, but for rest of these files, we are good to connect. Now, Parquet and ORC files, they provide much more capability for compression. And JSON, yeah, it's just much more, it's quite a rich format. And of course, there are more performance issues if we go ahead with the data which is in a gigabyte. So Parquet and ORC is the preferred format if really we are dealing with the huge data. But as part of this demo, we are only connecting to a text file or a CSV file, which is a very light file. So we'll be creating an external file format which is connecting to a text file. But I do have the schema that how we'll be connecting to the ORC format or the Parquet format. First, let's create a connection to a text file, and let's understand what are the different options here. So we are saying that I'm creating to a format type, which is delimited text. Basically, it's the text or CSV format that we are connecting. We do have options of providing all our string delimiter, or which is the first row where it will start. What's the type default that needs to be chosen? What's the row terminator or any encoding which is there? And this is the compression. There are a couple of more options for the compression. The one that we are going with, it's the default. And that's how we are setting up our external file format. So by doing this, we just tell data warehouse system that what kind of data sources that I'll be I'll be connecting with. If let's say there are files which are following the same format, we need not to create the same external file format again, and the same format can be used by multiple external tables. The format is done. If we require to connect to the ORC format file or the Parquet format file, this is the format for that. We just need to give the format type as ORC because all these files are columnar. It provides high compression ratio, and it also saves us time in setting up all the different options that we have to do with the text file or with the CSV file. Same goes with Parquet. It's pretty standard how the external file format can be set up. So the next thing is to create a connection to that external file, which is residing inside the container in our data lake. In order to do that, we have to create an external table. We just have to provide the schema, what are the number of fields that we are looking at. But then we have to set up what's the location. The location is test employee. The thing is, from here up to here, the connection information is already provided in the file format and in the external data source. So this is the demo container, which is the container that we are connecting to in this particular data lake. After that container, whatever number of folders are there, we can keep on putting all those folders there and can say this is the location for the file, as we have directly put it under the same container, and that's the file. Let's go to the container again. This is the demo container. Inside this, we have given the test employee file. So this is the location that we are connecting to. What is the data source that we are using? It's the same data, external data source that we have created. What is the file format type? So the same format can be used by multiple external tables. And this is just to make sure that if there are any issues with the file for a particular record, what is the percentage that we want to ignore? What is the number of records that we want to ignore before it starts throwing us an error? So let's create the external table now. We have set up a connection to the same text file, and now we are good to go to connect to the file. Now the same file which reside in the data lake, we can query from the data warehouse. So as of now, we are connecting it from the external table, and this data still reside in the data lake. The data is not yet available in the data warehouse. We will see further in our session today that how we will bring data to local tables, but first we will understand about the tables. But as of now, this entire data set reside in the data lake itself. And not just this file, but we can connect to a thousand of files as which are residing in one data lake or any other number of data lakes, or in S3 bucket or any other offering that we have for the data. Let's go back to our slides and understand more about the different distributed options that we have to create our tables. We'll understand those first, and then we'll quickly come here and we'll see all those tables and what are the different offerings of distribution which is provided within a SQL data warehouse. So there are three table types. The first one is hash distributed table. So how the distribution takes place in hash distributed table, there's the deterministic hash function, which will decide that which rows will be sitting into which partition. So no records will be sitting into more than one partition. So let's say if I have these 5 partitions, so this is our entire table, and this is how we'll be distributing it behind the scenes. So there's a hash function which will be distributing it into these multiple tables. And let's say there are 10,000 records, and I want to say my hash function will decide that every 1,000 will go into one partition. So it can be done by a deterministic hash function, and it will keep on putting this data. Another offering is round robin distributed tables. It's pretty much the same offering. The thing is, here we do not have control over the hash function. The hash distributed tables gives more performance advantage because the system itself, the compute node itself, will be knowing where the data will be available. So it provides faster performance for joins and for aggregations, because the compute node and the control node, they all will be aware where the data is present and how the data needs to be accessed faster. Round robin again distribute the data in different partitions, and of course it's not going to overlap any single record in multiple partitions, but the function is controlled by the system itself. Now it's a good candidate when we have any temp tables that we want to create, or within our stored procedure any temp calculations that we are performing. Then it makes sense to use round robin tables. There's another offering which is known as replicated tables. The advantage with replicated tables is each table will be replicated to every compute node. Now, it will increase your storage cost because the same data we are replicating on all the compute node. But it is a good candidate when we are working with the smaller data set, and maybe some small dimensions or small tables are a good candidate for that. The advantage that it offers is whenever this data management services is acting upon, it need not to move the data across all those compute nodes. As the same data is available at every single node, so the data movement is not happening, which also provides the performance benefit. But definitely the storage will increase. But as long as the tables are of very small size, storage is that cheaper in cloud that this should not be a problem. But this gives us an understanding for what purpose what table needs to be used. Definitely, if you are dealing with more than 1 million record and all the fact tables that we are creating, hash distributed tables are the way to go. Anything temporary you want to do will be going with round robin distributed tables. And whenever we want more performance benefit, but there's a very small data set, then we will be going with the replicated tables. Usually we use it in our calendar dimension, where we know that data won't be increasing every day. It's just a static table that won't be having more data operations. So replicated tables is a good candidate for those. Let's look at all these tables and how these are created within data warehouse. So we can also look at the external tables that we created as part of our polybase. So this is just the connection and mostly the schema information, and the data still reside in the data lake. So that's one of the offering. All these remaining tables I loaded as part of our data warehouse setup. So I have also imported Azure. I have also imported AdventureWorks data warehouse. So let's say if you are creating a hash table, we can provide the entire schema directly, and there's a feature within the data warehouse which is called CTAS, known as create table as select. We'll see also very soon. We are fetching data from our existing dim employee table, and we are creating a table out of that. But here I'm focusing more on the distribution that we are going to use. So the one that we are creating now, it's a hash distribution. The distribution, I'm saying it should be based on employee key. The default index which will be created in data warehouse, it is a clustered column store index. We do have a clustered index as well, and we do have a heap table as well. By default, if you do not provide any index here, it will be created as clustered column store index, but we can set it up as heap as well if you want. Here we are creating a table, and it's a hash table because that's the distribution that we are choosing. Again, we have to connect. Let's change it to the data warehouse. So we just moved 100 records from our demo employee table and we created a new table known as T1 hash. We'll do the same with the other distribution as well. Let's create a round robin table. And there is a reason that I want to create all these tables first, because we will see the different distribution with the icon itself. And we have created the third table, which is the replicate table. Let's refresh our tables here. So these are those three tables that we have created. And if you look at the icon here, with the icon itself, we get to know that how the distribution has taken place. In T1 hash, based on employee key, it will create and distribute the data across different distributions for each employee key. If we are, let's say, at a maximum capacity of DW 30,000 and we have 60 compute node, so there will be 60 different nodes which will be having those record. And it could be the same for round robin as well, as long as the function itself is distributing those, or it could be less in round robin, because here the system itself will decide that. So this is the distribution one. It clearly shows the icon that the entire distribution is separate. Here in the round robin, if you see there's a yellow icon which says the system itself will decide how the distribution has to take place. And in T3 replicate, if you see the icon says there is a replicated table behind this, which means it has created another copy of the same table on each compute node. Now, based on your data warehouse, if you're using 5 node, it will create 5 copies of the same table. So that's more on the distributed tables. What are they, how those should be used, and based on each scenario, how you'll be setting up your data warehouse, or maybe your data model for your cube or any other data warehousing purpose. Each table will give you some glimpse of the criteria that you should be looking at to decide the distribution that you will be interested in. Now, there's one more thing within the data warehouse, because it offers very less connection than how this concurrency has to be handled, because compared to SQL databases, data warehouse provides very less connections. But then we can come up with many other possibilities within warehouse, that how we have to control our workload management within the data warehouse. And for the workload management system, there are two things that we want to emphasize today. One is the resource class, and there is also like static resource class. There is also dynamic resource class. The one that I'm sharing with you now, this is the dynamic resource class, and there are 4 dynamic resource class, which is known as small RC, medium RC, large RC, and extra large RC. The advantage with each resource class is that, and of course they will differ from the data warehouse unit that we are choosing. If we are at 100 data warehouse unit, so that's the percentage for those. If we go back up to 30,000, there will be a different limit for those. But let's look what is the offering from each resource class. If we are at small resource class, we will have 25% of the overall compute, but there will be more concurrency available to us. If we move from small resource class to medium to large and extra large, there will be more compute power provided, but the concurrency will be less. So as we go from small to higher, there is the compute power will increase, but the concurrency will decrease. Another thing is if we are moving from smaller to higher resource class, even the preferences will be given to the higher resource class. Let's say there are 2 user A belongs to a small resource class, user B belongs to medium resource class, and they both are firing the query. The advantage will be given to the user who belongs to the medium resource class. And that's how this entire concept of maintaining the workload within data warehouse is offered. And there are these limits in terms of maximum concurrent queries or concurrency slot for each resource class, how it is being offered. It's a huge list. I have put it here up to 1500 data warehouse unit, but it goes up to DW 30,000. And the maximum concurrent queries in dynamic resource class, it's up to 32. But it's not like your queries will be stopped by the system, it will be queued up behind the scene. So the moment the query is done and the resources are released, then it will again come back and will start executing the queries. We'll look at quickly at the CTAs, and we'll see many other options for labeling, which is quite a good feature within Data Warehouse, that if you have to track your queries using dynamic management views or other options, that how you will figure out what resources query has consumed and what operations it was running behind the scene. So let's just say we will use the same table, the external table that we created. And currently, if I'll query external table, the data still reside uh, in the data lake. Let's bring this data from the data lake to a dedicated table within the data warehouse. And later on, we can come up with more operations on the same table after bringing the data within data warehouse. So that's my external table. Now I'll be creating a dedicated table within the data warehouse. I'm using a hash function, and using my external table, I've created another test table. Just a second. Yes. So we created a physical table within data warehouse. Now, if we query this table, the data is residing within our data warehouse. Now we can choose what we need to do with this table, whether we want to join this table with another table, or we want to fetch data from many other different tables. So all those options are possible. We can create another table by joining our external table or the newly created table that we created, and we can simply rename our tables and drop the existing table. So what we are doing here is I'm going to create another table which was having data from test employee, which is an external table, and the one that the physical table that we created. Both the tables are having 10 records. So we are combining this entire data. There will be 20 records, and then we'll simply drop all these temporary tables and quickly replace the final table with the actual table. And it all can be done in a single shot. What I just did is our external table and the newly created table, which were having 10 records, I created another table by combining those, and it's a 20 records now in the table. We can even test it here. The offering that it gives is we simply rename the existing actual table to a new table, which are we going to be deleted. The newly created table as part of this query will be replaced back to the original table, and we simply drop any intermediate tables that we created. Now it looks like a very simple thing to do, but you will be using as part of your data warehouse development most of the time the CTAS feature, because it just give this offering to quickly replace the table so fast that most of the data management and the data load is handled by using such features within the data warehouse. And as part of that, we also labeled our queries. So label is one function within the data warehouse, which can also tell you to track all your internal dynamic management views, that how this query has taken place and what a compute node it has used and how this entire operation has been performed. So this is just we are querying one of the dynamic management views, which tells us what compute operations are happening and pretty much all the details behind the scene. So that pretty much covers our demo on the data warehouse, on Polybase, on distributed tables, and the CTAS feature, or a couple of new advanced features to set up the data warehouse vault. We are ready to take up any questions for the SQL warehouse before I hand it over to Prince, who will be connecting the data warehouse to Power BI, and we'll see what offering within the Power BI that data warehouse provides. We can also connect it to Azure Synapse Analytics Workspace. We can also directly create just by putting up another connection to the data warehouse and then create our Power BI reports on that.
Ilyas, any queries from YouTube? Anyone? Elias? Okay. Uh,
Uh,
if no
in
one
that
has
case,
it, I have certain queries, Naveen.
yeah, sure.
One thing is that if we keep the data inside, so what is the preferable way to keep the data in the data lake itself and do not just bring the metadata to the data warehouse and still query it, even if the data is very large? Or how do we manage both? Is there any guideline from a Microsoft perspective that okay, if your data is going beyond certain GBs, you should start bringing it into the data warehouse rather than keeping it in the data lake,
Sure.
because both gives you different kind of stuffs.
Yeah.
Uh, so how do you prefer in that sense?
Okay, well, I'll go with the universal answer, as in it depends. So let's just say that your data lake is having quite a lot of data, and which you don't want to bring to the data warehouse. I mean, data warehouse should be, there's a purpose that you are building your data warehouse, which has its own meaning. It's just a subject-oriented thing. It wants to keep data for a particular subject. You want to give that entire history, and it should be non-volatile. So that's the purpose of building the data warehouse. So you can keep on, bringing 10 years of worth of data there. The advantage which we see here is that we can directly query the data lake and just ingest this entire data using import and export using the polybase. But let's just say if you just want to spin a cluster directly on top of data lake and want to do the data lake analytics, we are just looking for some information on this entire set of data rather than actually storing this data. So use SQL is one better way, or we can come up with the Databricks cluster, which will spin over on this entire file set, and whatever aggregation that we want to perform, or the machine learning algorithms that we want to perform on that data, then Databricks will be an ideal choice. But in terms of moving this data and to perform any other machine learning algorithms which you want to do directly on the data warehouse, then data warehouse will be the way forward, because the advantage that it will offer compared to the data lake, as long as the data is in file, you have less performance there. But yes, we have all these advanced technologies like Apache Spark, Hadoop, and Databricks, which can definitely create a series of cluster and spin it up and can give you the data. But here in data warehouse, you have your entire data structured, already available, indexed, and it's all the clustered column store index, which will go ahead and uh, put index on every single column out there. So the data is much more faster here, and on top of that, you are having advantage of this distribution. So when we compare to the data lake and when we compare to the data warehouse world, the advantage here is of structured data. The advantage here is of uh, uh, the cluster, the indexes which are there, like clustered column store indexes. The data is already compressed within your data warehouse. On top of that, this entire distribution which is there, you can also scale out your data warehouse, which is not really possible within your data lake, and that's why it offers much more advanced performance and scale out options when the data is available in warehouse.
Okay, in general, so the basic rule should be you should always ingest inside your data warehouse rather than keeping it in the data lake itself. Correct.
Yes, for most of the use case, if you're building warehouse, yes, we should bring it here.
Okay. Because I was asking in a sense because sometimes your warehouse is too big, so when you want to do an archiving thing, so better to keep it in the lake. That kind of data, put it back, throw it back to the data lake, and keep mostly the latest one inside the systems. If that could be a scenario we can think
Yeah, I
of.
think it's more of archive function, whether we want to archive within the data lake, the tens of years of data, or we want to archive it within the data warehouse. We want to create those structured data. So depends on the use case. If you want to keep it there, we just want to query it, then data warehouse is an option. Otherwise, we have to spin using data lake. We have a question from
Yeah,
Krishna. When to use Databricks? So if you don't want to store your data in a structured format, and every time you want to go ahead with some uh,
complex queries.
custom aggregations, I will say, or you want to run some algorithms on the data. So here the use case is you want to get some information out of some aggregated data from the data lake, then Databricks is the preferred options, because you have the option here not to move the data across different systems, be it database or data warehouse. and Databricks will give you Databricks use case should be used when you want to simply come out with some insights of your out of your data without moving it to the data warehouse world. The reason, if you do this calculation from Databricks on data warehouse, you are not only paying for the compute of Databricks, you are also paying for the compute of data warehouse, which will cost you double. So if your intention is just to come out of some insight from all those files, then Databricks is a preferred way. But if your intention is to create a data warehouse world and with limitless capability, then that's where data warehouse should focus. Your data warehouse is not an option where you just want to create an operational database. No, it's not for that. If you want to create just 1 GB, 2 GB of data, I think SQL data, Azure SQL database is a good option up to 1 TB or up to 4 TB. But if your data is so huge that it's going in 200 terabytes, 400 terabytes, which cannot be handled by any other SQL database, data warehouse is an option for that. Plus, it has all these capabilities of compression, cluster console indexes, and scale out options. And it keeps your compute node and storage node separately, where you can scale it out purely as how you want it. All right, I think yeah, at this stage I'll give it to you, Prince, for the Power BI.
Yep.
Let's
Yep.
quickly check. Yeah.
Yep. I'll do a quick demo. I think that won't take too much of time. Guys, give me excuse me for the noise. I'm just trying to share my screen.
All right, Prince. And I think you're on mute, Prince. And I think we'll take up some questions in the end. Maybe I'll let you go forward with your presentation first.
Yeah, I started sharing my screen. If you guys let me know if you guys are able to see my screen now. Is it coming up?
I'll stop sharing.
Yeah. I'm already sharing. Okay, yeah. I think now it's coming up. Okay, guys. I'll just show you how we connected these two. So what we are trying to tell you here, guys, that everything data warehouse is generally is because you start doing data warehousing because you want to tell the data story to someone, and telling a data story is always comes with from a reporting perspective, that you want to report something from the data source. Whenever you do data warehousing, any data warehouse project ends up in a reporting solution. Okay, so that's where it comes out to be a proper bundle solution end to end. You do not just store data for just anything, but you do store data for doing some analytics and doing some reporting, and that's the time when this Power BI, these reporting solutions comes into picture. And if you see from Azure Synapse world also, Azure Synapse actually integrates every part of it. But for now, today, what we are trying to show you is how you can use the dedicated SQL pool to connect to Power BI, and then you can do your reporting. Okay, so for this one, Naveen has opened the firewall towards why. So Naveen has used his own Synapse so-called store, Azure store, data warehouse, and but I'm still able to connect to that data warehouse with the SQL connections, SQL authentication, but from a so-called outside his network. So he has opened it. So these settings needs to be done across in every time. If you're in a same network, if you're connecting via Azure Synapse Studio, you don't need it because the networks are open already on that part. Okay, so what you can do, you can go to the data sources, get data, go to the Azure, then you see this is where your Synapse Analytics comes picture, where and I'm just telling that there's a dedicated workspace. You can connect to that workspace and start connecting it. But for now today, what you're gonna do, we're gonna see it from a Azure SQL database. So I'll connect. I've already connected the data, so you can see it's already there. It's just I'm just trying to show you. Uh, okay, so this is the data. If you remember, Naveen was showing the server when he created the first one. Then he gave the database. So for this dedicated SQL pool, you guys can use both the things. You can use direct query also, you can use import as well, depending upon how much data you're importing. It usually with Azure SQL DB, we prefer a direct query rather than an import mode, because direct query is always, while then you can use lot of the power of Azure to do the processing as compared to doing it in Power BI. So importing one will make your Power BI much more heavier in a sense. Okay, so I can go and connect. Okay, let me open a new one because it won't show because I have already connected, so that's why it's not giving those things. I'll show you another way. Let me open up another Power BI file. And once you integrate this data, so like Naveen was telling that even you can connect, so what you can do, you can create a CTAS on a JSON file, that is a unstructured or semi-structured data inside your data lake. Create a CTAS table on top of it, create views and all this stuff, and then pull that CTAS table into your Power BI. So there's an endpoint connection that you can use it there to connect in within the studio itself, and then you can take the data there from itself. So you can imagine, uh, you can imagine it opens the world of analytics across, where you can use directly the queries on top of the, if you're doing just a small analytics on certain small data marts, you can start doing it without having to go ahead and do build multiple stuffs across. So these are this is the power that it comes with when it comes to this so-called connection. Just give me a second, let me see if I can show you from here. I think I have. Okay.
Yeah, you're connected.
Yeah, yeah. I'm already connected. Yeah. No, I was just trying to see if I can. I wanted to show that how where there's Windows authentication and SQL authentication and all this. So just give me a second. I'm just trying to because I'm already connected, so it's not letting me show those parts. Mhm. Okay. Because if I go and connect this one also, it will auto connect because it knows now it is storing the credentials. Okay. I hope demo god saves me here. Let me see. I think it will again connect directly without. Uh, Naveen, can you just create a blank database? One small blank database there.
Yeah. Sure, Prince. If you go to get data again, I'll tell you.
Okay.
Yeah. Go to get data and choose more Azure. Azure and use analytics systems, Azure Synapse Analytics. I think that's the capability we want to show here. Yeah. Just
Yeah.
connect. And now type in the server. I've already added your firewall in my
Okay.
so you will be
No,
able
but
to
that
connect.
is already connected. That is there already on the other one.
No, no, no.
Um, it's already there, so I'm just not letting me connect to that one.
It will let you connect now. I set up your firewall. And yeah, go with import.
It's fine. No,
Yeah, so that's
this
it.
is coming
That
directly. This is coming directly. I
no,
want to
no,
show
no,
them the authentication mode. I
no.
want to
That's
show them
okay. It's there are
with
both the ways. I mean, you can use import mode. You can even use direct query mode.
yeah, no, authentication mode. I want to show them all the three authentications, Windows and the Azure admin and all those three authentications. That screen is
So
not
anyway, let's
there.
go with this first, and maybe
Yeah,
we'll
yeah,
show.
yeah, yeah. That I have already there in that other Power BI file. Give me a second. Yeah. So I've already imported these tables across. If you see, guys, it's already there. I can go ahead and show you edit query. Okay, so you can see Naveen, you created one so-called CETAs table also. Let me import that as well. Give me a second. There's one CETAs table that you created just now, correct?
Yeah, it's a test employee. Yes.
Yeah, give me a second. Oh, okay. Yeah. What was the name?
Test employee. I think it will be in the. Yeah.
EXT test employee, correct?
No, this is external. If you can go up, there must be one test employee.
Um,
Or you can pick up any table. That's just the physical table. You can just use the dim employee table.
no, no, I was just saying if we can show them an external table itself. There
Okay.
will be an external table.
It's in
This
the it's in the end. It's their external test employee.
yeah, correct. We'll use this one. Yes. So see, this is the external table that Naveen created, and we were able to still able to query it inside this Power BI itself. So you can imagine this how we can leverage what is done that is not even structured to a structured format first in data warehouse, then with the so-called capabilities of the nodes, capability of the so-called Azure services across in and making it such a fast queries across in the whole scenario. Uh, this is how we are trying to show you from the starting of the data life starting of our data towards the end of the data presentation. So it can move so fast with all the so-called dedicated pools involved in it, and then you can scale up and scale down as per your need basis. um, I'm not sure if Naveen covered that topic of scaling up at time of ETL,
Yeah.
that is time when ETLs are running, and scaling down at the time of ETL is not running, so that
Sure. Yeah, I'll show it quickly. I think yeah, we
yeah,
have
yeah,
just 3 minutes. We'll cover
yeah,
that.
yeah. If you can show that will give them another node of how.
Yeah, I'll share my screen now.
Yeah, yeah.
All right.
I'll stop sharing. Just give me a second. Then you can start sharing.
Okay.
I still can't see your share. Is it there?
You guys can see my screen, right?
No, not yet.
I'll share it again just in a moment.
Yeah.
Friends, you can see my screen, right?
Hmm.
Yes.
Yes.
All right. So the options that we have here is we can anytime pause data warehouse. So that's the advantage that we have here. Now, if you have a Azure SQL database, you won't be having that options there. Here, we can simply pause it, and we will be only paying for the storage. And uh, when we pause it, we won't be giving any money out for all of the compute that we are using. So that's the good part about using data warehouse. Anytime in our, let's say, non-prod environment, we want to save cost, so we can simply uh, pause our entire warehouse and we can resume it whenever we want. Another advantage is we can we can scale out these unit at the performance level. We can do it from the portal. We can also do it from using PowerShell and all those different offering. So I can simply scale it. That's manual, but we can also schedule it using based on our workload and all those Azure alert that we can place in. We can put an automation runbook on top of that, and it will scale it to cater the need of the performance that we are looking at. So let me simply pause it as part of this demo. So that's it, guys. I think this is just to show what data warehouse offers, how it offers, and what's the capability and the load it can take up. That's it, Elias.
Yeah.
Fantastic, Naveen and Prince. Thank you so much for the presentation on the Synapse analytics capability. I hope the audience really enjoyed your content and learned a bit to apply this in their enterprise and day-to-day activities. And thank you so much once again. And it was a pleasure hosting you guys at AZConf. Thank you so much.
Thanks. Thanks,
Have a great day there.
Elias. Thanks.
Bye.
Thanks.
Okay, so next up we have Antonio joining.
Hi.
All
Can
right.
you hear me?
Yes, we are live and
Perfect.
you're on screen at this moment and people can watch.
Okay. Let me share my screen so we'll check
Please
if
go ahead.
everything works as expected. Let me know if you can see my screen.
Yes, it has come up, and thank you so much, Antonio, for joining us at AZCon 2021.
Thank you.
It is it's a pleasure hosting you again. And this topic is very close to my heart. Cloud native CI/CD with GitOps, especially in my organization, that is something that I work on a bit. And this requires good exploration. Upskilling on this topic, and I hope your session would definitely add value and people could gain something and apply them on their job. Thank you so much again, and the stage is yours.
Thanks for having me. Thank you. So let's start. I'm so thrilled to be here at the Azure Community Conference. I hope you enjoyed the conference so far. My name is Antonio Liccardi. And in this talk, I want to talk about GitOps and how you can improve the deployment of your applications using GitOps. These are my contacts. If you have any queries, please shoot me a message, an email. I will be happy to answer you. Let's see the agenda of this talk. We will start with a GitOps definition. We will look at some principles related to GitOps. We will talk about the differences between DevOps and GitOps, and then we will talk about tools and best practices to use when you want to use this approach. So what is GitOps? GitOps is a way to do continuous delivery. It works by using Git as a source of truth for both both declarative infrastructure and application. This means that your Git repo will contain both the application code and the infrastructure code. For example, if you use Kubernetes as your host environment, you will have in your repository both the application code and the YAML files for your deployments and for your services. And thanks to Git, you can use Git events to have some sort of automation, and this automation will take care to roll out changes to your infrastructure. So, what are some principles related to GitOps? The entire system, the system where you will deploy your application, is described by using a declarative approach. In this case, we are talking about infrastructure as code. If, of course, as I said before, if we use Kubernetes, we will use a YAML deployments file and YAML services file. And these declarations are the desired state of your system. And the desired state should always match the actual state on your host environment. All these declarations are stored in Git, and each time we do a change in our Git repo, we should approve the change using a pull request mechanism. This way, we are giving more reliability to our code, and also we are improving the quality of our code. And then there is a service somewhere in our infrastructure which will take care of checks related to our desired state and the actual state. If these two states diverge, which means that are different between each other, the same service will try to first alert you using a notification system, and then will try to converge the desired state with the actual state. Git is the actual source of your entire system, and it is the single source of truth. Any change that we will apply to Git will trigger an operation. This operation will probably start a pipeline. And again, we have our application code side by side the infrastructure code in our Git repo. And we should not use tools such as kubectl because are not reliable. We could lost some commands. We could have a problem executing specific commands. If we have everything stored in a release pipeline or in a build pipeline, we have a more reliable process. And when we have prepared the entire workflow, the process, as I said before, is guided by pull requests. And from here, we have an entire automated approach. Also, to force pull request on our Git repo, we can protect our branches. If we should define GitOps in one sentence, we could say that only what can be described and observed can be automated and controlled, which means that if we can describe our infrastructure in some way, such as YAML files, and if we can observe with some tools our infrastructure, we can of course automate the entire process, and we can control the situation where the desired state is different from the actual state. So what are the differences between GitOps and DevOps? GitOps is mainly based on DevOps. So they are related. And why we talk about GitOps only now? DevOps is in the IT world from 10 years by now. Why now? Well, today we have tools that can help us to create our infrastructure using code, tools that can help us to monitor very well our infrastructure. And then, thanks to these tools, we can apply GitOps correctly. And also, thanks to Git and thanks to how Git works, we have a bunch of features that can help us through this process. What are the GitOps advantages? First of all, we have increased productivity. If we have everything automated, the release time of our application will decrease. So we can have multiple deployments during one day. We have a better developer experience because Git is a tool that a developer already knows. And this means that the learning curve is smaller. We have compliance and stability thanks to Git, thanks to auditing. If we should, if we have to use some regulation in our process, such as SOX, we can have it thanks to Git. We have a higher reliability, so we have a smaller mean time to recovery, because if we use Git, we can use the git revert command to automatically revert or roll back our changes. We have consistency and standardization. Since we have Git, we can use a Git workflow such as GitHub Flow. So we have a good consistency. And finally, we have stronger security guarantees. For example, if we use Git, we can sign our commits to have stronger security. GitOps has 3 pillars, which are pipelines, observability, and control. Let's start with the pipelines. This is a common build and release pipeline. We have 2 distinct phases, continuous integration and continuous deployment. When we write our code and we commit our code to a version control system, this will trigger a build pipeline, which will build and test our software. At the end of the pipeline, we have an artifact, and this artifact, if we talk about cloud-native applications, if we talk about Kubernetes, this artifact is an image artifact, and the image artifact will be usually stored in a container registry. When a new image is available on our container registry, a continuous deployment phase will start. And in this phase, we will have a deployment of our image on a Kubernetes cluster. This is a push-based approach because everything starts on our commit, when we do our commit in our application repository, and then our artifact will reach the target environment. More in detail, we have an application repository which triggers a build pipeline. We have an image pushed on the image registry, and also we have a new version of our environment repository, because remember that we have our code side by side our environment configuration. When we update the environment repository, this will trigger a deployment pipeline, which will update the target environment. So this is a push-based approach. When we talk about GitOps, we are talking about a pull-based approach, which means that the first part will usually remain the same. So we have a git commit, we have an update on our repository, we have a build pipeline. This build pipeline will create a new image, and this image will be stored on a container registry. But when we use Kubernetes, when we use GitOps, we will have a Kubernetes operator on our cluster that will take charge of update our infrastructure and our application code. So what happens here is that the operator will check the container registry to see if a new image is available. If yes, it will update the cluster. More in detail, we have our application repository. When we create a new commit, this commit will trigger a new build pipeline. The build pipeline will push an image on the container registry and then will update the environment repository. The operator on our target environment will check the image registry and the environment repository, and if there is a new version, will update the target environment. Sometimes the operator will also update the environment repository. For example, if we have a new image registry and we have not updated the environment file with a new image version, the operator will take care of that. We can do GitOps thanks to observability, because as you have seen in the previous slide, the operator should observe the container image registry, should observe your environment repository, but the operator should also observe your infrastructure, the actual state of your infrastructure. And if there is a divergent state, the operator should take care of converge the desired state with the actual state. How we can do observability? Well, of course, we can use tools that we already know, such as logs, metrics, and traces. Then we have a control. What is control? Control works closely with observability, and controls means convergence, because control is the operator that will match the desired state of our application with the actual state of our target environment. So more in detail, what happens here is that we have our Git repository with the desired state of our application. When we have a new change in our repository, our GitOps operator will update the running infrastructure. And if there is something that is not working correctly, thanks to observability tools such as Prometheus, Grafana, Datadog, and so on, the GitOps operator will check the actual state with the desired state and will know if should apply some changes to our running infrastructure. So GitOps Git is at the center of everything. We have from one side we have continuous integration, so build, test, artifacts, and from the other side we have a GitOps operator on our Kubernetes cluster that will monitor our infrastructure, will update our infrastructure, and will update our environment repository if necessary. What about our repository? Well, we can have different ways to configure our repository. We can have one repository with everything in it, such as application layer, Kubernetes layer, infrastructure layer, or we can have multiple repositories. For example, we can have two repositories where we can store, where in one repository we can store our application layer and Kubernetes layer, and in the other repository we could store the infrastructure layer. If we use one repository, we can also use folders to differentiate between these layers. And inside these folders, we can have subfolders to differentiate between among different stages of our application, such as production, staging, dev environment. So to sum up about a Git repository, we can have one repository per application, one repository for environment configuration. Usually branches are mapped to environments. So I will have, for example, my develop branch mapped to stage environment to another environment. I can have my main branch mapped to stage or production environment. And always remember that when we make a new feature in our code, we always have to update all the infrastructure application code. So these configuration are side by side with our application code, and we need to update both our application code and our infrastructure code. Remember that we can use a revert command to roll back our changes. And remember that we can use protected branches to force developers to use a pull request mechanism. So let's have a look on how to do GitOps using some tools. I have a couple of demos for you today. The first demos is related to Argo CD. What is Argo CD? Is an open source tool. Is practically a GitOps operator, and this tool will update automatically your infrastructure by observing a Git repository. First, I will create a namespace in my Kubernetes cluster. I have a Kubernetes cluster on Azure, so in Azure it is an Azure Kubernetes cluster. I have just created a new namespace, and then I will use this YAML file to install my Argo CD operator. This is the installation YAML file provided by the Argo CD project. This project is on GitHub if you want to take a look at that. I will create the operator. So I'm executing this command. As you can see, Argo has been installed successfully. If I wanted to check if everything works as expected, and if I want to go to the Argo dashboard, I can use this port forward command. So Argo is very interesting because it has a dashboard that we will see now. And this dashboard is very helpful because it gives you all the information related to your applications and also to your cluster. So you can see in here all the services related to your application, deployments, pods, and so on. I have to authenticate myself on the Argo CD dashboard. I need the password of Argo CD. I can take the password here. I need a git bash. This is my password. Let's log in. Here we go. So this is the Argo CD dashboard. Here I can create an application, which means that I will create an application to observe with Argo CD. I will give a name here, which is guestbook. I will use the default project, and then I have to specify the sync policy. This is very important because you have two different approaches. The first one is a manual approach, which means that when you have a new version of your application and of a new version of infrastructure of your application, Argo will alert you of this new version, but you have to manually update your cluster. If we choose the automatic policy, everything works automatically. So your application is automatically updated by Argo CD. In this case, I will choose manual approach to show you a couple of things. Then we have to specify our application repo. I have an example here that I will take. I will paste the repository here, and then I have to choose which folder in my repository I want to check, I want to observe. Here I can also specify branches if I want. Then I have to specify my cluster. This is the default cluster where I'm in. And then I have to specify the namespace where I want to create my application. In this case, I will use the same namespace of Argo. Good. I have typed everything here. I will click on the create button. And as you can see, Argo has created an application in my dashboard. The first thing that we can know is that the application is missing on the cluster and is also out of sync with the cluster. If I click on the application, as you can see, I have a very straightforward dashboard, which will show me all the services, the deployments related to my application. And if I click on a single box, here I have lots of information related to my services. I have parameters, I have the manifest of my application, I have events, and so on. Same thing for services. If I go on services, I have the summary of my services. And as you can see here, I have a live manifest and a desired manifest. So Argo will show me if there is a difference between the desired manifest, my desired state, and the live manifest, which is the actual state of my cluster. If I want to apply these changes on my cluster, I can click here on the sync button. I can then specify some options, and then I will click here the synchronize button. As you can see, Argo is creating all the information related to my application. And specifically, Argo is reading my application repository, and specifically is reading the files that are created inside this folder, such as the front-end deployment YAML file, and it will create for me all the services related to my application. If I click on a specific box, such as the pod box, as you can see here, I have a couple of information related to my pod. If I click on the events tab, I have the events related to my pod, and if I click on logs, I have logs related to my pod. If I go back in the summary tab, you can see my lab manifest. So this is the manifest that I'm using for my application, and this is the actual state of my infrastructure. Good. What happens if I have a new version of my application? Well, first of all, I have to update my application repo. To do that, I will go here in my front-end deployment YAML file, and I will make a new change. I will change the version of my application. When I commit this change, Argo CD will observe the repository and will warn me that a new version is available. If I click here on the refresh button, remember that I'm using the manual policy here. As you can see, the actual state of my cluster is out of sync from the desired state. And if I want, I can apply a new version clicking the sync button. So I will click here the sync button. I will synchronize my application, and Argo will take care of update my application. But during this deployment, as you can see here, there is a problem. So Argo CD will alert me about this problem, will show me that something is in a degraded state. If I click on it, if I click on this pod, I can go in the events tab, and as you can see here, I have a classic Kubernetes error related to image. Kubernetes cannot pull the image, the new version image. So what I can do in this situation? I can do two different things. The first of all, I can use Argo CD to roll back my changes. I can click here on the history and rollback button, and as you can see here, I have two different revisions of my application. The first one is the version 6, the first deployment. And the second one is the version 7. This version is the one I have just deployed, and this version is causing me trouble. What I can do here is click on this settings button and roll back to my previous version. If I click here, if I click OK, in a second, Argo will update again my cluster, and everything will work as expected. Here we go. Of course, we have a state of out of sync because the desired state in our application repository is different from our actual state, because we have a version 7 on our repository. What I can do here, I can do a git revert command. So if I know that that version, the version 7, is not working, I will do a revert, and then I will make some changes to my code to fix bugs and so on. A couple of more things about Argo. If I click here, I can have a different view related to my cluster. I have 3 nodes here. I have a couple of icons that show me the pods, how pods are distributed on my different nodes. If I click this other button here, I can see how communications are working inside my cluster. And then if I click the last button here, I can have a list of our services. So it's very useful if we want to check all the services related to our application. Here in Argo, I can add as many applications as I want. So we can use this instrument, this tool, to manage lots of applications. And I think this is very straightforward, it's very simple to use. If you don't want to mix your hand dirty using a command line interface. So this is my first demo for you. And this is a very interesting tool. But another tool that I want to talk about is Flux. Flux is another open source tool that we can use on our cluster to use the GitOps approach. Flux is created by VivoWorks, which is the company in which GitOps was born. So Flux is a command line interface and is very flexible, and you can use to manage different kind of things, as I will show you in a while. To use Flux, we have to install it. It's a cross-platform tool, so you can install it on Windows, Mac OS, and also Linux. In this case, I'm on Windows, so I will use Chocolatey to install Flux. But you can use the tool, that you want to install it. Then, if I have a cluster and I want to install Flux on my cluster, I should execute this command: Flux check pre-requirements. This command will show me if all the requirements related to Flux are okay. I will change here my terminal. Let's open a new terminal. Okay. So, Flux check pre-requirements. As you can see here, all checks are passed. So I can install my Flux tool on the Kubernetes cluster. To install it, I will use a GitHub repository. because in this repository, I will store all my cluster configurations. So I will have one repository for my application and for the Kubernetes declarations, such as deployments and services. And then I will have another repository to store all my cluster informations, all my cluster configurations. To create a new cluster automatically, to create a new repository using Flux, I need a GitHub token. This token will have access to my GitHub account and have a specific permission to create a new repository. And when I create this repository, I will observe on the main branch this specific path. This path will contain all the configuration related to my cluster. And as you can see, I can also have multiple configuration related to multiple clusters in this repository. So I will have different folders, each one related to a specific cluster. Okay, let's execute these commands. Let's run these commands. Okay, I'm using here the get secrets. This is the secret management PowerShell module. I suggest you to use it. It's very useful. So let's check again. 1, 2. Okay, perfect. And then I will create my environment. Oh, something is not worked correctly. I will try this again. So I'm creating my environment repository, and in the meantime, Flux will also install the operator on my Kubernetes cluster, because it's the cluster that I'm using right now in my kube config. Let me just execute this command again. I want to make sure that everything works as expected. After that, I will clone the new repository to show you how it has been created. So I will execute this git clone command, and I will switch to this folder. As you can see here, I have a couple of YAML files. I have a customization file, which is just a pointer to other two files. The components file is a file which contains all the resources related to Flux. And then the sync file will contain information related to my new repository, the environment configuration repository. And then it will have the customization resource that will specify how Flux should observe this repository. What I can do here is tell Flux to observe an application repository. So I have created my environmental configuration repository. Now I have to tell Flux which application I want to deploy and observe for my cluster, to host on my cluster. And I can do that using this command: Flux create source git, name of the git repository, the path where the repository is, the branch I want to observe, and the interval I want to set. So this means that every 30 seconds, Flux will check if there is something new. When I execute this command, as you can see, Flux created for me another YAML file. This YAML file will contain all the information related to my application repository. After that, I can deploy my application, And to do that, I will create another customization. So this customization will tell Flux which path observe and which repository observe. I will execute this command. I had some problem here. Let me just execute it again. Okay. Just reopen the terminal. Okay. Okay. To start the synchronization between Flux and the cluster, I have to update my environment repository. As you can see here, from Git, from PushGit, I have 2 new files in my repo that I should commit. So each time we do a commit, Flux will check the new configuration, and if necessary, it will update my target environment. To do that, I can execute git add command, git commit option m app configuration, and then we can push our changes to the configuration to the environment repository. As you can see here, I have another Flux command, flux get tool. Right now I have just 2 items here. The Git repository related to the Flux system, which is the repository where I am storing my environment configuration, and the customization related to this repository. As you can see here, I have also a couple of information related to the branch I'm observing and also the latest commit. If I execute again this command, as you can see now, I have a new item, such as the Git repository resource related to my application repository, which means that Flux has observed my configuration repository, my environment repository, and has applied all the necessary changes, which are something like the deployment of my application, and the Flux is making sure that the desired state of my application is matches the actual state. Let's check the pod in my services in my cluster. As you can see here, now I have my azconf app, and I can always use this IP to check if my application is working correctly. So if I open this one here, maybe the port is 8080. As you can see, this is my application, and it's working, and this is the latest version of my application. The synchronization process is always running, but if we want to suspend for some reason this process, we can use the flux suspend command. If we want to resume this process, we can use the flux resume command. If we want to delete a customization, we can use the flux delete customization command. And finally, if we want to uninstall completely Flux from our cluster, we can execute the flux uninstall command. This is a way for me to clean up my environment before the next demo. So this is a very straightforward example, but in real world, you will have a couple of more steps related to automation. For example, if I have an image repository where I will store a new version of my application, I have to update the deployment file with the new version. For example, if I have a build pipeline and this build pipeline will create a new image, I don't know before the build pipeline which is the new version number. I will know the number after the build pipeline has run. So what happens here is that when I have a new image, I will tell Flux to update my YAML deployment file. And Flux will update the version of my YAML deployment file. And since there are a couple of automation behind the scene, Flux will also update my cluster to the latest version of my application. Let me show you that with a new example. As I've showed you before, I need these two variables here. I will make sure that are available again. Very good. And then I will create another Git configuration, Git environment repository. This is different from the previous one. It has a different name. But here it's important to let you know that these parameters are the ones that help me to observe my image repository and to apply some sort of automation. These are Flux components, and you have a bunch of components that you can use in your GitOps operator. So this is the repository name. This is the branch I want to observe. This is the path I want to observe. I will create now the repository. So Flux will create the repository and will install again the Flux operator on my cluster. Remember that I have deleted the Flux operator on my cluster in the previous example. Then I will clone this repository and I will check what's in here. Okay, I will do a step back here. Okay. Let's clone it here. Okay. And then I will switch to another folder. Okay, here we go. So these are the same files as before. Then I want to deploy a version of my application. I will deploy it manually to show you then how the automation works. Here I'm deploying the version 0.1.0-2. As you can see here, using the kubectl command, my application is available and ready. And I will copy this same file to the Flux update repository. So I will then create some sort of automation to tell Flux to update my repository. Okay, let's go. So in order to observe my container registry, the one where I store my images, I have to create a service principal. This service principal will work with the Flux to observe the container registry. I have my container registry here. Let me go back to this resource group. This is my container registry. I have here a repository for EasyConf app, And as you can see, I have 6 different versions of my application. I have just deployed the version 2, this one. Then after, with the Flux, I want to update automatically this version. So I can do that first using a service principal. So I will create it. And this service principal will be used in this image repository configuration. I will also create a secret. The secret is the secret that we will use to connect to our registry. And then I will execute this create image repository file. I will execute this command. As you can see here, this command will have different parameters, such as the Azure Container Registry I'm using, an interval, and this command will will export all the configuration in a file, which is this one. As you can see here, I have an image repository resource, which point to my Azure Container Registry. And I have to specify, besides my image repository, also the image policy I want to use. For example, if I want to observe just a specific version of my application, so if I want to use a matching pattern, if I want to use semver, I have to specify this policy. So I can do that using the Flux create image policy command. And here I'm using this select semver option. In this file, you can see all the requirements I have just specified. And then if I want to to access correctly to my configuration registry, I have to tell Flux which secret to use. And I have to paste these parameter in my registry file. I have to put this secret here. So in this way, Flux can access to my registry. This is simple as I'm talking about. So we have just to execute these couple of commands, and then Flux will be configured to observe our container registry and to update our application. To do that, of course, I have to commit my changes to the environment repository, because otherwise Flux doesn't know nothing about this. So I will commit these files, image repository, and then I will push this new configuration. If I don't want to wait the Flux interval, I can force the reconciliation process. I can execute the Flux reconcile customization, name of the customization command, and then Flux will update everything for me. If now I will execute this Flux get image repository command, as you can see here, Flux has successfully accessed to my image registry and has found 6 tags. I can also use the policy to check which is the latest tag. And as you can see here, the number 7 is the latest tag. Now, how can I automate all the deployment update process. I have to tell Flux which file I want to update, which folder I want to update, and where this file is stored. In this case, I have everything in my configuration repository. I have copied before this deployment file, and I want to update this number. To update this number, Flux needs a placeholder, which is this one, as you can see here. This placeholder will tell Flux which image policy I want to use and also the namespace where the image policy is stored. So to configure the automatic update, I have to create a new image update process using the Flux create image update command. Here I'm specifying the repo, the path inside the repo, the branch to observe, and I'm specifying also a couple of things related to the commit, because when Flux will update the version, it will create a new commit. If I execute this command here, I will create a new file. Come on. Oh, come on. Let me check if everything is okay. It should be okay. Okay, so this is the branch, the interval, the repo, the path, the commit message template, and so on. It should be okay. I have to update my environment repository. So I will do a git add git commit option update image. Oh, sorry, I have to switch to the other folder. Oh, no, not this one. TDZ, this one. Okay, let me just check for a second. Oh, not so. Okay. Hi. Let me do this again. So as you can see here, I have one file modified, one file created. I have to commit this file. Git commit option image update. And then I will push my changes, my commit. Now I can force reconciliation here. So Flux now have a new configuration to update my deployment file. And if I execute this command, Flux get image all namespaces. As you can see here, I have a couple of information related to my images. If I execute these commands again, I have 6 tags. I have the latest tag. If I execute Flux get image update, I have a couple of information related to my images. But in the meantime, Flux has done something for me. If I go back to my repository, I have something here. Let me check if it worked. Deployment. As you can see, my repository, this file, let me go back to Visual Studio Code. This file that I have here with version 2 has been updated by Flux. If I do git pull in my terminal, as you can see here, now I have a new commit created by Flux to update the image of my application. And this is very helpful because we don't have to worry about how to update our image deployment files. So Flux is a very useful tool. It has a bunch of features. It's a command line interface tool, and I really suggest you to take a look at it and start to use to deploy your cloud native application. That's all I have for you today. So I will check if there are any questions.
So, Antonio, thank you so much for the session. So there's one question, whether we could use GitOps with Kubernetes, and I think you answered the question
definitely.
in the session. So I guess it helped our audience in India at AZCon 2021, and thank you so much for joining us.
Thanks for having me. Thanks.
Yeah, thank you so much. And we have Rick joining us very soon. Thanks, Antonio. Bye. All right, so the next session is a little more interesting, and it's one adult-only session. And to present that, we have Rick online, and this is Even Grid Deep Dive, and it's only for adults.
Yeah, only for adults, only for senior developers. Okay. Okay. Thank you to join us today to this wonderful conference. I would like to thank you all the organizers, first of all. And with this session, I would like to introduce a series of consideration regarding the usage, the real usage in production of Event Grid. Okay, because from my point of view, it is under-evaluated, and probably the majority of the developers consider Event Grid something that is good, but is not ready for production. It is not manageable. You cannot govern it using standard tools. So if you don't, if you are not able to manage it, you don't use it. Okay. So my session, the goal of my session is to introduce something more interesting about Event Grid. Okay, regarding its kind of usage. Many use cases. The first large use cases I've approached with Event Grid is regarding extended supply chain purposes. Okay, so probably if you want to view millions of lines of code, this is not the right session for you. The session I would like to present you today is regarding the meaning of. Okay, I'm not the best developer in the world, absolutely not. Probably one of the worst. Okay, but I am involved into IoT and supply chain projects from many years, and I would like to share with you my experience regarding that. Okay, so first of all, let me share my screen. And start with the presentation. Okay, so I hope everything is okay. Once again, thank you to EY, Microsoft, and the Elastic as main partner and sponsors of this event. Who am I? Who is Riccardo Zammana? Some bullet point. High blood pressure due to IoT products since 2011. Many phase, some goal, more than 50 young people raised in IoT and industrial IoT. And I'm a fellow, I'm a driver about servitization model, especially in manufacturing. Okay, and when you deal with the servitization, you deal with the events that are happening, and you are to and you deal with govern all of these kind of events in order to retrieve costs, consumption, and retrieve a new pricing model. So this session is a sort of deep dive regarding one simple object, but can be a very complicated object if you use it to manage supply chain projects. So which are the main concepts that we will talk about today? So some consideration about the services itself, and more than one consideration regarding the management in production environment of Event Grid, and a sort of a wrap up in terms of development, okay, using some tool, using some Visual Studio Code plugin and so on. Some news about Event Grid, because the perspective of this product is changing into two new environment applications. So on the edge world and the cloud native world. And after that, the use case regarding supply chain. So if you understand event-driven approach, you are welcome. If you have delivered at least one of event-driven application, it is not important to be an expert, okay, of Event Grid, but you have to understand which are the difficulties in order to manage not the go live phase, but the daily phase after the go live, day by day. So the first one, the first slide is about considerations, okay? So when you deal with Event Grid, you deal with events, but when you talk to Azure about events, it can have many responses to you. So one response regarding events is about diagnostics logs, okay? And you know, in Event Grid, you can publish something that is similar to a log, okay? But it is not event driven, it is a batch, and so it is intensive, and you have to constantly pull the feed to determine if there are changes with a diagnostic log, okay? Probably the payload of a diagnostic log is very complex, and it is not filterable. Okay, you cannot filter any payloads when you use a diagnostic log, and so it is different from Event Grid. Keep in mind one important thing. When you use Event Grid, you have to stay as simple as you can with the payload that is passed from one service to another, okay? Because there is a sort of pattern that is the VALET key, okay? VALET key, okay? This is the main pattern that is behind this kind of usage, okay? In terms of event-driven communication. The second one, the second feature that you can find in Azure, okay, that is regarding events, it is the alerts, okay. So both mechanisms are using a push-based mechanism, but events typically contain contextual information about what happened, while an alert provides information about the alert criteria, okay? So you deal with different kind of information. And another important thing that an important consequence is that you have to interpret and you have to evaluate the meaning of an alert, okay? Because it is a sort of notification. Instead, the Event Grid can contain all the foreign keys of all the entities that you have to manage. And alerts are not near real time, okay? Because you know, for example, when you deal with something like Azure Monitor, okay, all the alerts are the result of an evaluation that is made every 5 minutes or every minute, okay? It is not a near real-time event. The change feed probably it seems to be the most near, okay, to Event Grid, but a change feed is stateful. But and on the other side, Event Grid can be stateful, but it is stateless. Okay, can be stateful if you manage the persistence of the message that is not already delivered to the final destination. Okay, it is not a film. And another important consideration is about webhooks. So the webhook, consider Event Grid is a sort of superset of webhooks. Okay, because when you deal with webhooks, you are dealing with the pub and sub transmissions that are isolated. Okay, so while a webhook can be pushed to subscriber, Event Grid allows you to have an overview of all your active subscription without the publisher having to worry about who is interested. And so another important thing of a webhook approach is that the filtering, it is a sort of external provided aspect. Okay, so if you want to filter webhooks, you have to put in a sort of ambassador pattern in front of the client, and behind that you have to code all your real service. And it is a sort of the filtering is a sort of ambassador method. Okay, but is the ambassador of that webhook. And so you do not have the possibility to centralize all the filtering. Okay, many considerations. So remind that all these kinds of events are different from Event Grid, and consider Event Grid a sort of structure of well-organized webhooks the filters, all the dispatching phases, topic morphology, and after that can have not very intelligent services, okay, but stupid services with webhooks, with a HTTP webhook call, okay, with an ambassador behind in order to manage logs and so on. And after that, you can manage the real service. But the key benefits of Event Grid are obviously simplicity, because I can demonstrate you that is very simple to go live with an entire solution with a few lines of scripts, and you can Okay. Okay, guys. Sorry for the. Okay. Sorry, I don't know exactly what was happened, but nothing. No problem for me. I can reshare the screen
Yeah,
and
yeah.
start.
It's okay. It's okay.
Okay, sorry. I don't
It's
know
okay. It's
exactly
okay.
what is okay.
Thank you. Thank you.
Okay, so in order to go on, and keeping in mind that I have less than an hour, I would like to introduce you an important concept. Okay, what is exactly event grid? It is not the missing part to connect all the services around Azure. It is the missing part to connect more systems than Azure. So, for example, it is very important to understand what is a cloud event. The cloud event is a sort of standard in terms of JSON morphology, okay, in order to interconnect the systems that are heterogeneous between them. For example, in my company, we have more than one customer that is using a private cloud, so with Kubernetes, managed Kubernetes infrastructure, okay, all these kind of device families, okay, but we want to connect him with other customers, okay, who are managing the post sales. So all the digital after sales are external to the company, okay? And so when you deal with a claim that comes from a final shop, you have to intercept this kind of message, distinguish which is the right partner in terms of production, which is the right plant, and after that, you can pass the event of the claim internally to the plant that has got another workflow in order to manage that claim. So the cloud event, it is a strategy in order to connect heterogeneous systems. And imagine that if you have a challenge in order to build up a service that embrace many systems from AWS to IBM Cloud to Google Cloud and so on, how can you deal with it? You have to define standards, and the cloud event is one of them. But the second problem is to manage all the infrastructure between this kind of entirely disconnected systems. And so probably you want to use the already deployed worldwide service that can interconnect them. Okay, in that case, EventGrid is the unique alternative that you have. So the standard scenarios are regarding serverless application architecture. So React instantly to event or to deposit a data, okay, an event to a blob storage, and after that do something, okay. For example, a standard scenario is to asking to an edge device to give to you all temporal window, well-defined temporal window data regarding the process. So, for example, you have a claim, you ask to the process control engineers all the events regarding the production or a particular tracked product. And without using Outlook, okay, you can do that using events managed by a sort of grid of events between the edge and between the cloud. And now another important usage of Event Grid is the classical usage, so within Azure environment. So when you deal with automation, you can deal with the operation and automated operation, scale out, redefinition of services, new services that comes out because probably one firmware developer has deployed a new device within an experimental new device within a customer, and so on. And so you can notify all the Azure automation changes using one simple product. Even the subscription creation event, okay, is a part of this notification system. And obviously, when you have to integrate different applications, you can connect them with the event grid. But remember, event grid is not a pipeline ingestion system. Okay, so the systems are decoupled. Okay, if you want to interconnect them with a strict pipeline, don't use event grid. Use another system, another architecture. Okay, when you want to notify uh, when you want to notify events, okay, with a long-term operation management. So I ask you to manage a claim. After 1 hour, okay, you say, okay, I am managing. After 4 hours, you send me. I manage it, and I have at your disposal to give you all the data. And after and so and so and so. And in this use case, you can use event grid. Okay. So the real advanced scenarios are okay. Already said examples. So extended supply chain is one of them. The other one is the process dossier automation. Okay. So claim, product tracking, a sort of report. Okay, that comes from many systems, from the MES, from the ERP, from the raw material manager, from the the IoT, okay, in the strictly meaning, and so on. And you have to resume all of that data and process it with another tool that is disconnected, okay, in order to give with the right brand, the right colors, exhausted report to the final customer. Another important thing is to change things and change the way the IoT pass you the data. For example, when I worked with the automotive, with an automotive company, they said that when there is a theft, a car theft, you have to change all the information sampling. Okay, so you have to reconfigure the edge environment in order to gives you a more frequent GPS position. Okay, in order to identify the right location. And at the same time, you have to advise police. At the same time, you have to ask your driver to gives you informations. And after that, you can deal with other things, such as insurance company, for example. Okay, so if you want, we can speak about the right organization of streams. One of the limits of event grid is the static creation of the topics. But when you have a dynamic system in which every topic is dynamic, because you don't know exactly which are all the cars that are connected in a fleet, okay? But every day some new car goes up, okay? And all of that cars must be linked to the insurance companies, or must be linked to the maintenance management systems, okay? But the maintenance management systems are different based on geography. You have to understand that you have a sort of dynamic architecture that can rise up every day in a different way. And so, in order to manage this kind of operations, is to deal with dynamic subscription of all the topics from one side, and on the other side, a dynamic generation of the topics. Okay. And so the unique way to do that is to use the event domain. So event domain, it is a sort of management tool, okay? All of those topics must have a sort of to associate dynamically all those topics to the right subscriptions without deploying new subscriptions. Okay. And probably you have to partition your topics when you deal with the multi-tenant architectures. And so in your topic structure, you have to keep in mind the tenant ID that is part of the topic. So when some sale to a new customer, the day after, with them, remember that all the topics names must be achieve one simple organization. So tenant ID,
I don't see. Hey, Ricardo, are you there? Hey, welcome back.
I don't know exactly with what is happening today to my ADSL.
No
Okay,
issues. No.
so
Yeah, carry on.
when we deal with the topics, we deal with the various types of topics, and you have to keep in mind that the system topics, so the topics that are dedicated to Azure, and are only subset. Okay, and probably if you look at to Event Grid as a sort of all system embracing service, probably the system topics represent a few percentage in your usage, because the domains are custom topics and you want to customize all your communications. After that, probably you can have the participation of some partner. Imagine that a partner is a sort of well-established entity, okay, that gives you the possibility to access to its own topics in order to manage a particular aspect of your business. Okay, in my if I have to dream something about my work, okay, it is a sort of I have to think to, for example, MindSphere, Siemens MindSphere. It is a sort of cloud services dedicated to IoT. Okay, it's good. Imagine that kind of services, okay, helps you to find out anomalies within something, okay, that is managed by that kind of infrastructure, and you want to release to him, to this kind of service, some aspect of your business, and you want to have a sort of strategy, standard strategy in terms of topics, in order to declare every time the same payload to the same topic that is managed totally with the total responsibility from another entity, okay, business entity. This is the partner topic. And after that, you can deal with, obviously, custom topics, okay? partners and domain are the two important things. And so when you think about the more larger usage of Event Grid, imagine that Azure is a partner topic, nothing else. As I said, event subscription can be made in the best way if you think about the morphology of the topic in terms of string. So the subject with the prefix filters and so on, it is the only strategy that you have in order to dispatch the right event to the right subscription. So subject naming pattern is the key. Event handlers. Probably this is a not well-known argument. When you start to play, okay, easily with the Event Grid, you play using simple webhooks. And so, for example, logic apps from one side and an event trigger client from the another side, one from the other side, and that's it. Yeah, but it is only a toy with this strategy. Probably you have to structure in a different way, more structured way, your handler. So the event handler, imagine that you can handle, for example, using the Event Grid handler about when you deal with Azure functions. But the real life, it is not made of 100% of Azure function. Okay, so probably the most useful way to interact with the Event Grid is to use APIs, so HTTP endpoints. And when you have an HTTP endpoint, you have a big problem because you have to manage various aspects about the API. So not only the server-side code in order to retrieve information, change something in the attributes, enrich, filter, or union the information with a sort of registry that you have in memory, okay? And after that, put the result into the storage. But probably you have to deal with the logging. You have to deal with configuration. You have to deal with the other secret breaker manage the services behind you. And so you have to implement another strategy. So imagine that you have a simple API, not an Azure function, okay? A simple API. So you can have a sort of HTTP webhook, simple, the most simple you can. First, you have to manage correctly all the responses because Event Grid interpret all the responses, the HTTP responses, with its own meaning. For example, if your status code is 400 status code, it is a sort of please retry. Okay, please retry. It is a sort of retry behavior. Okay, probably in a simple request response, 400 HTTP response is okay. Something is wrong. Call the developer and debug this API. In this case, when you deal with the Event Grid, okay, you have to manage all the correct HTTP responses, okay, in the functional point of view. So if you want to retry 1 hour later, okay, or half an hour later, you have to put the 503 HTTP endpoint, response. So service unavailable. And if you want to say something, okay, you can say, okay, forbidden, but the forbidden code will be retried after 5 minutes. So you have to manage correctly the HTTP response. And this is the meaning of the sidecar concept. So the ambassador service have to translate towards Event Grid all the responses that it receives from behind to the correct HTTP endpoint. Because imagine that your primary application must or should be an headless application. Okay, so with an entry point method and behind it all the code you want. But in front of Event Grid, you have to manage in a decoupled class, okay, all the tasks regarding proxying, circuit breaking, logging, and so on, and retry policies. In terms of delivery, you can define all the message delivery, okay, and also the TTL, the time to leave message of any message. But the retry schedule is something that is half enough. So you can define within Event Grid, but you can override using HTTP responses. Remember that two important things. The first one is that Event Grid doesn't guarantee the order of the messages. So please don't think to Event Grid as a sort of a queue. It is not a queue. Probably the most attention you pay to the topic hierarchy, the most guarantee order you can have. So if you dispatch your events to well segregated from the functional side topics, probably in that way you can obtain the more ordered way. Okay, the more ordered order of event delivery. Okay, but it is not ensured by the system. Another important thing is if you don't configure dead lettering, you don't have dead lettering. Okay, so if it is an important message, must be managed in the correct way. So two kind of consideration. The first one, how can handle every the 101% of the messages without losing anyone. First problem. Second problem is to have the correct architecture to handle all the dead letter arguments within your domain. Okay. In the past, I worked in a project with many queues, and we had two web jobs at the time. One in order to process the messages, one in order to process the DLQ messages for every single queue. So every time, in order to deploy an update, there was a boy, okay, that today is a man. At the time I was a boy, that had the mention, okay, to redeploy at the time manually tons of queues, DLQ managed jobs, okay, and it was not a good approach, okay. So in order to answer to the first question, how to structure an API, an HTTP endpoint, okay, a function API, it is not very important, in order to handle the 100% of the messages, is important to say that you have to deal with two services. The ambassador, that is a sort of aspect-oriented programming helper, okay? And probably you have to deal with activities. In a few minutes, we will talk about activities in order to correlate events, okay? But the second one, it is the service manager. The service manager must not be the HTTP endpoint, because the service manager had to think how to manage the service, not to answer correctly the event grid. And probably when is called by the ambassador to manage some messages, probably need a persistent layer in order to consider, for example, async operations. And so the sort of session status repository, okay? So a key value database such as Redis, for example. So imagine that you have an API management, okay? We will talk about the meaning of API management when we deal with the event grid. API management, ambassador service that thinks to distributed tracing, Behind that, the service manager that deals with a transaction persistence cache, deals with the real service, and is managed by another, big I, made by application inside logs linked to Azure monitors rules with an action, that can start an Azure automation. So in order to bring it clearly in your mind the example, imagine that you have a function, a function with the ambassador. It is a proxy, that calls another function or another structure. That the first phase put the state into Redis in terms of key, and put the temporary status of the processing, with a Redis queue. After that, there is a sort of trigger within the service provider that reacts to the Redis queue, and manage the transaction, cleaning the session status and giving to the ambassador the response. The response made by the ambassador must include all the headers when the operation becomes longer than 30 seconds. And from another point of view, there is a sort of big brother that accepts distributed tracing. So imagine exceptions within application inside. This kind of big brother configure Azure monitor rules, that resume something, some alert from the application inside, and runs Azure automation runbooks in order to, for example, stop or restart a particular service provider function. With this strategy, you can manage tons of calls without having troubles regarding messages that are lost, golden samples that periodically double check all the chain. This was an old strategy to manage event-driven application and other things. This is the correct strategy to do that. The second answer is regarding how to manage a DLQ. I know that is common arguments with other infrastructures, but it's important to me to make in evidence something that is particularly important for Event Grid. The ambassador must manage the ambassador of the DLQ manager, that you can see it in this graphic, must evaluate some important attributes in order to not to make loops. In 2020, the Event Grid product group released a new version of the debt laddering management in order to say, hey, every time you have a retry and when you have a sort of not well managed message, you will find other attributes within your payload. So the debt lettering reason must be evaluated and associated with the right strategy. The delivery attempts must be evaluated in order to retry at the maximum 20 times. And last delivery outcome, it is the response, unfortunately, in terms of string and not in terms of HTTP status. This is my humble opinion of the delivery. And so probably the best way you can manage all the DLQs is a sort of new subscription made with the system topics that reacts to a blob storage message that is stored when the number of retries has succeeded the limit. And so you want to be notified, when an event is sent to the that location in terms of storage. And so you can notify with a particular handler, okay? Within the handler, you can manage all the attributes, okay? And decide to send an email using another subscription to a Logic app that send email, for example, or other things. Give space to your personal fantasy, okay? This is an important question. When you are in production, and fortunately or unfortunately, you have at the maximum point of your mountain, as a manager event grid, you have to know exactly which is the correct process to manage a failure. Failure, define failure. It is difficult to define failure. In the past, I've defined failure some corrupted firmware that was sent to cars, and all the cars were lost because the communication was good in terms of 4G or 3G communication, but no payloads were coming from the cars. Another important is to avoid loops within your event chain. These are failures for me, and there is a correct strategy and not correct strategy to handle them. The first is to, I don't want to talk about processes, okay, and in functional terms. So send emails and so on. Managing technically, you must have in front of your APIs managed with a circuit breaker, ambassador, sidecar, and so on, a sort of proxy in order to change the collocation of the event grid in terms of topics and in terms of subscription. So, first rule, never connect directly a service to an event grid without using a proxy. Second rule, never connect a subscription directly, a subscription web-based webbook directly to event grid without a proxy. Please use containers, please use tools, some, for example, Nginx, whatever you want. It is not important, but use proxies. Because if you do not use proxies, you cannot handle a failure situation, okay? Because you have to only to stop the service, but you know that the event grid cannot be stopped, can be deleted, and after that you have more time in order to go up, so your RTO and RPO will go upper. So the quickest way is to manage all the endpoints, subscription and topics, okay? So make a sort of plastic filter all around event grid with webhook proxies. Step one. So when you have a failure situation, you can change the proxy in settings in order to give an 404 or other things directly to the publishers. So all the software that are publishing, obviously, to the subscribers. The second one is to drain messages. It is important to pre-develop a sort of data dumper, okay, that can flood all the messages away using a subscription, okay. When you can use a particular subscription, something like the web application, okay, the event grid viewer that you can use to view all the logs, okay, something like that. So subscribe to everything in order to flood out and store in a queue all the JSONs, okay, that are a sort of in-flight queues within an MQTT broker, something like that. And probably if the failure starts not from the devices, but from your event grid, can happen. You have to change to another event grid. And this is the meaning of the topics plastic film, okay, with the web proxy. And so you can use a data pumper with the impersonification. So a sort of simulation of all the tenants that are rebooting all the in-flight messages into event grid. This way, using directly event grid. After that, rechange and re-enable all the proxies to the normal traffic, because you have to avoid all the data tsunami. Last argument of today, sorry for the disconnection, is the drama that I have every time with the event grid when I talk about disaster recovery. Because even if it is well specified in the documentation that there is no service level agreement for server-side disaster recovery, it is not very good from my humble opinion. In my humble opinion, you can manage well, okay, using a mixed strategy, the recovery of the service. So imagine that you have an event grid that goes down. Okay. Can Azure help me with the data that is in flight? Unfortunately not. Because all the geo disaster recovery, it is only regarding metadata, so topics and subscription definition, not regarding data. Okay, this is one of the reasons why I prefer to have a sort of circular queue subscribed to every event in every situation, in order to have a sort of replay functionality. And in this case, so if you have availability zone, probably you can handle the event data that is replicated around the availability zones. But when West Europe goes down, West Europe is down, okay? And so the RPO and RTO are not so fast, okay? And especially if you want to redrain all the messages and all the data that you fortunately saved in your circular queue. But which is the right strategy? The right strategy is to have a mix. A mix made by what? A mix made of high availability from the client, so 2 connections with the 2 URLs, and try the first connection, okay, in the try section, and try the second connection in the catch section, in order to choose the correct event grid endpoint, okay? And this, you can make this because there is an important API, health API, in order to double check if the service is okay or not, or unknown. It is enough? No, because with this strategy you manage only the topic sending phase, but you don't manage the subscription phase. And so this is the solution. The first one is to have a sort of load balancer, okay, when you subscribe to the messages. And so with the load balancer, you can have more than one endpoint in terms of event grid that is connected to the same subscription points that can be made in more than one data center, obviously, okay, because you have to deal with high availability from the topic side, so from the publisher side, and also from the subscriber side, okay? It is the same question. And probably it is not the most one, because the most well organized one, because in this kind you can have a sort of restart of the producers, and probably you cannot define, you cannot manage all the in-flight queue. So the messages that are already stored into the primary node of Event Grid. And so in order to do that, you have to manage a completely clustered situation. So, as I said, proxy. Okay, in this case, we have a load balancer functionality with 2 Event Grid instances behind, and after that you have another load balancer in order to manage all the events from other 2 subscription points. The last thing I want to tell you is how to manage a sync operation. It is not so difficult to manage a sync operation, because when you deal with the interconnection of systems, you have to deal with long operations. And remember that Event Grid manages only fast responses, so within the minute. And so you have 2 options. The first option, and it is properly option when you deal with the system topics, so Azure services. And so in your payload, in your headers, you have to put in terms of response. Okay, so your ambassador service response is 201 created, or 202 accepted. And in the same response, in the header, in the body message, you have to put 2 important a sort of message, okay, JSON response with 2 important attributes: the URL for checking the ongoing status of an operation, because in order to declare finish the operation, Event Grid must want an HTTP to 200. Okay. And you can define the retry after in order to customize, or in order to be a sort of predictive surface, okay, that advise you with the right time. Okay, so in order to close the situation, I want to summarize all the approach. When you deal with the Event Grid, you deal with 2 important things: the viewer, so in order to view all the things, search on GitHub Azure Event Grid Viewer. It is a sort of web application made by some good developer in order to retrieve all the information that are coming into the Event Grid architecture, probably using some mock event generator. For example, the mock generator that you can find into the Visual Studio Code. You can have a more detailed approach when you want to simulate the events. In this case, it is a JSON schema service. In the data, okay, that is an object, a type object, you can define all your attributes, okay, specifying a sort of complete payload that you want to send to a particular subscriber, or you want to send to the main topic endpoint. Other important thing, ng-rock, because when you want to debug your functions, okay, it is not sufficient to press F5 and run locally, but you have to use ng-rock in order to subscribe from Event Grid, the cloud Event Grid, with the right endpoint that is this endpoint. Remember that it is changing every time you restart the process, and so you have to go to the right service in order to establish a new endpoint. When you want to observe events, you can have this kind of graphic when you deal with the edge computer. So a sort of data-driven approach and an event-driven parallel approach in order to connect your edge machines and your edge system to other ecosystem. From the higher level, and this is the last assertion, when you have to deal with the domains, okay, think to different domains that can interchange messages from a domain to another domain. For example, distributor network claim supplier domain that send a message to a specific plant domain, and probably within the plant there is another domain that calls the machine producer in order to retrieve all the process data and gives you a complete dossier or your claimed product. Sorry for interruptions. Thank you so much for this opportunity. Please use Event Grid in the right way.
Thank you so much, Rick. That was a great session. I learned quite a bit about Event Grid. I assume it was a very simple service to use and as part of the solutioning, but looks like it's a deep ocean. And certainly this is only for adults. At least this content is only for adults. Thank you so much once again, Rick. And it was great hosting you.
Okay.
Bye-bye and take care.
Bye-bye.
So next up we have Eril, who's going to go in depth about integration services. Let's bring Eril into the screen. And Eril, thank you so much for joining us. And you're live, and we could see you as well as your PPT. Thank you so much, and stage is yours.
Yes, thanks, Ilyas. Just a quick confirmation that you can hear me good.
Yes, sound and clear.
Yes, that's wonderful. Welcome everyone to this session on Azure Community Conference. It's a pleasure to be a part of this India's largest Azure conference. So I'm Mary Larissy. I'm super happy to share the secret behind building a reactive Azure integration application today. I'm sure Rick has set a wonderful context well before the session to talk about event grids. And along with the event grids, we are going to explore a lot of the services that Azure offers, which can help you build and support reactive Azure integration applications in real time. So before we get ahead, I would like to share some credentials about me to justify that I am one right person to talk about this topic. So I play the role of a lead product consultant for Serverless 360 with Covey.co. So Serverless 360 is a tool crafted for Azure portal. So any challenges or operational challenges that you have in the Azure portal, you will find the right toolset in Serverless 360 to address them. So we'll touch upon this as well as we proceed further. So I would be glad to engage or involve in any Azure related talks. And I work with the enterprises across the globe every day in and day out to help them build the Azure integrations the right way and support them in their production. So in this session today, I'm going to share some of my key learnings that I have acquired in my last 4 years with enterprises and Azure integration experts across the globe. So today's context is about reactive application. As the name says, as we observe the modern applications that we deal with day in and day out, we play the role of the users as well as that of developers. So when we are in the user's positions, we are so demanding, isn't it? So that's just the same way our end users are as well. So they expect the application to react to their needs. So we might have to handle various architectures, development patterns to fulfill the needs of the modern applications and modern end users. So that is where this concept of building a reactive application comes into picture. So first, before trying to build a reactive application, we should understand what are the key characteristics it is expected to possess. When do we call an application to be reactive? So we define 4 key values a reactive application is expected to possess according to a reactive manifesto. First, the application is expected to be responsive. as the general meaning of the term responsive means. So, responsiveness is a cornerstone of usability and utility of an application. So it's not just responding when the application is up and running. It is expected to be responsive whenever it is able to respond. Apart from that, even if a problem is detected, it has to quickly fix it and then effectively restore out of the problem. That's an expectation from an responsive application. And this behavior has to be rapid and consistent. Only then the application can deliver a high quality of service, and hence it can ensure that your end user is confident of using this application, and that encourages further interactions. Imagine we ourselves are using a chat application in a website portal. Say, imagine it's an e-commerce application and there is a chat app at the right corner of an e-commerce application. I try to respond to it. So at least the application should be intuited in a way that it gives me the first response very the moment I give post a question to it. So these are certain basic requirements, not only in mission critical applications, but also in day-to-day applications that we use. So the application is expected to be responsive whenever it is possible. Next, what should happen when there is a failure? Failure is something that cannot be avoided, isn't it? So, but the application is expected to be responsive even when it faces a failure. And this characteristic is called as resilience. How can I ensure my application is resilient? I need to take care of four key things. Replication. So this is something very common we would have heard about. Say, even if one server of my application is unable to serve me at this point in time, there should be a replication of it in another region or in some way that another server responds to the end user's request. So that replication has to be taken care of. Your application should be replicated. At least one instance serves your end user's request. Containment. So this is the application is expected to be responsive in case of failure. So what if a failure happens? The failure should be contained within that component. So even if the payment processing fails in my e-commerce application, all the previous process of me adding the item into the cart should be retained. So only then the user will have an experience or a way out to spend less time in processing the order again. So the failure in the payment module should be contained within that module. And every component of the application should be isolated from each other to make sure that the failure is contained within that particular module. What if a failure happens within this module? It has to be delegated to an external component so that the restoration is not dependent on this failed module. So taking care of these four core values, replication, containment, isolation, and delegation, I can make sure that my application is resilient, which means my application is expected to be responsive even in face of a failure. The next core value that an reactive application is expected to possess is elasticity. So my application is expected to be responsive under varying workload. So that's how our modern applications are, not right? I cannot expect my application to have a predefined volume of inputs day long. So it might vary at a certain period of time. Say, taking the same e-commerce scenario, I might have a spike in the traffic to my website in case of special offers like the Great Indian Festival for an Amazon or any Flipkart announcing an $1 billion sale day. I can expect a sudden spike in the incoming traffic, but that's not going to be the case on the rest of the days. So my application is expected to be responsive under these varying loads. So what is that I need to take care of to fulfill this requirement? My application should have the capability to replicate its components and distribute the load in runtime seamlessly. It should make use of predictive and reactive scaling algorithms so that my components that are required to process the inputs is scaled up or down seamlessly whenever based on the volume of inputs that come in. To ensure this, I should have live performance measures. Like I need to understand how has it been the trend of the incoming request and all that within and in a cost effective way. So ultimately, I also need to make sure that I spend effectively and get the desired output. Most importantly, the entire application should be message driven. Imagine, for example, the e-commerce application is expecting it is the processing of an order is expected to process the incoming orders. So imagine there is no order, but still this backend application is expected to check for message every minute. Does that sound like an effective application? Definitely not. I cannot expect my backend processing to ping for the arrival of messages now and then. That's not at all a right way of programming. Instead, whenever there is an order, there should be an intelligent event-driven approach that makes sure that it informs the backend application to pick it up and then process. So this scenario is an example of a message-driven scenario, and it has to be an asynchronous message processing. Passing. So my application is expected to process a number of inputs at the same point in time, and this has to happen seamlessly. So this particular action should be driven by an asynchronous message processing architecture. So this also ensures that my components are loosely coupled. Say I have my external website which compiles the order and pushes it into my and message, compiles it as a message. And I have a backend application which has all the information that is required for processing the order. So it can pick up this message and then process. In this way, there is no exact connection between my front-end website and my backend application. Instead, they communicate through a message. And this way, I have achieved loosely coupled components. My user-facing website is completely decoupled from my backend order processing application. So what is the benefit here? There is no blocking communication. That is, both the components is not expected to be online at the same point in time, and it is also ensured that failure of one of the components can be can still even in case of failure of one of my components, I can still ensure that the incoming orders are processed. So this also helps me in delegating failures as a messages. So these are 4 key values that my reactive application is expected to possess, right? So before we proceed further, I would like to quickly summarize that, because having all these requirements in mind when we build an application is necessary to build a real reactive application. So it's expected to be responsive. If at all it can respond, it has to respond on time. Even in case of failure, my application is expected to be responsive. Even in case of varying load, my application is expected to be responsive. And I need to make sure the entire application is message driven so that the components are isolated, the failures are contained within the component, and in case of failures, they are delegated to another external component. So all these sound really complex, isn't it? But we do have technology to support us. We have Azure to save us or help us in building reactive applications at ease. So when I say at ease, you might not believe me at this point in time, but let us explore various services that Azure offers within real-time complex business scenario. Then you would definitely appreciate how services from Azure can help me address complexities in real time at ease. So here is an overview of enterprise integration services that Azure offers. So let me quickly quickly touch upon some of them that is necessary for us to know before we proceed further. So imagine in any business application, I might have I might have a set of logics that need to be executed. So logic apps are here, which has a rich set of predefined connectors available with which, even without writing a single line of code, I can fulfill my business requirement. Say, for example, I need to pick up a message from a service bus queue, which has got the order compiled from an web application. Say I can have my app service in which my web application is hosted, which compiles the message and pushes it into a service bus queue, and that can be picked up from by a logic app. And this logic app executes or defines the workflow that needs to be carried out to process this message. And this information can also get into in storage. So the Azure and complete integration platform offers solution for me to fulfill all these needs. I have messaging and event services like Service Bus, Event Hub, and Event Grid. Say when I'm dealing with messages or events, at this point in time, we need to clearly understand what is the difference between a message and an event. So the event says that something has happened, that is, a file has been created, or an an event has just occurred, a message has arrived. So this is an example of an event. Here we do not have any much complex information that is required for by the subsequent application. Instead, it just says that some action that you are expecting has happened. It's now, you are now ready to react. Yes, so this event grid is one of the key servers that we would use in any reactive application. Wherever you expect a component to react on an output from another component, you can very well fit an event grid between these components. And this event grid, as Rick has was mentioning in the previous session, has got the capability to connect seamlessly with any services in Azure for that matter. So you can even have a custom web endpoint at the topic, and you can subscribe to a custom webhook in the subscription. So Event Grid can seamlessly pass on or route event across various components, which could be the Azure integration services or event services in your premise. What is this Event Hub? So Event Hub is an event processing service from Azure, which can seamlessly handle millions of events per second. So imagine real-time telematic devices. So we use Ola and Uber day in and day out. They have the device, they have they are vehicles traveling across the city, and how does the telematic information from all the vehicles get gathered, compiled, and then get comes to a consumable form in your mobile phone. So we have a service like Event Hub, which is capable of ingesting millions of events like that, and then compiles them to have an in proper information. A service bus comes in the picture whenever we deal with messages. So how are messages different from events? Message will have an useful information that is required for further processing. So that is where a service bus can come into picture. So to understand all these services better, let us pick up a real-time business scenario. Let's try to understand what does the business need, and we will provide them with a reactive application that can fulfill their business needs. So as we proceed further, let us first understand what this business needs. So here we are going to talk about a fleet management system. Yes, as the name says, this particular organization has got good number of fleets or vehicles that is spread across the globe, and which are required to carry out their shipping process. So this organization has got a core business logic which is residing in their premise, and they do not want to get rid of it at this point in time. But still, they want to scale to meet the real time demands. So, this business logic does take care of processing the shipments. But how can I make this system more intelligent? how can I make sure that this reacts to the real-time changes in my fleets? So now they have taken a measure of implanting telematic devices on all their vehicles. So now their vehicles are implanted with telematic devices, which will pass on information like what is its current fuel level, what is the location of this vehicle, what's its insurance validity. All this information is compiled as an event, and these telematic devices are capable of passing on this event. So now I need to bridge this gap. I have the core business logic in their legacy code on their premise, and I have my vehicles implanted with the telematic devices. So at this point in time, this organization has decided to go on the cloud partially. That is, they want to retain their business logic. They do not want to touch their core legacy code at this point in time. Maybe later point in time, when they are comfortable with the rest of the application working good, they will go ahead with this. So these telematic devices are going to send in events which comprises of details about all the information that I require about the vehicles to provide an intelligent information to my end user. What are the other components that I need? Here I am going to choose Azure services. So maybe I might have to explore the need of every component. So as we discussed in the reactive application, we are going to segregate the application into various components so that any failure of any of these components can be contained and isolated from rest of the components. That is one of the core principles that we saw. And let's first understand, explore the needs of this system and fit in the right Azure services to fulfill those needs. So first, the telematic devices are implanted and they are going to stream the events. So I need an service that can ingest these events. And this event data has to be stored for my business logic to process at its convenience. So I need an event ingester which can accept the events. So here we need to take care of the scale of the event that I am dealing with, volume of events. I have a good number of vehicles spread across the globe, and I'm expecting millions of events per second. I need an efficient service that can seamlessly ingest these events and compile them into an event data that can be processed by my business application. This event service should be complemented by a cloud storage service to allow my on-premise application to process the events. So ingesting the event and capturing it or saving it into an permanent storage itself sounds like a massive task. So I need to take care of various parameters at this point, especially the volume of information that I am dealing with. Next, I need a cloud service that can securely expose my on-prem service to the public cloud. So obviously my core business logic is in my premise. I need to expose it to the cloud so that it can work along with other services that I'm going to identify. And this business logic also has a primitive database which I need to get rid of and then come up with a responsive database with business continuity and enterprise grade security in place. So these are my next set of requirements. So to connect this cloud service, that is, imagine I'm exposing my business logic through a cloud service. So how do I make sure that this business logic understands that the information that it is looking for has arrived? So this is where the core concept of event driven comes into picture, right? So I cannot expect my business logic to ping the storage every 1 minute to check whether the expected information has arrived or not. No, that's not the right way of building this application. So instead, the business logic should be informed whenever the storage is available for processing. So I need an event routing service that can seamlessly scale based on the inputs that come in. Okay, so these are the requirements. And based on the information that is being processed, There are a set of follow-up actions that need to be taken care of. For example, the simplest would be sending out intimation emails to various departments, or say if it is regarding an insurance expiry of one of my vehicles, there should be an orchestration that triggers an insurance renewal process automatically. So that is how this fleet management is expected to be made more intelligent, so that nothing skips out of their target. So I need and follow up action need to be orchestrated. So this orchestrator logic should be completely decoupled from my core business logic, because that was another principle of a reactive application wherein I need to make it message driven. So I'm trying to bring in another cloud service which can be a messaging service to decouple the follow up actions from my core business. So this is all what this fleet management system needs. And we have also categorized which are all the services that I am going to choose from the cloud, and what is that I'm going to retain in my on-prem. So let us now see what are all the services in Azure that can fit exactly into this scenario. We also need to remember the core principles that we defined for our reactive application. So every service that we pick, we need to evaluate whether it adheres to the core principles or not. Yeah. So I am putting in Event Hub in place of my event ingester. So Event Hub is an event ingesting service. It can ingest the stream of telematic information that comes from the devices installed on my vehicles. It's capable of seamlessly processing millions of events per second. Wonderful. We also identified a challenge there in dealing with millions of events per second. Storing them into an accessible storage location itself sounded as a massive task. Does Event Hub offer any capability that can fit in here, that can help me facilitate in capturing this? Yes, it does. It has a feature called Event Capture, which can save the batches of events into a target storage location. So as we discuss this, I would like to show you this in the Azure portal for a better understanding. So I'm getting into my Azure portal here. So for these demos, I have a bunch of resources created in a specific resource group. And here is my Event Hub. So an Event Hub would reside within an Event Hub namespace, and this Event Hub is created with one Event Hub namespace contains one Event Hub, which is active and has a message retention of 1 day. So here comes the interesting feature, capture events. So your Event Hub needs to be at least in a standard tier to have this feature. The basic tier doesn't support capture events. I can also show you more about the pricing associated with this particular feature. And what does this capture feature help us with? This can automatically deliver the streaming data in event hubs to an target storage blob or an Azure data lake store. So this can be decided based on your application architecture. In this case, I'm going to choose my storage blob as a target location, because I can my business logic has the logic to access a storage blob and then process the events further. Okay. So this setting up capture is fast. Let us see how fast it is. I just turned on the capture feature, and I can specify the time window here. It can be defined in minutes. As of now, I have set it as 5 minutes. That is, for every 5 minutes, it's going to capture all the incoming events into my storage below. Yeah, I can also specify an size window. So whenever I have event of size this much, it is going to. I can turn on this option here. Do not emit empty files when no events occur during the capture time window. So because I have put 5 minutes, even if there are no incoming events, if I do not check this, it's going to put an empty event file into my target location, which I do not want to happen. So I just check this option. Yes, and I'm choosing the capture provider as storage account, and I'm asked to select a container. I already have a container designated for this purpose, and I associate that here. I select the container and I'm all set. That's it. It does seem really simple, isn't it? Just as they have promised above. So I'm going to save the changes, which means that any incoming events is going to get captured in my storage block. So my massive challenge of capturing millions of events per second is getting sorted without even writing a single line of code. Isn't this amazing? So this event hub is capable of scaling seamlessly, so which means our reactive requirement is also getting addressed, and it is in this way I have reduced a lot of complexity. But I also need to pay attention to what is that I need to spend to get this done. So as I mentioned, the basic tier capture is not uh, supported. Still, you can ingest the events and you can have your application processing it. That is not a problem. But when you need to capture the event to enable your business application to process it, then you can choose a standard tier, which is also cost effective, and you just pay for the events. So ingress events, you get you pay for the million events that you get processed. A capture is associated with an additional reasonable charge, and you have a retention period of a maximum of 7 days. This is within pricing that we need to pay, and with respect to configuring and using this feature, it is as simple as Antisad has been claimed for. So we have fit an event hub here to ingest our incoming events. And we have also enabled capture on the event hub so that the batches of events are getting captured in my Azure storage block. Now coming to the next requirement. I need to expose my on-prem application through and to the cloud. So what is a service that can help me doing this? I have relays which can expose the on-prem service to the cloud services safely. And the best part is you need not make much intrusive changes into the network layer of your application at all. So without having much intrusive changes, you can safely expose your application to the cloud services, your on-prem application to the cloud services. This is also as simple as you can see. You can create an hybrid connection or a WCF relay, and you can associate your on-prem application to the relay, and that is it. The ones even here you need not write a single line of code. You can achieve your on-prem application exposed to the cloud services securely. You'll get an endpoint endpoint for exposing your on-prem application to the cloud. So this URL, through this URL, your cloud services can communicate to your on-prem application seamlessly. And all this I've done without making much intrusive changes to my firewall or network type. So this is also done. Now we need add this application to be reactive, which means I do not expect my business application to ping every minute to check whether the expected blob information, the event information has got into the blob or not. Instead, I need this to seamlessly happen. So like whenever there is a blob created in my storage account, I want my business application to be informed that the information that you're looking for has come. You can pick it up and then process now. So I need to bring in an event routing service, that is an event grid here. So what does event grid can do? It can connect to my event hub. It can get an event emitted from my event hub. So this event hub emits an event to the event grid saying that the capture file is created. And this event will be passed on to the relay saying that the file that you are looking for is now available. So now my business application gets triggered, and this will start processing my storage information. That is a event information in my storage account. So let us see how does my event grid look like. So I have an event topic and an event subscription. So the first step is my event hub is expected to emit an event, isn't it? So when I get into my event hub's events section, I can bind an event grid subscription which can accept event emitted from my event hub. So this is going to pass on the event to my relay. So I was connected to my event hub, and when the event hub emits an event, it passes it on to my relay, which is a subscription to this event grid. So whenever an event hub informs the event grid that the capture file is created, it's going to inform the relay and hence the on-prem application to pick it up and then process. And for the on-prem application to safely store its information into an fully managed NoSQL DB, I choose Cosmos DB. Cosmos DB is also equally simple to get started with. You can choose your relevant database in a Cosmos DB and then start binding your information there. Now coming into the interesting part, another segment of this particular in this entire application architecture. So there was a requirement to orchestrate the follow-up actions. Here I choose a logic app because this logic app has a good number of predefined connectors that can help me achieve my business workflows at ease without much of coding. So here I have my logic app. You can edit. I'm going to show you a glimpse of how different connectors are available here. So my logic app, I wanted my logic app to be completely decoupled from my on-prem application, business application. So I was expecting to bring in an service bus queue in between. So I can define an queue triggered logic app that can help me fulfill this requirement. So building a logic app is so simple. You have predefined templates readily available. You can get started with an trigger. You can bind your resources, and you have rich set of services that are available which can facilitate redefining and logic app. Let me show you one which I have already created. So this is one logic app which I already have. So whenever you create resources in your Azure portal, make sure that you stick on to the standards. You can associate tags to them so that they can be relevantly grouped to give you an visualization like in business application. And you can make sure that you stick to the proper naming conventions so that it's readable and you can understand or locate which application are you dealing with. So this is an sample queue triggered logic app. Whenever this service bus queue has a message, your logic app gets triggered, and that particular message properties will be available within my logic app as dynamic content for me to further process it. So without even writing a single line of code, you get to receive the message and you process it. So in this scenario, whenever they wanted to execute follow-up actions, here I have rich set of connectors either from built-in or if you have any custom logic, it is also possible to create a custom connector, publish it, and start using it here. So this has integration with rich set of services. Say for example, if I have to trigger an email, I can just look for the email connector, choose from the service provider that I would like to connect with, associate your account, and then start sending it. So it's as simple as that. And these connectors are reliable. So you can make use of them which are readily available and get your business logic attained. This is how Azure services are helping us address complex real-time problems at ease. So these services independently are solving a specific business scenario, which not only fits into this particular business scenario, but also into many real-time cases that we deal with day in and day out. When we rightly choose the services and fit them into the desired locations, then your problem is mostly solved. Yes. So even so, let us revisit our reactive application requirements at this juncture. So when my first and foremost requirement was in responsiveness, right? So these services have come in with good uptime, so that your application, you can expect the application that you build using these services would be responsive. And when in case of failure, say what if my relay or my on-prem application was not available for some point in time. So because this is the only non-cloud service I have now. What if the event grid was unable to deliver the event to my on-prem service at this point in time? So event grid has a feature called dead letters. So any events that are cannot be passed on at this moment will get saved into my event grid subscriptions dead letter. So I can, which is nothing but and again and storage destination. You can enable dead lettering on your event grid, and you can view the dead lettered events in the storage account, which can be further processed. That is, or you can understand which are all the events which has not been delivered. And similarly, when you deal with messages, see, events are important. Messages are more important because they are going to have the information that is required for my follow up or the downstream application to process this particular transaction. So, what if a message is enabled to be delivered? So, what are various reasons when a message will not get delivered? So that could be number of reasons. It could be system defined reasons or business reasons. The message might not be in a position to get processed at this point in time. So but later point in time, there is a necessity or there is a feasibility of these messages getting processed. So where does the queue hold these messages? So service bus itself offers a secondary sub queue called dead letter queue, wherein these messages which cannot be processed at this point in time get saved. We can process them at a later point in time. So this is all are possible. So in this, it is also required that my reactive application should be extendable. That is, at later point in time, when I find that I'm good with the rest of the components and I want to go to the cloud on my on-prem business logic as well. So this particular customer does really want to do that. So they want to get rid of the on-prem legacy code and replace it with a much reliable and easy to manage service from Azure, which is an Azure durable function. So Azure durable function will have a starter function and an orchestrator function with a number of activity functions, and this can help you whenever you need in custom computation or when you want to write your own legacy code onto the cloud, then Azure Functions is the right choice. And here the scalability, the server management complexities all are off our plate. We just need to focus on our core business logic, get that implemented in an Azure function, and your code gets executed on the cloud seamlessly, and this can scale. By making use of features like geo-replication, disaster recovery, you can also make sure that your application is more resilient in case of any failures. So, as I was mentioning, it is also important to adhere to the best practices, and it's also important that we learn from others' mistakes or we learn from the experts across the globe. So, for this specific need, we have created a platform called Serverless Notes. Let me give you a quick glimpse of the platform, wherein you get experts from across the globe sharing their tips and tricks. So you have top Azure serverless tips from Microsoft experts in the serverless notes. Herein you can sign up and then start learning from the quick tips that you get from experts across the globe. Say, be it service bus, you get to understand what is that, when should you choose standard or premium tires, any such decisions. You name it, you'll have it here. Like whatever people have encountered in using these services, we have compiled them as tips and quick tips that would be not more than 2 minute read. You can get authentic content from experts across the globe in the serverless notes page. Okay, so assuming that we adhere to the best practices, we have built and reactive application. So as important it is to build a reactive application, it's equally important to support it in real time, because when once we build the application, our responsibility doesn't end there. When it gets delivered to the end users, you are expected to give them with consistent responses, yes, consistent support. So here is where defining an frictionless support strategy becomes very important. Let us see what typically happens in a support scenario in dealing with an Azure integration application. So this is an Azure portal. We just saw we had the resources created there. It had an excellent interface for me to build my workflow, create my resources, integrate them together, and make them work as I expected. And I have my experienced Azure developers and experts who get access to my Azure portal. I do have a level 3 support team who gets access to the Azure portal. So as you see, the Azure portal is complex, critical, and it is very important to restrict access to this Azure portal to only to limited resources who have got adequate knowledge on this system. So in a typical organization, you can expect only the experienced Azure developers and experts to have the adequate knowledge of what have they built and how does things work together, what failure in one component mean to the status of the other component and all. You cannot expect an L1 or L2 support team to understand all this, or my business users to understand the complexities of the underlying architecture. So the typical challenge here is my business users or L1 and L2 support team who is facing the customers do not have much visibility on the solution, because it's not really safe to provide them with access to the Azure portal, which is complex and it is hard for them to understand. And due to security challenges, their access to the Azure portal is limited. And this IT support team, a level 3 IT support team, has limited experience of the solution. But whenever there is a ticket that gets raised by the customer, whenever someone comes and say that my particular transaction is missing or it has not got processed, the support team is expected to trouble the experienced Azure developers to get the issue sorted. So in a typical scenario, we observe that experienced Azure developers are involved in less valued support tasks. That to 70% of the support tasks are getting sorted by the experienced Azure developers. So, what is the problem here actually? So, experienced Azure developers are expected to innovate in the business. Rather, they are spending time on sorting out the support challenges. But how can I safely move this support to the IT support team and the business users? That is where you need to bring in a right tool which can enable your support and business users to deal with your Azure application safely. So still, I need not give access to the support and business users to the Azure portal, but still I can give them the visibility that they require to deal with these applications in real time. Let me show you how. So here is my Azure portal, wherein we just saw there are a bunch of resources, but it's hard for me to understand what is a business application that they are associated with, what is their status at this point in time, is my resources hale and healthy. All these are very hard to understand. Right. So let me log into my serverless 360 site. Let's see how this can give us an application visibility on the resources that I am dealing with. So this Serverless 360 has three core components. One is a business application, which we'll focus on the first. Say the bunch of resources that I see in the Azure portal can be refined to give me an application kind of view in Serverless 360's business applications. So all those bunch of resources, I have segregated them based on the business context, and I have provided access to different users at different level of permissions on these applications. And this also gives me a holistic view of what are the number of resources that participate in this business application and what is their status at this point in time. So, for example, let us pick this fleet management, which is the one that we were dealing with. I find that 88% of my resources are healthy, but still there are four resources that are facing some challenge. So, I can get into the service map to understand which is the resource that has got a trouble. I find that my service bus topic that I have in this particular application has got a trouble. And I find the messages count and the dead letter message count is greater than my expected value. So in the Azure portal, it is practically not possible for me to view the dead letter messages and then process them. But as you see here, it becomes my day in and day out operational requirement for me to view the dead letter messages and then process them. So let us see how Serverless 360 can facilitate this. So here I have an uh, interface wherein I can get into the topic subscription, which has got the messages. I find that there are humongous number of dead letter messages, which means that there is a critical business failure, and that needs to be sorted right away. So I get into my queue. This is get into my topic, and I retrieve the messages from my topic's dead letter end. So, an topic will have active messages as well as dead letter messages. Active message is what the downstream application will receive and then process, whereas dead letter messages are those which needs to be sorted manually by us. So here I view the dead letter message. I understand what is it. Say I want to view the message details. Yes, this is a sample message, and this has dead letter due to time to live expiry. Maybe the downstream application was not available to process these messages, and every message is associated with a specific time to live. Say within 3 minutes, it's expected to be processed. After 3 minutes, it automatically get pushed into the dead letter queue. This is one system reason why a message gets dead lettered. Apart from this, there are various other reasons like business reasons. I book for an cab. I associate a driver and then book a cab. But unfortunately, the driver is unable to pick up the order at this point in time, or his presence has gone unknown. So this message gets dead lettered. That's how the business logic is written. So this business application can dead letter message within custom reason saying that the driver is not available now. So my I can have another downstream application which is required to failure processing. So this downstream applications can pick up messages from the dead letter queue and then process it. Or it could be scenarios like wherein your support person gets into the dead letter queue, finds that these things needs to be acted on, and then takes an action like reprocessing. So a tool like Serverless 360 becomes critical in day-to-day validations like this, wherein they can get a visibility on the reason behind the failure, and they get the tool set to reprocess the failure to restore the business. So this can be safely handed over to the support team to ensure that your most of your support gets sorted by your business users and the support team members. So for business users, we have another excellent feature. So when you see these are the static processing of the messages. So for in real-time business, what if a number of transactions are going on and I need to get an visibility on what's happening with my business data. So here I can have a real-time tracking of my business information. I can see what happened with the processing of this particular employee. I find that for this specific employee, a particular action failed, and I can understand why this could not be accomplished, and this way I can understand the reason and reprocess this business transaction. Who can do this? A business user can safely take care of this, and we can configure and leave them with task to provide the customer with and better support. So this ensures that you get an consistent response time to your end users, and they are this ensures that your end user improves the end user confidence that we were talking as an important critical parameter for an reactive application. And here we are also offloading your core Azure team from the less valued support tasks so they get time to innovate in their business. So this is an desired support. So this is a common support scenario wherein a business user says this looks like the follow processing is broken in the above case, and the business user says I have no idea. Let's raise a support call. Support team has no visibility on the application, so they claim that we can't see anything. Let's escalate it. So now I can see the problem, but I'm not sure what to do. I will escalate it, and the Azure person is expected to identify the problem and fix it. Instead, when you have the right tool, what is that we can achieve? Thanks, say they have a dashboard which pinpoints or spotlights any failure in your business application. The support team, they find the they receive an alert of a problem through a notification, could be an email or teams channel. They go to the service map to identify the problem, and then they use the tool sets to address the problem. So this way, even before the problem gets noticed by the end user, these support people are in a position to say that there was a problem this morning, but we have already fixed it. So, and reactive application needs and proactive monitoring with the right tool in place. So that is how we can achieve building and reactive application and support it. And quick summary of all that we discussed today. We thought we understood, we defined a reactive manifesto and defined the core principles or characteristics that a reactive application is expected to possess. It's expected to be responsive, resilient, elastic, and message driven. And we also understood in real-time business scenario, understood its needs, and selected the right Azure services to fit in and then solve the business use cases. I introduce you to the platform wherein you can get tips and tricks on developing with Azure integration platform. And yeah, I also introduced you to Serverless 360 to define and frictionless support strategy and proactive support strategy for the reactive applications that we build using Azure. So this brings us to the end of the session. I have brought here few set of useful links that would be good for you to explore further. And thank you.
Thank you so much, Earl. Hope I'm audible. It was a
Yes,
fantastic
Ilyas.
session, and on you're on time, and thank you so much for that.
Thanks, Ilyas.
Next up, we have Suhas online. So let's jump into the next session. Thank you so much. Hey, Suhas.
Yeah,
Good
hi
evening.
Elias. Good evening. How are you, Elias?
Very good. How are things there?
Yeah, I'm fine, Elias. Good.
Perfect. Okay, so now we have the next session by Suhas. So Suhas, the stage is yours.
Yeah, thanks, Elias. Okay, guys. So, yeah, good day, everyone. So, first of all, thanks for joining us for AZConf. So, I appreciate your interest, learning some new technologies and new stuff. So, there are a lot of tracks going on. So, I appreciate, all the volunteers and all the speakers and organizers for making this, AZConf is a big one. So, thanks everyone for joining. So, today, So myself Suhas, so I'm a software engineer. So my tech stack is Angular, C Sharp, .NET, and Azure, and I also work on SQL and MongoDB. And I also do some blogging and also speak at some technical meetups, and I'm also Microsoft MVP. Okay, so today my topic is, so let's build a real-time dashboard using Azure SignalR. So we'll see, the agenda of this session is very simple. I'm going to keep the session as very simple because it's just 30-minute session. So I just want to convey, like we'll see what is SignalR. So basically why SignalR came into existence, and we'll see why we need Azure SignalR and what is it and how we can use it to build any real-time stuff. So it cannot be dashboard like anything, any real-time applications. And finally I'll explain you the demo. So I thought of planning to do a live coding, but it would take an hour. So I have all the coding stuff's done. So I'll show you how you can build a real-time dashboard within just 30 minutes uh, using Azure SignalR service. Like if you have any questions, just raise it in the comments. Like we'll pick it up at the end of the session, guys. Okay, so first my slide is like introduction to SignalR. So basically why SignalR? So basically the protocol HTTP we have, when the internet came into existence, like we have this HTTP from from all the days, and currently we have HTTP2 and HTTP3 is coming up, etc. But all these HTTPs is a kind of the model. It's a kind of a request response model. So let's say we have a client and we have a server. So client sends a request and server sends the response, and it's a kind of an half duplex communication. So it cannot, client and server, it cannot communicate simultaneously. So client sends a request and then it comes the response. So it's a kind of an front and forth kind of communication going on between the client and the server. So that's a kind of when you want to build some real time, for example in this screen, like you are seeing a dashboard, or else you can take an example of a stock market dashboard, like it will, or any bitcoins dashboard, like the price of the coins, like it will reflect for every second. So it is a kind of you need to refresh the page for every second. So let's say if you are dependent on like HTTP protocol, you need to send a request and response. So imagine like how many number of AP calls you want to do just to refresh the dashboard. And if the number of customers using the product, and if you're going to use HTTP, the number of API calls is going to be huge, and the maintenance will be bigger, right? So that's when they thought of doing a kind of full duplex communication. A full duplex in the sense, let's say client and a server acts like talking like in a mobile phone. So basically it's a kind of client and server, they can interact simultaneously. So there'll be a connection established between the client and the server, and they can interact with them simultaneously instead of doing like polling stuff. So the solution had in the earlier days was polling, like they'll check an API call for every 2 seconds. So they'll hit for every 2 seconds, for every 3 seconds they do a long polling. But that's not a good kind of strategy, or it's not a good thing to do, like if you want to build real-time things. So that's when WebSockets came into existence. So what does WebSockets do is uh, it establishes a connection between the client and the server. So it initially it provides a handshake between the client and the server, and it provides a connection between the client and the server, and they can communicate simultaneously. So the introduction of WebSockets, it changes the communication between the client and the server. And what do we see as a difference between the WebSocket and the HTTP? So as I said earlier, HTTP is a kind of an request response model. So it's a request, and client sends the request and server sends the response. But in the WebSocket, you can see there will be an initial handshake from the client, and there will be an acknowledgement from the server, and that's it. And the calls or the messages will be flowing through the client and the server. So it's just you can take it as it's kind of an one API call, which gets the client and the server connected, and the messages can be easily flown through between the client and the server. So this kind of introduction of WebSocket, it transfers the communication. It looks like an the second era of communication between the server and the client, and this WebSocket leads to the introduction of a signaler, and we also have packages in .NET Core and .NET Framework. So we have signaler libraries where you can consume it in your application, and you can build real-time .NET applications. So the main purpose of signaler is like building real-time applications. So as I said earlier, the stock market dashboard, and for example the group message we do right in WhatsApp or Facebook, sorry, Meta. So if you are doing any group messages, the replies will be it will be shared to all the clients which are stays connected. So everything, there are a lot of scenarios like real-time helps, and that's when WebSocket is a kind of a great use of it, and signaler make use of WebSocket, and it also does many techniques like long polling, for our frames, etc. But here in this session, like, we are going to focus on WebSocket. But most of the times, you'll use WebSocket as if you want to build any real-time stuffs. So basically signaler uses WebSocket to make it the real-time communication between the client and the server. Okay. So basically my slide won't contain much points, so I'll speak a lot with a image. So if you have any doubts, you can just post it in the comments, guys. So the next term I want to introduce is hub. So what is a hub? So for example, let's take this is a kind of an airport, and there'll be a central hub, which will in that central hub we can able to communicate to all the aeroplanes, right? So this hub acts as an intermediate communicator between all the aeroplanes. For example, a hub can communicate to all the airports. So the same stuff, signaler has a concept called signaler hub. Okay. So those hub, so let's say all the clients will be connected to that hub. So in this example, we have a central airplane hub, and all the airplane radios will be connected to the respective hub for communications. The same happens like in signaler, we'll have a hub, and all the clients will be connected to that hub. And let's say if I want to send a message to all the clients, I can say just hub dot send off. I can just send the message I want, and if that piece of line executed, the message will be communicated through all the clients simultaneously. So this is one of the term in signaler, like you want to know the hub and the clients. So if you have any doubts regarding this term, just text it in the comments. So this is about signaler. So initially Microsoft introduced signaler with just .NET packages and .NET Core, etc., and they have and you can consume it easily in your .NET projects. So the next stuff I want to introduce is the Azure signaler. So why we need Azure signaler? First of all, it's a kind of an serverless application, and so just a minute, guys. For that, okay. So Azure signaler. So basically we had packages to consume in .NET applications, but nowadays people used to have cloud services created, and Azure has a lot of resources like Azure logic apps, functions, etc., which you can consume it. So likewise, Azure also developed a service, signaler service, where it simplifies the process of adding real-time functionality over HTTP. So this real-time functionality, it allows the service, as I mentioned earlier, to push content from a hub to all the connected clients. So that's the main part. So all the clients will be connected to a hub, and this hub will communicate all the messages to the respective clients. And this signaler service will be hosted in the cloud, and you can consume it and watch the main advantages like it has a new mode called the serverless mode, and if there are more number of requests, it will scale in as much as it wants, and when the requests are low, like it will scale out automatically, like scale in and scale out, it takes out, it happens automatically. And we have some pricings, like let's say number of concurrent requests, etc., so which is available in next slide. But this is what Azure Signaler is like. It is a service which you can create it in the cloud, and you can consume it, and it will have an connection string. Using connection string, you can stay connected with this Azure Signaler service. And this is the pricing tier. So let's say we have two tiers, free and standard. So in free tier, like you can have 20 concurrent connections, and standard you can have 1,000 concurrent connections. And messages, like in free you can send 20,000, in standard it's unlimited. And price, like in free it's a yeah, it's kind of free tier. In standard, like it has around 119 rupees for now, and max units is 1, and standard is 100. So this is the cost as far as in the Microsoft documentation. Like we have a free and standard tiers. Like if you are going for any enterprise application, you can go for standard tier, and you can go for serverless mode, which will be very much helpful. So in free tier, like you can do it for your experimenting purpose. So that's it, guys. So those are very small slides I had. Like we saw what is Signaler, and why we need Azure Signaler, etc. So now, like, we'll build a real-time dashboard using these using Azure Signaler, and also in the front end I'm going to use Angular for it. So I'm going to I just have an UI which has its dashboard, etc. So the architecture of this application will be looking something like this. So we are going to have a setup, like let's say here, like we have this Signaler service, and we are going to have two Azure functions. So one is messages, and second one is negotiate. And we have this Angular application in the front end. So we have two functions, messages and negotiate. So what does negotiate function do? So basically, these two functions will be created in a function app which contains this Signaler service connection string. And this negotiate function, what does this do is it does an initial handshake. So when a service call is made to this respective function, it returns the Signaler service info. What info is, like, it contains the respective key and the Signaler URL. So that initial handshake will be done in an Azure function, negotiate. So once this handshake is done, that's it. Like, we'll be connected to the Angular client and the Signaler service, and the messages will be flowing through it. So that's it. So I'm going to repeat it. Like first we'll have a Signaler service. It will contain its own connection string, and we are going to have two Azure functions. One is negotiate and messages. Negotiate, like, it's a kind of an function which returns me the Signaler credentials, I would say, like its URL and an API access key, and we can establish an initial handshake using this Azure function. And once this is connected, we'll have this messages Azure function, and we can just send the messages in the hub, and it will be a kind of bi-directional communication between different clients at the same time. So I hope you understood this concept. So I'll go to the Azure portal, and we'll see how you can create Signaler service and Azure functions, etc. So okay. So I hope you can see my Azure portal. So here to create a resource, like you can just click create a resource, and you can search for Signaler, and you can just click create, and you can just mention your subscription and resource group name and unit count and service mode. So this is what I mentioned, like the mode serverless and classic, and the pricing tier you can take it as free and standard. For enterprise, please go for standard. And once you fill out these details and click create, your Signaler service will be created. So I already created a service, so let me show you that. So this is my test demo Signaler service. So once you create it, this is the landing page of Signaler service. to get the connection string, like there'll be a left hand side, there'll be a thing called connection strings. If you click on it, there'll be a connection string for access key and for managed identity and for AD applications. So you can click copy, and so this is the Signaler service. So that's it. Like, just you can create a Signal service within just 1 minute. And once this is done, you have to create a function app, because a function app will consist of the Azure functions. So I already have created a function app. So it's the same thing, guys. Like, just search for function app, and you can click create, and just you have to mention the details. So that's it. So just mention the resource group and app name, and region, version, etc. So I already have created a function app. In this function app, as I mentioned earlier, I have two functions. So one is message and the other one is negotiate. So the negotiate Azure function, if I go to the slide, the negotiate Azure function will be useful to get an initial handshake from the client and the from the signaler. So what does this negotiate Azure function contain? So let me go to Visual Studio. So here I have a function app which is called as message project called message publisher, and here I have two functions, negotiate and message. So what does this negotiate contain? So it's very simple, just one line of code. So it has a signaler connection which takes as an parameter, and the hub name is broadcast. So signaler connection, it has an hub which is named as broadcast, and it sends just the connection info. So this function just returns me the connection info. That's it. So nothing much complex in this code. So this Azure function has a logic which just returns me the signaler connection info. So now you may have a question like how this function will be aware of this signaler connection. So that's where in this function app we are going to see okay. So let me go to that option, access control function app keys. Okay, just a minute, please. Okay, so basically, so I was searching for another option, but I'll show it in this Visual Studio. So basically, you'll have this local settings.json in your respective Azure function app project. So in this function, like you just have to mention the Azure Signaler connection string. So that's it. So which you can get it from portal. So as I mentioned earlier, so this is your Azure Signal service. Just copy it, copy this string, and just mention it in your local settings.json. So just mention this Azure Signaler connection string, and yeah, and most probably you are good to go. So that's it. So that's how you establish a connection between Azure Signaler and the function app. So this negotiate function will take care of sending the Signaler connection info. And what does this message? So once the connection is established, so what does this message function do? So this message function, it just it just send the message to the signaler. So it has a target, and it sends the request body what's being sent to this respective Azure function. So this Azure function has a parameter called request, and this request will have a body. So you can send any message or any model or anything you want to share between all the clients. So that's what you need to send it to this respective Azure function. And when you send it, it's just send the message to that respective signaler, and this message will be picked up in the front end Angular application. We'll see how we can do it. This will be messaged in the front end, and it will be processed in Angular application. So it's just two simple piece of code. So one is negotiate, which will return me the signaler connection info, and the next one is the message Azure function, which helps me to publish message to all the clients. Okay, so you can just click and publish from Visual Studio itself, or you can directly create functions from portal, and you can just copy paste code. So that's it, guys. So it's very simple. Create a SignalR service and create two Azure functions, negotiate and message. So now we go to the front end part, where I'm going to Visual Studio. So I have simple app comp. So this is Angular application. So I'm using Angular 12 for this demo, and I have some libraries called can do charts. So I'm using can do charts to build some dashboard kind of stuff. And if I go to app, so first I'll go for Signal. So I have a service file in which I have two methods which has get connection info and send message. So this get connection info will call the negotiate Azure function, which will establish a connection between the client and the Azure SignalR service. And the next thing is the send message. Send message will send a message to the respective message Azure function. The Azure function will publish that function to all the clients. So these two methods are the very two important methods in our application. So I have a separate service for it. And if I go to app component.ts, so just ignore all this code. I'm just going to explain this one. So what I'm doing is I'm just initially getting the get connection info. Initially, I'm getting a connection info for getting the access token. So it will return me the access token, which helps me to access the respective SignalR service from my Angular application. Okay, and I have this access token, and I'm going to build a SignalR hub connection using this just 3 lines of code. I'm just sending the response.url. So this response contains the SignalR service URL, and in the options we have this access token. So once these things are sent, this hub connection, it will establish a connection, basically a SignalR connection. So when I run this code, what happens is the respective client will be connected to that respective SignalR service. Okay, and then like I have some random code, like it says when once the hub connection is started. So I have a chart data. Okay, so I have some chart data with some predefined number. So I have a line chart. And if I go to component.html, okay, so let me go below. So this is my chart, guys. So it's very simple. It has some can do chart series, and it takes the chart data as an input to the series item component. So I have some initial values, and what my logic, what I am saying is, while this connection, unless and until it's connected, just run this loop and get some random number and send it to the respective send it to respective message Azure function. Okay, so what does this do is, like, it will create an random number, and it will send that message to the respective Azure function, message Azure function. And what this Azure function will do is it will establish that message to all the SignalR clients. So very simple. And so once this message is sent, like, you have to receive it, right? For receiving it, this is the method. So this dot hub connection dot on notify. So what this notify is, like, if I go to Visual Studio, so here we have a target string, right? Notify. So this is what you have to mention it in front end, notify. And this data consists of this request. Okay, so this data consists of this request, and I'm just getting the data, and I'm just pushing it in the chart data, and I'm just adding some random numbers into that chart data, which will look like the graph will reflect automatically without refreshing the page. So it's very simple code. I hope you understood it. Like, if you have any doubts, just let me know. So let me just show you this application. Okay, so localhost 4200. Okay, so this is my application. So as you see, like, the value of the line chart, so I'm not doing any refresh, right? So the values, it is being it's kind of an real time, so I don't need to refresh the dashboard. So let me open another client. I'll go to Chrome, and I'll say localhost 4200. Okay, so let me just refresh the page by saving this. So as you can see, I have two different clients, and you can see that the graph is being loaded in real time. So you can connect as much clients as you want. So I'm not doing any refresh, and the dashboard is being loaded automatically. So this has helped the Azure Signaler. You can also do it with the help of Signaler package libraries, which is available in .NET Core and .NET Framework. So the main key I want to mention is like the architecture of this application. Like you have to create two functions. So one is negotiate and message. Negotiate will create an handshake between the client and the Signaler service. So once it is done, just send the message to this Azure function, which takes care of publishing that message to the respective clients. So it's very simple demo. So soon, like, you can expect a blog in my blog site, and if you have any doubts, you can raise it in the comments. And in this YouTube video also, like, if you have any comments later, those who are watching it later, if you have any doubts, just raise it in the comments. Like, I'm happy to answer it. And yeah, and I think those are all the points I had. And thanks to all the title sponsors and learning partners and all the communities for helping us to make this AZConf going good. And we still have one more day, and stay tuned for all the technical sessions, guys. And thanks everyone. So these are my handles: Twitter handle ngsuas, and my LinkedIn is Suhas Parameshwara. And I also write blogs at devsuhas.com and techme360.com. And I'm also a co-organizer of these two meetups, TechMe360 and Talkify and NG Kerala. Okay, so all right, guys. So thanks everyone. So thanks for joining, and stay safe. And thanks, Elias. Thanks for the opportunity.
Thank you so much, Hoss. It was a great session on this topic.
Yeah.
So next up, yeah, I don't see much questions. So if there's any question, people would reach out to you.
Sure.
I appreciate that. All right, thanks everyone. And next up, we have Hassan joining us on the topic of Cosmos DB. In a minute from now, Hassan would be online, and we can get started with that. Hey, good morning, Hassan. Looks
Good
like
morning.
it's
How are you?
We're good. How are you?
Good. Good. Thank you very much.
All right. Okay. So we have a wonderful topic from Sauron that is going to talk about what's happening under Cosmos DB. So it's a interesting topic. It's a scalable, globally scalable and distributed database. Let's understand from Sauron what's underneath and what's under the hood.
Yep. Thanks for having me. I can jump in if you want.
Please go ahead, Hassan.
All right. All right. Thanks again, everybody, for having me and coming to my session today. I'm going to speak about, as Ilya say, I'm going to speak about the Cosmos DB with you today. Cosmos DB is really kind of like a black box when it comes to like backend, because it's managed by Microsoft and you don't really know what's happening in the backend. So in this application, in this presentation, I'm going to try to explain some of the, I guess, unknown stuff, or maybe you are curious about some of the items. I'm going to try to explain them here. My name is Hassan Savran, and I'm a data platform MVP. That's my third year, and I'm from Cleveland, Ohio. So this is going to be a lightning talk, so I'm just going to jump in and start actually the presentation. First, I want to actually talk about here is Azure itself. So as you can see here, that's Azure infrastructure. And what you really care, a lot going on in this map here. The blue items are the data centers, the current data centers that you can actually run your services in. The purple ones out there are the ones, the data centers that coming up. So there are 17 new data centers coming up, and 3 of them is going to be in America, 7 of them is going to be Europe, 2 in Middle East, and 5 in Asia. So whenever you try to create any kind of service in Azure, the first thing probably you hear that you should pick the data center close to your users. That applies especially to databases. But the first thing you kind of need to remember that well, those users are going to come from a web server. They're going to come from their personal computer. So you want to be sure that you put the web server and your database in the same data center, so there won't latency between them that much. Also, Cosmos DB actually born in this structure, so it's very easy to kind of scale up and scale down with Azure. And as Azure grows, Cosmos DB easily. Many other databases, they are still trying to well, they bought to Azure long time ago, and they go back to the cloud systems. Cosmos DB is not like that. So let's actually try to go and understand a little bit more about the Cosmos DB. The first thing you need to understand about the backend is the physical partitions in Cosmos DB. I really compare the physical partitions to container ships, and there is no really related to container, I guess, technologies, just literally container ship. Whenever you create any kind of database in Cosmos DB gives you this empty container ship. There are 2 things that you need to know, 2 numbers you need to know about this container ship. The first one is it can carry 50 gigabyte data. The second one is the horsepower, which is it can go up to 10,000 request units. So for any reason, if you will have more than 50 gig data, or you're going to need more horsepower than 10,000 request units, Cosmos DB is going to give you another empty container ship. So those are the 2 numbers that you should know by heart if you are using the Cosmos DB. Now, the other thing we know about the physical partitions, all the data is actually getting saved in the local SSD, the disks. So we know that the latency is pretty good with that. The number of the physical partition is going to really depend on how much data you have. And when you start to have actually more physical partitions, then you really need to watch those numbers very closely. Because small problems can become big problems easily when you have too much data or too much horsepower you need. Physical partitions, there's really nothing you can do with it. There's no setting for you that you can go and change anything on them. So Microsoft is actually managing it totally. So if you go a little bit deeper than that, physical partition, actually, when you open that, it looks like a replica set. So you have a leader and you have 3 followers. Summary, you have 4 copies of your application, of your database. So if you have the web application here trying to access your data, potentially it has 4 options to go and get the data. That's one of the main reasons that Cosmos DB is really fast, because we have options to get the data. This model here, you see in the bottom, it says without global distribution. So if you don't need to worry about, distribute your data this is going to be it. The data is going to come to the leader. Leader is going to sync that with the followers, and the data is going to be same. So web application can get the data from anywhere. So if you are going to have other data centers, and if you're going to turn on the global distribution, then this model is going to change a little bit. The first thing is going to change. You're going to see that one of the followers here is actually turning into forwarder. What is really going to happen here is, let's say this is our web application, and it's going to send some kind of update, delete, or insert, right? It's going to go to region 1, and the leader is going to get that signal, get the data, sync it with the followers and the forwarder. And the forwarder is going to actually move that data to other leaders. Doesn't matter how many you have. That's how the data is going to get actually sync in the backend. So one of the main reasons that you want to kind of watch the physical partitions is really if you are having like any hot partitioning problems or anything like that, you want to be sure that which one is actually causing the problem, and you want to catch that before it becomes a bigger problem. And because when it becomes a bigger problem, well, it's a bigger problem to solve. So you should kind of always watch the physical partitions. The place that you can actually watch them, you can go to the Azure Cosmos DB, the portal, and in the under monitoring, we have this metrics link. When you click on it, you are going to actually click here the storage on the top. Then you're going to pick your database and your container. Then all this information is going to be available in the bottom. Really, the number of physical partition is actually, this chart is showing to you. In this example, I have 3 physical partitions. And in the right side, it tells you that our partition key is a food group, and those are the partition key which are larger than other partition keys. So you want to kind of watch those, how many you have. It's okay to have, I guess, like 1, 2, as long as they are too big, but you want to be sure that all of those partition keys should be very close to each other, because it looks like this one has the largest one, and you don't want like one like close to here, the other one is going to be in the bottom. That kind of shows you that there's a lot of data in that one, and because of the partition key, maybe all the data is actually going to that partition and the other one is empty or close to empty. So you want to be sure that you kind of watch this. And I guess if there's a problem, this will be the first place that actually kind of, I guess, gives you a red flag. So this was the physical partition. If you go to the other partitions, which is the logical partition, that is the one actually you have some control of. Partition key here, which is you actually give to Cosmos DB to create the Cosmos DB containers, and the database is the logical partitions. Logical partition key distributes the request, it distributes the storage, and it intelligently routes the queries for efficiency. So it's pretty important that you pick the right partition key for this. Now, if we compare Cosmos DB with the SQL Server, in SQL Server, usually, you're a dev, you create your table, you give it to DBA, and DBA just looks at it and, puts in the production, right? So your application goes to production. After probably 5-6 months, you figure out that your queries are kind of slowing down. So you go to your DBA, you ask them, like everything was fine, and this thing is kind of slowing down. What's happening? DBA actually goes to your, database and figures out that you need some indexes. He or she creates some indexes, and everything goes back to normal. Probably another 2-3 years passes, then you see that your database level is kind of getting slowed down again. So you go to your DBA, and then your DBA probably is going to say that, you have too much data. I think you are ready for partitions. He creates some kind of partitions in SQL Server, and as long as you use the partition key in SQL Server, then everything goes back to fast. Now, if you compare the Cosmos DB actually wants the partition key in the beginning, not at the end. So that's one of the main reasons that you really need to kind of study your data. You want to be sure that whatever partition key you're going to pick is going to distribute the data equally. That is a challenge in Cosmos DB, because at least in SQL Server, you already have the data. You can look at the data and try to figure out what is the best way I can partition this data. But in Cosmos DB, you have to do it in the beginning. So just don't be, I guess, in rush and try to find a good one that which is going to actually distribute the data equally. That would be the, I guess, best suggestion I can give you with that. Really, logical partitions about organizing the data. So if anything is organized, it's very easy to find whatever you are looking for. So in this case, for example, those containers are going to be the logical partitions of that container ship that I'm going to actually show you here. So container ship is the physical partition, and the logical partitions are the containers on it. So it is your responsibility to organize this container ship. And a number you need to know when it comes to those logical partitions, the largest size is the 20 gig. So you cannot have larger than 20 gig logical partition. But now, if you remember, the container ship's limit was 50. Now, we are saying that each container, the max, it can hit the 20 gig. So really we are saying is you can probably have maximum 2 container ships if you will actually hit that limit on that container ship. I've never seen a container ship like that, which is actually carrying 2 huge containers. The main reason is, well, it's not going to be easy to find what you are looking for if you have 2 big containers in it, right? So you open the container and it's going to be all over the place. That who knows what's in it. So for SQL, I mean, for Cosmos DB engine, it's not going to be easy. If those containers going to be larger, still it's not going to be easy for it to find the data you are looking for, to update or read or change. For example, let's say if we are creating a IoT application for cars, right? So in that case, the best thing, I mean, you can organize this in many ways. You can organize by color of the car, you can organize by the year of the car, or anything about the car, maybe model of the car. But when you are doing things like that, that means you are going to put multiple cars in each partition. So whenever you try to update, delete, or read data, then after you open that container, there's going to be a bunch of other cars in it. So you're going to use more CPU, you're going to use more memory to actually find what you are looking for. So it's going to make more sense if you can actually put 1 car in each container here. In that case, probably that's going to be the VIN number that you're going to use for the partition key. And as long as you have the VIN number in your queries you are sending, it's going to be much easier for Cosmos DB to find where this car is. It can find very easily which physical partition this one is in and which container is in. And as long as you can make that process easy, that means your bill is going to be cheaper. It's going to be more affordable. So that's why the partition key is very important when it comes to the Cosmos DB. Now, I want to go back to physical partition one more time, because this one is pretty important too. Many people learn that in hard way. So let's say we have an application, and our application request unit is 9,000. So if you remember, one of the numbers physical partition is the 10,000. Let's say we are going to have a big sale next day, and we want to be sure that our application is going to actually handle this. So we're going to say, okay, you know what? I know it might handle, but I'm going to go and actually, just to be safe, I'm going to scale up and maybe put out there 12,000 request units. Now, as soon as you do that, you change it to 12,000, you're going to have 2 physical partitions, right? So really, you're ending up with 2 container ship. Each of them is not going to have 12,000 because your total resource is 12,000. So Cosmos DB is going to actually divide that to 2. If you have 3, it will actually divide it to 3. If you partition this correctly, this should not be a problem. But if you have a huge container in here, which might take almost like 4,000, 5,000 request units because everybody's going and try to buy or change that data, then you're going to have actually a problem. You try to fix a problem, but actually you find yourself in a bigger problem, because at least this used to be 9,000 before, now actually it's 6,000. So this can be really a big deal, as I said before, when your data is getting larger, when your application is getting larger, and when you start to scale up, you will be in a lot of trouble with if you don't pick the right partition key, and this won't be easy to solve later. So you want to catch those problems early. All right, so if we look at Cosmos DB, So whenever you create the feature, the service is pretty easy. You just pick the subscription, you give a name for it, and your service is ready just like any other Azure features. After you create a database in Cosmos DB, or when you are creating a database in Cosmos DB, the first thing you need to answer or decide is which API you're going to pick. Now, if you compare again to SQL Server, in SQL Server you have one API, which is the T-SQL. Now, some people can argue on that, but it supports XML, it supports JSON, it supports many other things. The problem is you need to know T-SQL to be able to use those features. In Cosmos DB, that's not the case. So if you have a MongoDB application already running here, and if you want to actually move your data to Cosmos DB, you can move your Cosmos DB, all the MongoDB data, it's JSON at the end. Then you can still use your API, which you already developed, which has been connecting to MongoDB. All you have to do is change your connection string, and your MongoDB API is going to think that actually is talking to MongoDB when it's talking to Cosmos DB. So the code change is going to be probably little, maybe none. And there are going to be many ways to actually get your data in different languages, thanks to multi-API in Cosmos DB. After you pick any of these, if you are creating a new application, I will suggest you that you pick SQL one, because that's the one that actually Microsoft is on, and most of the new features actually come in the SQL. The rest of them is those are just the protocols from the other databases, and Cosmos. I mean, Microsoft doesn't really have that much control on them. Now, whenever you pick any of those, you are going to end up with a container. Containers is just like, I guess you can compare them to tables in SQL Server. That's where all your data is going to be. And depending which API you pick, the name of the container might be a little bit different, or the item's going to be in the different. For example, if you pick the SQL, you're going to call the data documents. If you're going to pick table, probably the data is going to be the rows. Gremlin, I think, is going to be the nodes and edges. So depending which API you are picking, I guess terms might be a little bit different. But at the end, container is the place that you're going to keep the data in. Now, things get a little bit more, I guess, tricky under container. So each container is going to have store procedures. I guess the things about the know store procedures, first of all, you have to know JavaScript. All the store procedures are written in JavaScript. Also, another thing to remind you in store procedures is store procedures are good for writing data, not reading data in Cosmos DB. The main reason for that is, if you remember, I showed you that replica set, there's a leader and 3 followers. Store procedures always runs and executes in leaders. They will never execute in the followers. What that means is leader is always busy getting the data to change, writing data, updating data, deleting data. So that makes them, a good place for, writing data for store procedures. If you're going to try to read data, that means that you are forcing leader to actually read data when it has other stuff that it has to do. So if you have store procedures on Cosmos DB, be sure that you are using that for writing data. Next one is the user-defined functions, and that's just like store procedures. It's JavaScript, and UDF is a great way to express complex business logic in a query. Just be sure that whenever you are using them, if you are using them in the where clause, try to, I guess, use other properties whenever you are filtering the data. Because if you will say that, if you will use only the user-defined functions, just like in other databases, you are going to force table scan, and the request is going to be pretty high because it's not going to be able to use any indexes. So just want to be sure that, they are useful, but just don't use them in the where clause. You try to use at least with other properties, or don't try to write your own. If there's another one out there, system user defined functions, try to use them. Next one is the triggers. There are 2 types of triggers in Cosmos DB: pre triggers and post. So really, the biggest difference is when we compare to SQL Server, they do not get trigger automatically. So from the SDK, you need to actually trigger them, so they will run. Merge procedures and conflicts. Merge procedures are really the store procedures, but when I was talking about a conflict can happen, especially in the global distribution. So when that happens, you can actually create a store procedure, and you can register as a merge procedure. So when a conflict happens, that goes in a queue, and Cosmos DB will run your store procedure, which has all your business logic to figure out which data you are going to trust, and then it can figure out which one should stay in the database, which one should be thrown away. So merge procedures and conflicts are for that, and each of those options are for each container, and you cannot write a store procedure which can go and access to different containers. So each are items here for specific for each containers. Now, next one is storage. Storage engine, actually, believe it or not, there are two storage engines in Cosmos DB. Many people really don't know that. The first one is, which ones everybody know. So whenever your application use any of those APIs, we are using the transactional storage. And all the data is getting saved as raw store here. So, well, when you say raw store, that kind of applies to, I guess, the relational database. So in Cosmos DB, you are really saving JSON by JSON. Usually, whenever you are getting the data, usually you have the key, hopefully. If you have the key, you know exactly which JSON file to pick. So it's pretty easy to find what you are looking for if you have the key in this model. If you are trying to select hundreds, thousands, JSON files here, that means that you might be doing something wrong here, because you are in an operational database, and you shouldn't really try to analyze or write a report in operational database. That applies to any database, not just Cosmos DB. If you're going to do that, well, it's gonna cost you a lot, and probably that's one of the main reasons many people says that, oh, Cosmos DB is expensive. Well, if you are going to hit and try to run your data science project in Cosmos DB database, that's going to be expensive. So to actually solve this problem, Cosmos DB came up with this analytical storage. So what you can do here is you can enable the Azure Synapse link in your database. And as soon as actually you do that, Cosmos DB is going to start to actually move your data automatically to a different environment. And it's going to save the data differently too. So this is great, because if you really think about, probably many of you have the SQL Server environments, you have the operational, you have the reporting, right? So you kind of move the data to reporting sites by, I'm guessing, maybe ETL or something like that. So if you need to write a report, you need to get from this database. Your web application is still using that, so there's going to be no logs or anything like that. So same idea here, but the best thing is you don't need to write ETL. Actually, Cosmos DB does this for you. And this creates a great isolation between two environments, and also analytical storage is going to be much cheaper for you to get this hundreds, thousands, millions of data than if you hit to the main database. So this is great for if you have a data science data science projects, analytics reports. So you can use the Synapse Spark or the SQL to get this data, and everything's going to be synced automatically, and the data is going to get actually saved as column store, which means that the data is going to get saved by property. So if you are looking, for example, average, let's say we have an age in our schema, so all the ages are going to get saved one by one here. And if you are looking for average, it's going to be easy to find all the ages, because they are going to get saved in the same area. It's going to be much easier, and it's going to be much cheaper to actually find that data and aggregate it. All right, next. So this is actually on a flat screen. You can see the whole picture of Azure here. The yellow ones are the current ones, orange ones are the new ones coming up. So, most of the, whenever even I talk about it, we always talk about these big projects that Cosmos DB is getting used. But really, you don't have to be this large application, large company to use the Cosmos DB. We have airlines, healthcare, education. There's all kind of projects going on out there, and you really don't need to be like one of those, top 100 companies in your country to use the Cosmos DB, because at the end, everybody wants the same thing, right? You want a scalable application. You want availability to be high. If you are going to get larger, if you're going to be a company later, you want to be sure that you can scale up easily. So those are actually Cosmos DB can deliver you very easily. And especially in these days with the COVID, everything is online, and doesn't matter with what industry you need, how you are in right now, you need those things from a database. And whenever you might say that, what, I'm going to use Cosmos DB, if you're asking your friends or, some other people, you might get this, I guess, feedback. Well, you're going to save this data in unstructured JSON. Are you crazy? No, you're not crazy. You have been doing this in SQL Server. Maybe you have 20 tables, maybe you have 30 tables, maybe you have 40 tables, and you survive that. There's nothing wrong saving your data as unstructured JSON. As I showed you before, if you want to analyze the data, and if that's your problem for a feature, we have the other database. You can save it as a column store, so you can actually want it. You can do just the way that you were doing in SQL Server in Cosmos DB. So don't let people, I guess, scare you. Cosmos DB can be great for small businesses and middle businesses too. Cosmos DB is a free tier. So if you're a little small business, it might be even free for you. If you actually use it the right way, and if you pick the right partition key, you might be able to actually use the Cosmos DB for free. So don't let people, I guess, scare you. And there's a lot of things going on out there, a lot of new projects coming up, I'm sure. And just, I guess, give Cosmos DB a chance for that, because you'll be happy with all the results it can give you. That is all I have for you, and thank you for coming to my session today. You can reach me from any of those platforms. I have my blog. You can check it out too. Lately, I couldn't write it, but mostly I write about SQL Server, Cosmos DB, C# front end, whatever I know. I'd like to share it out there. You might find something interesting out there. And yeah, thank you for coming to my session today, and hopefully you will have a nice day today. Thank you.
Thank you so much, Sauron. It was great having you. So we are hitting the last session of the day, and thank you so much again. And we are very glad to host you at AZCon 2021, and we look forward to host you in many more such events.
Sure, I will be happy to. Thank you again.
Thanks, and have a great day there.
You too.
Goodbye.
Thank you.
Thanks, everybody. And the next session is going to be the closing note, which you could join in the track 1. If you are, to check the link of track 1, you could go to the event website to get the link. And I will see you in the track 1 in a couple of minutes. Thank you so much.